Welcome to your Nim crash course. In this course, you will be learning everything from the basics of programming in Nim, as well as the basics of programming. So if you are new to Nim or to programming in general, this video should be great for you. And if you're not new to programming, but you're interested in learning Nim, this video should also do you good, because we cover a lot of Nim modules and a lot of complicated Nim topics. Whilst in the video you'll occasionally see there is a Nim 1.6 version. Please note that the video is still completely valid for Nim version 2. If any updates needs to be made, I'll leave it in the comment section below. So feel free to go look there for not only answers, but to ask your questions. And if there are any updates you should be aware of. Now, there may be a couple of other Nim tutorials also on the way. So if you're interested in seeing them, feel free to subscribe and then go check out my channel. Maybe there are other tutorials that interest you as well. And if you would like to support me and what I do, feel free to become a channel member. By becoming a member, you get early access to some of my content, as well as just generally support me making more content in the future. Now, without further ado, please enjoy this Nim crash course. So let's get to installing Nim. Now I am on Linux, but if you are on Windows, you can use Windows. And if you're on Mac, you can use Unix, and I believe this supports FreeBSD as well. Then here you go. If you are on Linux, you can just use curl, but if you don't like curl, there's also this tarball you can use. But if you don't like using tarballs either, you can go check here. There's a bunch of other things you can use here on macOS to actually give you a few extra things. But here on Arch Linux, it says you can just use pacman-s nim. Okay, so you can just use pacman-s nim if you want to install it. Otherwise, you could use choose nim. That's actually the recommended way of doing it, because then you can also switch between different Nim versions. Like let's say one project supports this feature in Nim, but the other doesn't. Then you might want to switch between the versions. But of course, there's also debian/ubuntu where you can use apt-get. There's Docker if you want to use Nim in a Docker container. FreeBSD, macOS, OpenBSD, OpenSUSE, and Void Linux. Now I already have Nim installed, so I'm not going to be using choose nim or pacman-s nim, because as you can see, I already have it installed. Cool. Now before we continue to the actual course, let's take a look here at the documentation. There's a lot of things that will be covered here, because we will actually be doing a lot of the things from the documentation in this course. A lot of people say the Nim documentation is somewhat difficult to understand. I don't find the Nim documentation difficult to understand or read, so I'm going to convert it into bite-sized, easy to understand Nim tutorials, primarily from the standard library. So if there's something you don't understand and it's from the standard library, then you can actually go look here and you'll be able to find it. For example, let's go to the math libraries. So here's a bunch of math libraries. Let's say you want to use random. Go in there, and here's the Nim documentation. Anything you don't understand, you can also read up here. Now, Nim is open source, so if you want to contribute to the Nim community, you could also go to the Nim source code here on GitHub. It's on their website. Just click on the source here, and you'll be able to contribute here. There is a separate Nim community that has made Nim Skull. Basically, it was a few people that didn't really like where Nim was going, and they created their own Nim, fixing up bugs and whatnot. Currently, I'm pretty sure Nim Skull, right here. I'm pretty sure Nim Skull currently is just Nim, but with a few extra fixes and whatnot. You can actually go take a look here, but their website should look, that is the documentation. Yeah, their website should be fairly similar, whatnot. But if you're one of these, you can also go take a look at Nim Skull. But I'm just going to cover normal Nim here. Okay, cool. Now let's create our first Nim program. So I'm going to do this in a GUI in a second. We can go to Documents, tutorials, and I actually already have a nim here, so I'm just going to create a new nim, and then I'm going to do nim, and I'm going to explain this in a second. Now, for those of you who don't have any Linux experience, what I just did is I went into my documents. I have a tuts folder where I have all of my tutorials that I'm teaching, and then here I have a nim folder. So all I did was I went into the nim folder. We can create a new file, and we can call this main.nim. Alright, and then we can open this up in whichever code editor you like. I like using VS Code, so that's what I'm going to use. But of course you can use Sublime Text, Notepad, whatnot. I'm just going to use VS Code. Alright. If you are on Windows, make sure that this doesn't say main.nim.txt. That is something that happens in Windows. If it is saying that, just remove the .txt, so it just says main.nim. Cool. So now we have our first nim file. Now before we get into writing any code, I first want to teach you about comments. A comment is a line of code that does not get executed by the computer. So when you put a line of code there or a piece of text there, you don't necessarily want that to execute. For example, I am cool. In nim, this will cause an error because I am cool is not valid commands. But by putting a hashtag in front of this I am cool, you'll see it becomes this nice greenish color. This means that it is being ignored. It is a comment. But on the next line, you can start typing again. Every time you put a hashtag there, that will be a comment. The comment can also be after a command. So anything after a hashtag, that is a comment. This is a single line comment. You also have multi-line comments, which uses these hashtag and then this bracket, square bracket things. Anything inside of this is a comment. So no matter how far down you go, this will be a comment. Even if you put normal nim code in here, it will not be read by the compiler. And then if you're outside of it again, you can write normal code and it will execute. And then finally, you can also use discard. We'll get later into what discard is. But for now, if you can then create a documentation string like this, and anything inside of this is a comment. Again, outside of it, it's no longer a comment. So these are the 3 ways you can create a comment in Nim. Now let's write our first line of Nim code. Echo hello world. This is amazing. So now here we have like a print statement. If we run this, so we go down here, and take note, you can also open up your terminal from inside of VS Code. These two are exactly the same. This one is just outside of VS Code and looks nice. This one is inside of VS Code and doesn't look nice. So I'm going to use the outside one, but they are both the same. I'm just going to say nim c main.nim. This will compile the program. So let's actually go here. Nim c main.nim. We'll be taking a look at a bunch of these. If you run this, here we'll get a main. This is an executable, so we cannot just read it, but we can execute it. And there we go. Hello world. You also have nim -r c main.nim. This will compile the program and then run it afterwards for you. So you don't have to do it in 2 different steps. You only do it in 1. Run it. It will compile it, but also run it afterwards. You can also do nim-r main.nim. Take note, there's no dash here. It's just nim-r. This will compile it, but it will not compile it to this folder. So if I were to delete this, and I were to run this, it will compile and run this, but you'll see it didn't create an executable here. Be careful when using this, because this is a little bit of a strange method. So some code that you run with this might just not work. We'll get later into why this might not work, but for right now, just take note, this might cause issues. If it does, just instead use this, because it will compile it into this folder and then run this executable. And then finally, we can go nim r -- verbosity. 0 hints off. Now, this is just to show you some of the features that the compiler has. Main.nim. This will turn off all unnecessary messages, so only show the very essential messages that really needs to be shown. As you can see, it doesn't show you all of this. It only shows you this. So that just shows you some of the features you can use with the compiler. You can also use the compiler to compile to JavaScript and C and C++, and we'll later get into actually doing that. But for right now, it is not necessary. We can just continue with Nim. Now, Nim is a very flexible and interesting language. So let's show you a few methods you can use to just echo out a few things, just to print a few things. So here we could say hello.echo world, and we'll get into why this is actually valid Nim code in a later tutorial, but it is very interesting. So now if we were to say nim or main.nim, we get hello world from both of these echoes, but this one just looks a little bit different. You can also go echo hello world, or if you wanted to, you could just continue with this, say hello world, but then just say .echo. So this is just because Nim is so flexible, so you'll see all of them show hello world. And then finally, this one is not an echo, but you can use the standard output to also write things to the terminal if you want to. So write into the standard output hello world. Take note, you don't need any semicolons, as you can see here. Do that, and there we go, we get hello world. If you also want a new line, you can just go \n, and now run it. There we go. Okay, so that's just a few ways you can do hello world in Nim. Just a little fun fact. So let's first explain what is a data type. A data type is, as it says, it's a type of data. For example, let's say we have a piece of text. Now, the data type of a piece of text is a string, because a string will represent a piece of text. So when I say this value is a string, you will have to know that this value is a piece of text. You also have things like float, and float represents numbers that go like 9.3123, any non-whole numbers. So 3.14159, or even 9.0, that is perfect, or -2.3. So that is an example of a float, and we will be getting deeper into this as we continue with the course as well. You also get int, and int is an integer. It's a whole number. So that's 1, -2, 0, and whatnot. So these two are very similar, but they are quite different. Where float can have floating point values and integers can just be whole numbers. You also get things such as a uint, which we won't be getting too deep into, but let's say an integer has a limited amount of values it can store. Let's say an integer can only store 10. Not really, but let's say they can only store up until 10. Then a uint will be able to store up until 100, as an example. And it's obviously much bigger than this, but the idea still stands. You also have float 64, which has the same concept, but for float. So let's say it can only go 3.1313, but a float 64 might be able to go 1313 again. So it basically doubles the precision you have. But again, we won't be getting too deep into these yet, but this is just to give an around idea. You also have bool, which is a boolean. So this is true, which you can think of as yes, and false, which you can think of as no. So let's say I ask you, are you older than 18? You will say yes, that will be true. Or I can make a statement and say, you have gone to the store today. that statement is either true or false. Yes, I have gone to the store today, or no, I have not. True or false. And we will be getting deeper into that later. And then we also have char. Char is basically like a string, but it can only hold one character. That's all. Now that we know what the basic data types is we can use, let's actually get into what is a variable. A variable is like a little bit of storage we can use. Because let's say we have someone's name, Jack. We don't want to constantly type Jack in like a piece of text or anything like that. We would instead like to store Jack inside a word we can reuse. It's like you have a box and you store a value inside of that box and carry that box around with you, where you can later on use that value when taking it out of the box. To give you a real example, I could say var age is equal to 14. Now we have a variable, which is like a little box, and whenever we use age, we will get this value back. So if I say echo age, and we run this, we get 14. So age here allows us to now reference this number without having to go, oh, but now I have to retype this each time. You just have age. A reason this could be useful is, let's say we have a little bit of a story. Very basic story, but imagine this story was 100,000 lines long. It wasn't just free. 100,000 now, that's a lot. Well, if that was the case, then this here would not be that awesome. We should instead then go name and make it Mike. So then we can go here and say comma name and in that. Now if we were to compile and run this, we will get this. Hello, my name is Mike. I'm 28 years old. I like my name, Mike. It is a cool name. So this still works. All we had to do was add commas here to add these together. But without this, let's say we were to want to change the name Mike to something else. Here we'll have to then change it to Jack, and in here we'll have to go Jack. And for the other 900,000 lines of code that has this, we have to change it manually. But because we have a variable, we just have to change the variable. So here we can just say Jack. And now the name everywhere where we use this variable will change to Jack. There we go, Jack and Jack. We can do the same with age. So var age is equal to 28. Then here we can say, instead of 28, we just say age. We run it. And now the age will also be a variable, and if you ever need to change it again, we only have to change one line. Now we'll get back to this example, so I'm not going to delete this, but I would like to show you more. So now here we can also specify what data type we specifically want this variable to hold by going colon and specifying a data type. Let's say this has to be an int. We say int. Now this variable knows it should be an int, but by default, Nim can actually tell you what type it is without having to do this. However, it is always still recommended to use this to tell it what the data type should be instead of having it infer it automatically. Because by doing this, you're basically saying auto. That means it will automatically figure out that this is a string. But auto is just like invisible, so you don't really use it. But here, as you can see, we specified this should be of type integer. If we were to go string, then we'll actually get an error here because 28 is not a string, it's a number. To make it a string, you should put it inside of double quotes. So that's also how you can specify what specific data type it has to be. Take note, because of this, we cannot later on change the data type of something. So we can say age is equal to this. Because age is of type int, not of type string. So if we try to reassign this, it won't be allowed because this is a string. You could reassign it by putting the right data type there. So now age will be 34. Now we can actually go here and we can do this. And we can just say age. There we go. And we can just make this 29. So now, not only will this age update, thanks to our reassigning here. So there, 29, and here it is 28. But it also makes it easier to manage the story, because now age will always be 29. And we will always be sure that age is of type integer, because age has been set to always be an integer. Same with name. Name will always be a string. And this makes telling this story 20 times easier. Now, just a note, if you want to work with chars, then you'll have to use single quotes. Like that. Chars do not use double quotes. Strings use double quotes. Now, take note that Nim has a few weird quirks when it comes to creating variables. For example, variable my var, and we just say hello. Now this is snake case. Generally in programming, snake case is used with an underscore, so splitting words with underscore. However, in Nim, they ignore the underscore as well as the casing. So if we go var, or if we actually go here and echo my var, as well as echo my var, as well as echo my var, like this, you'll actually notice if we were to run this, we get hello from all three of these my vars. It's a weird quirk in Nim, but basically underscores doesn't matter. Camel case doesn't matter. The only case that really does matter is Pascal case, because my var, this is not the same as any of these. So if I were to compile and run this, we'll actually get an error, because this is undeclared. My var is not the same. So if the first case is a capital letter, then we know it's different from the rest here. It's a little quirk you should be familiar with. But basically with variables, the casing doesn't matter, except for the very first character. If it's uppercase, it's a different variable. Now let's take a look at a few more cool quirks here. Let's say we have a bunch of variables. So let's actually make it easier on ourselves. Say var x is equal to 10, var y is equal to 29, var z is equal to s, var a is equal to satsta. Okay. Let's say we have all of these variables. Now we are already declaring a variables a lot. So one thing we can do that is very nice of them is we can just indent like this. Now all of these will be part of the variable. So all of them will work as normal variables. The only difference is we don't have to specify var in front of each of them. Instead, we just indent it. Take note, I'm indenting it. I pressed tab, but you could also just like use a space. That's fine as well. But I pressed tab. So I indented it so it's all in here. You'll notice a lot of Nim is similar to Python in terms of its indentation. Basically, Nim prefers indentation above like brackets and stuff. Anyhow, so all of these are valid ways to declare a variable. And you can still say int, that's perfectly fine. Here you can still say string. It's the same, just now you don't have to specify var each and every time. Now let's take a moment to talk about const. So a const is a constant value, meaning it will never change. If we say var x is equal to 10, and then we say x is equal to 19, we echo x, Nim won't care about this. They'll be perfectly fine with us changing x into something else, so now it's 19. However, let's say we were to say const. If we were to say const x, this will not be allowed, because once you've set x, you cannot change x. So then it has to be this value forever. And of course, it has the same quirks where if you go like this, you can declare multiple at a time. However, we should take note that let's go like this. Let's create a variable z is equal to 99. We cannot do this. X is equal to z. The reason for it is constants are set during compile time. Once you compile your program, the constant should be set. Now this means that things like variables, which does not have a value during compile time, cannot be used in this scenario because this doesn't have a value during compile time. In cases such as this, you can instead use let. Let is also a constant. However, let specifically doesn't need a value once the program compiles. So, if we print out x here, it will work perfectly fine. But if let was instead const, then it won't work because cannot evaluate at compile time z. Because as far as they know, z will become 12. They don't know that because how will they know? But with let, you can do that. But as I said, let is the same as const, just one needs to have a value during compile time. So if we say x is equal to 9 here, or just normal 9 there, we'll still get an error because you cannot assign it to x because it is a constant value. So const and let are the same. The main difference is let can have a value or can have a value that's not determined at compile time, where const needs a value that is set. So you can do something such as const x is equal to 2 and then say y is equal to x. This is fine because x has a value during compile time. So x will also have a value here during compile time, so y will also. This is allowed. But let p is equal to 9, you cannot do this. Because again, let does not have a value during compile time. Same as var. Only difference is var can be changed, let cannot be changed. Const is the same as let, but it needs to have a value during compile time. If you're wondering which to use, I always just use let, unless I need to change the variable later, then I use var. Because it is recommended to use let wherever possible, because that is a constant. Now the reason why there is two type of constants, const and let, is because of compile time, compiling, which means const is actually faster than let, because we know the value and we can basically hard code it. Where let is a little bit slower because we don't know the value. It can be any value, so that needs to be determined at a later stage. Because for all we know, we can get user input and store it inside of let. So that needs to be used during runtime and not compile time. Also, one more thing before we finish off this course or this tutorial. I told you that if you have something such as my var, let's make that 9, it is the same as my var and my var and whatnot, as long as the first letter here is not a capital case. Now it is still recommended to always use this. If you're using snake case, just use snake case. If you're using camel case, just use camel case. But there's also one thing you can do. I wouldn't necessarily recommend it, but you could go in these little quotation marks here, my var. Now this is allowed and it will be converted into this. So if we run it, we won't get any issues. I would not necessarily recommend it, but if you prefer to declare your variables in multiple words, then you can. My var is cool. And now we can go my var is cool and my var is cool. Run it. will still work. I wouldn't recommend this, but you can if you want to, if you don't want to use snake case or camel case. Now let's declare a few variables. Var first, which is equal to hello, and var second, which is equal to world. Now a recap from the previous video is a string is anything in double quotes, any piece of text in double quotes. This can even be numbers if you wanted to, but if it's in double quotes, it's a string. Now let's go through a few cool things we can do with strings. Like let's say we want to add these two strings together. Then we can go full is equal to first and name. This will append two strings to each other. So if we were to go echo full, and my bad, it's not first and name, it's first and second. Anyhow, if we were to run this, we'll get hello world. So you can use this and symbol here to add together. In the previous video, we did it here in echo by just using commas, because echo is a function, so we can do this. And I'll show you later on why. But right now we don't need to focus on functions. Now we can also get the first letter inside of a string by using indexing. So here we'll start at index 0, which would be hello. Let's actually just use first, so we can have an idea of how it looks. So here we go, hello. At index 0, we will get H. That's the first index. Indexing always starts at 0 in Nim, not 1. In some languages such as Lua, you will start at 1. But in Nim, it's always 0. If you run this, you get H right there. If we were to say 1, we will get E, because hello. And if we were to say second here instead of first, we'll get O, because O is at index 1, while W is at index 0. So there we go, O. And of course, if we were to say full, we'll get E, because full is hello world. So we'll just get E. You can get a specific word from it as well by using indexes to cut out a piece of a string. For example, 3.6. Now if we were to run this, we'll get LO space W, because 0, 1, 2, 3. So we start here at this L. And then we say we want to go up until 6. So 3, 4, 5, and then 6. So we basically got this whole part. This is not one word, but we could make it one word. So if we were to just say hello world, we were to go like that, because that's anyways what is inside of full. But if we were to go, it just got this. So from index 3 to index 6. You could also do something such as full.low, and this will return the lowest index in a string. In this case, it will be H. So it's basically index 0. That's what we just said here. You also can do full.high, and this will return the highest, aka the last index in a string. So D, because D is the last item in the string. Now we have this method where if we go full and then we do this, then we have a new variable. But what if we wanted to change this variable? Well, then we could just have gone first dot add second. So now first will be hello world, because we added the second variable to it. So this is the same as what we did with full, but this time it just modified the existing variable and added this piece of text to it. We could even go here and say Mike instead. So now first will be hello Mike right there. So this is if you want to add to an existing piece of text. Take note, if this was let, it will not be allowed because let is constant. Cool. Let's say we want to get the length of this string. Well, there you can just say .len. This will get the length. If you run it, we'll get 6. You can also add brackets here to specify that this is a function. And Nim has very interesting function features, so you can also do this. It's the same as with echo. And you can also do this. And we'll later on get to why this is actually valid Nim code. But for now, you can just note you can do all of this. It's up to you which you prefer. I generally prefer to do this. You can also resize a string. So let's actually have two echoes here, one that has the actual string and one that has the length of the string. We can say first dot set length, and we can set it to, let's say, 3. If we were to run this, we'll get hell and 3 because we set the length of this string to only 3 characters, meaning only the first 3 characters can actually be in the string. Let's take a look at escape characters. Now, escape characters is basically characters that can escape from a string. For example, let's say we have first line, second line. Now we have this piece of string, but if we were to run this, we'll get first line and second line on one line. A way we can negate this is by going like this, saying first line, echo, second line. But there's sometimes cases where this cannot be done, where you can't just go to the next line and say second line. And you'll see what those cases are the more you code. So in cases like that, we can use \n, which is an escape character, meaning new line. So if we do this, we'll get first and on second line, second. You also have things such as \t, which means tab. So it will add a tab between first and line. We can add another tab there if we want. Now it'll be double tabbed. And you can also have things such as \\, which will add a backslash, because you can't just add a backslash like that. This is for escaping. But if you add \\, then it will be able to add a backslash in your text. So second \/ line. Or let's even say you want to go echo Seri, and Seri said, I am cool. Now this is an issue because these will escape each other. This string ends here, then we have a piece of text, and then there's a new string. As you can see, this will cause an issue because identifier expected but found that. So you have to escape these quotation marks by going \. Now it won't have any issues. Now you have double quotes inside of your double quotes. You can also do it with single quotes if you want. And there are tons of other types of special characters you can use. I would actually just recommend you maybe go read up on it on your own time. Or once you need it, you can just go, oh, I might need to use a special character for this. Now let's say you need to see these special characters. Well, then you can use R, and this will escape all of your escape characters. So now if we were to run this, you'll see \t\t\n. This is a raw string. But what if you had this? Because now your backslashes doesn't work anymore. Well, in this case, what you can do is you can just double the amount of them. So you go like that. And this will actually escape them. Because in this case, you need to escape them, but you can't. So now it will work. But if you were to use backslashes, since they are being escaped by R, you'll get this, an error. But if you use multiple quotation marks here, so you're basically doubling them, then it will work. Just something you might want to take note of if you write code in them. Now, Nim also has much more features we can take a look at. For example, let's import something from Nim. Import str format. And this will allow us to do a lot more in Nim. So let's say we have a few variables. Now this will allow us to basically format our strings much easier. Because before we had to go echo my name is, and then we have to go out of our way and do this, and then say name, and I am, and now again, age, years old, and like to eat. And again, pizza. Now, this is just an example, but it's already somewhat cumbersome. And this isn't pizza, this is food, my bad. I'm just really in the mood for pizza. Okay, so here we go. So now we have my name is, comma, name, and I am, comma, age, years old, and like to eat, comma, food. This works, so if we were to run this, it works. However, it's not really that nice. Primarily because what? You just have to do all of these extra work just to put variables inside of your string. And if you were to use a normal string, you'd have to go like this, and you have to append them such as this. But there's a better way. With string format, we can use ampersand. And now we don't need this. We can just say name in brackets. Same here, we don't need all of this. We just say age. And again here, we don't need all of this. We just say food. And now if we run it, we'll get the same output, but it will be much nicer and easier to read. And all we have to do was add an ampersand here. Take note, this ampersand does come from string format. So you need to import this to use it. You also have FMT, which is actually what Nim recommends you use because it looks neater. And this will work exactly the same. However, it has a little quirk. If you try and use an escape character, it will see it as a raw string and not an escape character. But if you were to use ampersand, then that escape character will be an actual escape character. Personally, I like to use the ampersand more than FMT. Personal preference. But you can choose what you want to use. I just prefer ampersand. So let's first start with a nice Nim quirk that you can have. So let's create a variable, ln, for very long number. And let's say we want to make it 2 billion, which if I'm not mistaken is like 9 zeros. So 1, 2, 3, 1, 2, 3, 1, 2, 3. Now this is incredibly difficult to read. However, in Nim we have a nice feature. Let's say we go here. Yeah, see, I'm already having trouble here. We go like this. In Nim, an underscore does not get read if it's inside of a number like this. So this makes it a ton easier to read. Plus, the value itself will not be different. So here you go. You'll still get the same amount of zeros. But now it's so much easier to see not only how many zeros there are, but just what the actual value is. So yeah, that's just one nice quirk I wanted to show you. Right, let's talk about mathematical operations. 1 plus 7. That will give you 8. Simple as that. Alright, let's go through all of them. I'm not going to sit here forever. Okay, so 1 plus 7. 1 minus 7. 1 times 7. Or actually, let's go here and say 2 times 7 just to get a different value. Times is represented with an asterisk. And let's go 14 divided by 7, which is represented with a forward slash. Take note, a forward slash is not the same as a backward slash. A backslash there, not the same as a forward slash. Div, so let's say we have 15. Let's make both these 15. 15 div, which is the same as divide, but it has a little quirk. You also have things like mod, so 25 mod 4, which is basically modulo. And then you have order of operation, which would be 5 times 2 plus 9, which is not the same as 5 times 2 plus 9 in brackets, order of operations. Now let's get our results and then I'll explain what's going on. So let's start here at the top. 8, that's just plus. -6, that's just minus. 14, that's just times. 15 divided by 7 is 2.1428, and that's just divide. Div is the same as divide, however, it will always return an integer. So these two are the same, but this will return a float, and this will return an integer. To refresh your memory, a float is anything that is not a whole number, so 1.23, whilst an integer is a whole number, so int is like 3, or in this case it would be 1 if we were to make those two. So this is an int, that's a float. Div will return an int, divide will return a float. Cool. Mod is modulus. Now, I'm going to leave that for the end, so let's skip that for now. And in order of operation, we all know in math, you do times first, so basically you have your brackets here, and then you do +9. But by using brackets, you can specify first add these together, then do the times. So yeah, that's just if you wanted to do order of operations. Cool. And now as for modulus, basically, remember when you were like in grade 3 or 2, where you had to do things like 25 divided by 4, and that would be 6.25, right? However, you didn't do this. You didn't do that in like grade 3 or grade 2. Instead, you did 6 res1. Because 4 times 6, that will give you 24. Then you have 1 left before you get to 25. Do you remember this? Basically, modulus is this res1. It's what's left over. So if you say 4 times 6, you'll get 24. And then there's 1 left. There basically is 0.25 there, but it's here. That's what modulus is. So if we were to go 2 and we were to say 3, we'd get 1. Why would we get 1? We'll get 1 because it is going to be 2 and then it's going to go to 4. However, it cannot go to 4 because there's 3 here and it's 3 modulo 2. So it's going to be 2 res 1 and we're going to see this res 1. Let's say we were to say 3 instead, and now we were to say 5. Now it's going to be 1 res 2. So now if we run this, we'll get 2. If we were to make sure that's a comment, we'll get 2. Right, let's talk about typecasting. So here we have x, which is an int, and it is 5. We also have y, which is a float, and that is equal to 10.5. And then we have z, which is a string, and it is equal to 15 in quotation marks. To get the type of a variable, so the data type, we could do something like x.type. Or again, because type is a function, you can say type of x, or in this case, we can actually go y, or even type of z. If we run this, we get int, float, string. That are their data types. To convert an integer to a float, you can use float. So echo float x. That will convert x into a float here. Not the actual variable, but just the output of this float will give you a float value. So x will still be of type integer, but the value we get from this float x here, so if we were to just do this, there we go, will be different. So we run this, as you can see, x is still an int. So it started out as an int and it stayed an int, but the value we got from float is 5.0. So 5 was converted from an integer to a float. And here you can see if we get the value of this output, it will be a float. You can also use .toFloat. Since we already know x itself won't change, we can just go x.toFloat. We'll get 5.0. You can also convert to an integer. So we can say int y, and it will return 10. It will always return this value, no matter what this value here is, but this will always return 10. And of course, you can also say .toInt, and toInt will return the same value. And then to convert a float or an integer to a string, you can just use $. So $x and $y will return a string. If we were to actually use type of $x, then you'll actually see we get a string. So here they won't look any different, but their data type here is a string. So a $x will convert it to a string. For example, let's say we wanted to say, I am, like that. Now you cannot add a number like this. If we were to do this, we'll get an error. Primarily because you cannot add a string and a float. But if you convert y into a string by using $, y itself is a string. So we get this. It works perfectly fine. To convert a string into a float or an integer, you need to import strutils. So now we can just say z.parseInt and z.parseFloat, and this will convert z into an integer and a float. So as you can see, 15 and 15.0 might still look the same, but the difference is z here is now here an integer once it returns here. So we say type z and type z here, we'll get an int and a float. I've said multiple times in the past that user input is one of my most enjoyed parts of programming. It's actually what got me into programming. So let's just jump right in. What is your name, sir? And then we can get the user input and immediately store it inside of a variable. So let's go let name is a string. And here we're using let because we don't want to change the user input later on. If you want to modify the user input in that variable, then you can make this a var. But in our case, we're using let, since why would we want to change the user name? Anyhow, we can then say read line, and from the standard input, stdin. And this will get the user input from the standard input. We can now say echo your name is name. Alright, let's check it out. If we were to say nim or main.nim, what is your name? It is Nick. Your name is Nick. As easy as that. One of the best things about Nim is just how easy a lot of the things are. Now another cool thing that you might want to do is, let's say you want to get someone's date of birth, like their year. Then you could do something such as, when were you born? And here we could do something such as date of birth. And we don't need to specify exactly what type it is. We can get readline standard input, but then we can say parse int. And remember, to use parse int, we need to import strutils. And here we could say you are 2022. Well, it's almost 2023, so let's make that 2023 minus date of birth, years old. There we go. Now we can get someone's age. Now if I were to go here, we could say, when were you born? I was born in 2002. I'm 21 years old. And that would be correct for 2023. Just an example of how you can just modify it with a few extra steps. So here you can get int, so like an integer as user input instead of a string. Because readline will always get a string from user input, whilst parseInt will just convert that string into an int for us. You might want to do some checking here because, of course, if I were to say else, then I'll get an error, but that is for a later tutorial. If statements are used to add logic to your program, you can make your program make decisions. For example, when you go to the store and you're like, should I buy the bar 1 or the lunch bar? That's a choice you have to make. You can even write a program to make that choice for you. And this is where programming really starts to become incredibly powerful. Now I'm not going to cover all of these in a physical manner, so I'm just going to give them all to you right now. So these are all of the type of operations you can do. Larger than, lesser than, larger than equal, lesser than or equal. You also have equal, not equal, and we'll use a few of them to give you an example. And then finally, and, or, not, as well as XOR. And we'll get into what all of these does, except for XOR. This basically returns true if one of the conditions are false and the other is true, which can be useful if you have a scenario for it. Alright, so let's declare a few variables. So we have age is equal to 24, name is equal to Jack, and birthday is equal to true. Cool, so we have an integer age, a string Jack, and a boolean yes or no true. Cool. Now let's say we have a bar. Now let's first say if someone is under the age of 21, they are not allowed to enter this bar. Then we can check if their age is less than 21, then echo you may not enter or enter. So here we're checking if this variable age is less than 21. We could have even put a normal number here like 24. That's perfectly fine. Anyhow, so we're checking is this less than this? If it is, print this. Let's make the age 10 for now. If we run this, we will get you may not enter. But if we were to say 21, because this is only checking for less than 21. So 21 and older is perfectly fine. So if we run this, you'll see we don't get an output. So just by using an if statement, we've told our program to only do something if it meets a specific condition. Now let's say if someone's too old, they're also not allowed to enter. So we can say if age is more than 60. So if they're older than 60, then we should tell them echo you are elderly, may not enter. Cool. So now we have two if statements here. And take note of the indentation here. That's actually important. If you were to just do this, it might throw an error at you. Indentation is important. So you'll also notice here, this is not part of this top if statement because there's no indentation here. The indentation in Nim is very important. So all of this is part of this if statement. But this is not part of this top if statement because it is unindented. Always take note of your indentation. If you're coming from Python, it's the same concept. What is indented is important. Alright. So now that we know that this if statement does not contain this if statement, they will run independently. So if we were to go 20, this bottom one will execute, but not this top one. Run it, you may not enter. And here if we were to say 610, then the top one will execute, but not the bottom one. Your elderly may not enter. Now let's say if they are not one of these two ages, they are allowed to enter. Because then we can just say echo, you may enter. But now we have a problem. We will now have to, if we want to make this one only execute if these are not true, we have to then go if age is more or equal to 21 or age is more or equal to 60, or not more or equal, but I mean less or equal to 60, then you may enter. So now we have three if statements. One for if they're older than 60, one if they're younger than 21, and one if they're older or the same age as 21, or younger or the same age as 60. If we run this, and let's say our guy is 32, now they are allowed to enter because they are not older than 60 and not younger than 21. So with this OR statement here, we can check if this is true or if this is true. And you can use brackets to make it a little bit easier because now you can see, this goes first, then this, it checks them. So if either of these is true, then this will execute. But now we have a problem. What if we were to say they are 302? We'll actually get your elderly may not enter as well as you may enter, because OR checks if one of these two are true, not if both are true. So if this is a true value, but this is a false value, this will still execute because this one is true. So if yes or no, that's what we're basically saying here. So if either of these two are yes, true, then print this out. If we were to say and instead, then we'll say if this is true and if this is true, then execute this. So now if we were to run this, we'll get your elderly may not enter. But if we were to say 31 now, then we will not get that. We'll just get you may enter. And if we were to make them 18, then you may not enter. Cool. So we have just covered larger than or equal, less than, lesser than or equal, and or. All right. Now we can actually make this a little bit less to work with. For example, we can say elif, and now these two are one if statement. But this one checks. If this executes, then this will not execute. If this does not execute, then we'll try and execute this, but they cannot both be executed at the same time. To give an example, let's say we have this if statement, and here we're saying if their age is less than, or actually let's go here, let's say if their age is more than 18, right? Just ignore this piece of text here. And if their age is less than 21, now if we were to go here and we were to say 20, so it will fill both of these categories. We run it, then you get both of these values. However, if we were to say elif, which means else if, then only one of them can execute at a time. Your elderly may not enter. And the one that executes is the one that gets hit first. So if we were to say 10, this one will not execute because 10 is less than 18. But this one will execute. So now if we run this, you get you may not enter. So just as an example, that allows us to have two if statements that does not get in conflict with each other. Only one of those two if statements can run. You can of course have as many else if statements as you want. You don't have any limits, but take note, if one of them gets executed, the rest will be ignored. And take note, all of them should preferably have a different value. So this could be 22, 23, 24, 25, and so on and so forth. And didn't all need to check age. One could check age, the other one could maybe check the name. So here we could say else if name is equal to Mike, then you may not enter. And that's the wrong equal there. That should be 2 equals. And we'll get into that in a second. Okay, so now that we know that, we can actually use this to our advantage. Now we have this if statement here at the bottom. The problem with this if statement is every time we want to add another check here, we have to add it here as well. But because if statements are so powerful, we can add an else statement at the end, remove this, and there we go. Now it's all one big if statement. Else will execute if none of its upper components executed. So if you have 100 else if statements here, if none of them execute, then else will execute at the very end. However, if one of these else ifs execute, or if this if execute, else will not execute. So this will only execute, only run if none of the other if or elif ran. So if this and this did not run, then run else. But if this ran, skip these. If this ran, skip this and skip this. Alright. Now if we run this, we'll get you may not enter. If we make them 39, they may enter. If we make them 90, they may not enter. So it's basically what we had, but now there's less checks, and we don't have to worry that one if statement will execute when another should not be executing because this one has already executed. It's the same as going else and then doing this. instead of having to indent this and do this, we can just do this. And that will make it easier on us as well. Now let's say we want to do a few extra checks here. Let's say if they may enter, we want to go if name is equal to Jack, then 20% off all drinks. And we want to echo this. So we're checking if their name is equal to Jack, do this, and then also do this, because you have to remember, if something is not part of an if statement, it will still execute. If I go here and say echo 1, and then I go here and say echo 2, we will always see echo 1 and echo 2. No matter what this if statement says, we will always see this because these are not part of the if statement. Same applies here. Because this echo is not part of this if statement, if it wants to be, it needs to be indented. Because this here is its own little block scope. Same with this. This is its own block scope. So if we were to go like this, then now this will be part of this if statement. And this if statement is part of this else statement. But they are not part of this core code here. Indentation is very important. Again, because this indentation says if something is part of something else. This also shows you can have an if statement inside of another if statement. Even up here, we could say if name is equal to Jack, this could be a special case, and then echo you may enter, you are a good customer. There we go. So you can have an if statement within another if statement. Now if we were to run this, we'll get you may enter, you are a good customer. And we'll still get 2 here because 2, and we just resize this, because 2 is still part of the normal code. It's not part of this if statement. If we were to indent it, it will be part of the if statement and it will not run. Alright, but you'll notice we still get your elderly may not enter. What we want to do here maybe is we could say if name is, let's try adding a not equal. If it's not equal to Jack, echo this, else this. So we have an if else in here. Of course, you could have said equals Jack, and you could do this. So this is if the name is Jack, do this. But you could also do not equal. So the name is not equal to Jack, do this. And take note of this equal symbol here. This is 2 equal symbols, not 1. 1 will reassign. 2 will check conditions. This is a very important distinction to make. Now if we run this, we get you may enter, you are a good customer. And in here we could say, let's say their name was Jack. Then they'll say your elderly may not enter. Let's say their name was Jack and they were 38, so they are allowed to enter. Then 20% of all drinks and you may enter. We might want to put this you may enter first and then say 20% off of all drinks, just to make it look like there's actually some order here. If we run this, then it will display in that order. And if their name was not Jack, they will not receive that message. So run this, you may enter, but not 20% of all drinks. Now let's say if it's someone's birthday, they also get 20% off drinks. Well, if that is the case, then we could say, or birthday is equal to true. So now we're checking, is their name Jack or is their birthday today? If it is, then print this. So this is again an example of an or statement. With this Boolean statement here, we can actually just go like this. This means if their name is Jack or if it's their birthday, because this is already true or false. Because going like this is the same as not having that there, because it will still check if this is a true value. You can also do if it's not equal to true, or if it is equal to false, or you could go or not birthday. Not here tells us if this is a false value, then it will be represented as true. If we were to open up Nim secret here, which is a little command line, and we were to say let x is equal to true, x is a true Boolean. Not x is false. Because if something is not true, it is false. not x would be true, because first here, this is true. If it's not true, it's false. If it's not false, it's true. So not will allow us to flip it around. So if it's true, it becomes false. If it's false, it becomes true. Alright, so if their name is Jack, or if it's not their birthday, they get 20% off. Something you might want to take a look at. Now let's say their name should either be Jack, or it's their birthday, but they cannot be both. So if I say XOR birthday, then it either has to be their birthday or their name should be Jack. But if their name is Jack and it's their birthday, they are not allowed to have a drink. But if it's their birthday and their name is not Jack, they are allowed to have a drink for 20% off. If their name is Jack but it's not their birthday, they're allowed to have a drink for 20% off. If we run this, we'll get what we expect, 30% off all drinks. But if we were to make their birthday false, meaning both of these will be false, then you may enter, it will not execute this. But if their name was Jack, they will get 20% off their drinks. But if their name is Jack and it's their birthday, then they will not get 20% off all drinks. Now let's say we check if it's their birthday, and if their name is equal to Jack, or their age is more than 30. Now this is a little bit confusing, because what Python or what Nim will do here is Nim will first check, is it their birthday? If this is true, then it will try and check, is their name equal to Jack as well? If this is true, then if this is true or this is true, that's what Nim will do. So Nim will basically first run this statement here, the first statement it sees. So if this is true or if this is true. But in our case, let's say we don't care about this. We just want to check this. Now we'll check if it's their birthday and their name is Jack or their age is more than 30, then it will echo this. But by default, it will not do that. So you'll need to use brackets to specify what you want to be checked first. If you run this, we get stas because this executed as true. Cool. Now one more thing is you might want the ternary operator. So let's go let greet is equal to if birthday. So if it's their birthday, then greet becomes happy birthday. Else, welcome. So a ternary operator is when you have this if statement, but it's in one line and returns a value. In this case, we could have gone var greet is equal to welcome. And then we could have gone if birthday, then greet is equal to happy birthday. We could have done this, but as you see, now greet needs to be a var, which you don't necessarily want. You might be like me and you want to stick with let as most matches possible. So first, greet has to be a var, plus this takes up 4 lines, including the space here, but it could take up 3. But this takes up 4 lines instead of 1 line. And this actually might be a little bit more difficult to read than this inline if statement. So you might actually see more use in having this ternary operator around than using a normal if statement. But this is up to you. If you prefer to use a ternary operator above a normal if statement, then use it. Just don't go too overboard, because they become very difficult to read very fast. But with basic scenarios like this, it is one of the best things in the world. And now we get happy birthday. If we were to make this false, we will get welcome. Cool. Indentation in Nim causes scoping. Now what scoping is, let's say we have a box. So let's go draw here. Let's say we have a little box here. Now this box keeps the value x, and x is equal to 2. Now this value x is not available outside of this box, and this box is already inside of another larger box, which might keep the value y, which is equal to 1, we could say. Now this x here should not be available to the outside scope. It should not be available to the box outside of it. This x should only be used inside of this tiny box here. And this y can be used inside of this smaller box, but again, this y cannot be used outside of its current scope, its current box. So we take a look here. There's another box here, but y again cannot be used here. We have z here. Z is equal to 3. Z is available to this scope here. So if we were to print out z, we will get 3. But z is also available inside of this inner scope. If we were to print out z, we will get 3. Now the idea behind this is that you are safe to declare new variables inside of smaller scopes without it interfering with your already existing variables. So you won't have to worry that if you declare this y variable here, that this y variable might actually appear outside of the scope. But if you currently were to print out y, you will get an error because y is unknown. So you'll get an error. But the nice thing here is, if you were to put an x here, so if you were to declare x here and make this equal to a 4, then x will be available inside of this scope. So if you were to print out x, you will get 4. But in this scope here, x will print out 2. Because of scoping, when you redeclare x inside of this lower scope, x will be its new value. This will be the new x. So x cannot go into this scope. However, this x here will not affect this outer scope x. So this x and this x are two different x's. However, and there you can, if this x is a var and not a let or a const, then this x can be modified here if you're not redeclaring a variable, but instead creating a new one. Or not creating a new one. Yeah, anyhow. So let me show you an example of this. So let's go let z is equal to 20. Var x is equal to 10. Now here we have a block scope. We can use the block command to create ourselves a dummy scope. Take note of the indentation here. You need to indent to be inside of this block scope, because this is a new scope, just like with the if statement. Here we can create y, which is equal to 30. If we were to echo out z, x, and y, or let's do it in order x, y, and z, then you will get, and we maybe might just want to add it like that. There we go. This should be easier to read. We get 10, 30, and 20. That is what we expect. But now let's say we create another block. Now this block, we go and we say let z is equal to 50. Now we do the same echo, but in this new block scope. You'll notice we don't get an error that we redeclared z here with let. It just allows us. But if we run this, z will be 50 in this block scope here, whilst z is 20 in this block scope here. But if we were to try and go here and say let z is equal to 100, we will get an error because this z is in the same scope as this z, which causes an issue with which z should you really be using. But take note, we could go let x, or even var x is equal to 100. If we do that, and semicolons are not necessary, if we do that, we get 100 here for x as well. But if we were to go x like this, it will search for the closest x it can find, which is this x. So if we were to run this, x will be 100 in both of these. But let's say we were to go var x is equal to 99. And we can also do this echo, but for the lowest scope we have. And here we don't have a y, so we'll just do x and z. There we go. Now if we run this, you'll notice this x here, which is 99, it gets modified. But this x here, which is 10, right there, it doesn't get modified. This x will try and find the closest relative x it can have to modify. If we were to put a let or var or const keyword here, it will create a new X instead of going to search for a previous X in the previous scope or for the X in that specific scope. So if you run this, you'll see all the X's are different. Now this is just some basic things about block scopes you might want to know about. Cool. Now let's have another block scope example here. Let's say block I am cool. Now this is a block scope we gave it a name as well, which is an optional feature. And then we can go echo I can stop. And here we can also go echo 1, and in here we can have echo 3, and in here we can have echo 2. Yeah, let's actually just do that. Echo 1, 2, and 3. If we were to run this, we'll get 1, 2, and 3. We can also break I am cool. Now what this will do is it will break out of this block scope, so we can still have an extra echo here saying 209. But once it hits a break with its name in it, it's going to break out of this block scope like that. So now we don't get 2. We can also have another block, so block 2, and this could be in block 2. But because it's saying break I am cool, this block scope will break, as well as this one. So this block scope and everything inside of it will break out. It will stop executing the code in that block, as you can see here. This is just an example, not too important. Don't know how much you're going to use this, but just so you know, you can do block scoping using the block command. Cool. And now just always remember indentation, very important. That's the key takeaway from this. Indentation and scoping. So if you have a variable out here, you can create a new variable with the same name inside of this block scope, or inside of any new scope. It's like an if statement or a while loop or whatnot. But you can also reassign it in here if it's a var. If it's let, of course you can't because it's a constant, but if it's a var, you can reassign it here as well, and it will modify the original or the closest to the highest block scope. And that's the basics on scoping as well as the block keyword in Nim, as well as indentation. Very, very important. Case statements are very similar to if statements in the sense that they can check if a value is true. But in some cases, a case statement might just be the faster solution in terms of programming and typing than an if statement, because instead of having to go if x is equal to this or if x is equal to this, for example, let's go and say x is equal to 10. Now let's say we want to check a bunch of things. So we can say if x is 1 or x is 3 or x is 5 or x is 7 or x is 9, and these are all the checks we want to do, right? And in here all we want to do is say echo x is odd, right? And then we can say else if x is equal to 2 or x is equal to 4 or x is equal to 6 or x is equal to 8. Then we want to say echo x is even. Finally we want to say elif x is equal to 10, echo x is 10. And then finally else we can just say if it's not any of those, echo x is not a valid number. Okay, now if we were to run this, we'll get x is 10. Cool. Now if we were to make x 2, we'll get x is even. If we make x 3, we'll get x is odd. And let's run this just so we don't get all of that other output. So x is odd. Finally, then if we go x is 100, then we'll get x is not a valid number. Okay, this is a basic if statement, but you saw this took me a very long time to code out, and it's not really nice to read. It becomes a little bit difficult to read at this point, and it's just, overall, it's not a great experience. With case statements, this issue is somewhat solved. Let's create a case statement. So case X. So we're saying, with all of the following checks, X is what we're going to check of. And we state our things here. So 1, 3, 5, 7, 9. And you can echo the same thing. So we said, basically this is the exact same as saying this. So we're saying, for all of the following of statements here, X will be compared to these values. Cool. And let's also go of 2, 4, 6, 8. And here we can echo X is even. And again, of 10, you can echo X is 10. And you can also use an else statement, so else, and we can echo X is not a valid number. This case statement is the exact same as this if statement. However, the difference is this didn't take me that long to write, and I believe this is also easier to read. There are a few other minor differences, but in this scenario, these two are the exact same, where this is just saying, okay, for the following checks, X is what we're going to check again. Is X 1, or 3, or 5, or 7, or 9? If not, is X 2, 4, 6, or 8? If not, check if X is 10. If not, then print this. So let's remove this if statement and just run over this case statement. Run it. X is not a valid number. We go 10. X is 10. We go 1. X is odd. We go 2. X is even. So a case statement just kind of made it a bit easier to work with. It's dependent on what you prefer. If you prefer to use if statements, use if statements. If people online tell you use case statements because they're faster or something like that, don't worry about it. On the end of the day, it's what you prefer. If you prefer using case statements, then use case statements. If you prefer using if statements, use if statements. I don't really have a preference, or I do towards if statements, but I use both case and if whenever I feel it's needed. If there's a massive if statement which I don't really want to cover with if statements because that's a lot of unnecessary typing and whatnot, I'll use a case statement. Otherwise, I would just default to an if statement. So it's up to you when and where you would like to use a case or an if statement. It's up to you if you would like to use an if statement or a case statement. Anyhow, let's take another look at a case statement that we can make. Let's say we have a type, color is in enum, and I will get into enums at a later date, but for right now, just know that they can store values for us, such as red, green, and blue. So let's say you are developing a TV, and a TV has pixels, and each pixel can be either red, green, or blue. And this is what generally makes, or even a keyboard that has RGB lighting on it. You can either tell it to be red, green, or blue. Well, in this case, it's pretty neat. We can say, let text color is equal to color dot red. So now let's say if the backlight on your keyboard, which is RGB, should be red. It's like that. Then we can say case text color of color.red, and now we can compare it to the red enum. Echo text is red, and then again we can check of color.blue. Then we can say echo text is blue, and finally of color.green, echo text is green. Now you'll notice here we don't add an else statement. Now in the previous example, we actually go to that previous example. So here, if I were to remove this else statement and save, you'll see we get an error because not all the cases are covered. So a case statement also makes sure to check all of the cases that could happen. In this case, this is a number, so it can have a bunch more cases. So in that case, we should also add an else statement. it wants us to do that. Where here, there can only be 3 cases because this color enum can only exist with 3 different values. So by putting an else statement here, it will never execute because this color can only be one of 3 values. Unlike a number which can be more than 10, or which can be a different number that you didn't include in that case statement. So else statements are required if you have something, but you don't cover all of the cases in that case statement. Anyhow, we'll get back to that in a second. If we run this, we'll get text as red because it's subtype red. If we go blue, then we'll get text as blue. Now let's say we don't want to cover the blue case. However, when we save it, we get an error that says not all cases are covered. So if I'm going to run this, it's going to tell us not all cases are covered, missing blue. Well, in that case, we can use an else, right? But we don't want to do anything if it gets blue. So we can use discard. We'll get into discard later, but right now, you can think of discard as literally saying skip. Don't care about it right now. We don't give a damn about what's happening here. So it's just going to skip this else statement then. Now if we run it, we'll not get any output, but we'll also not get any error by the fact that we didn't cover blue. But if we go red, or let's go green this time, we will get the text is green. And that's the basics of a case statement. Case statements are very similar to if statements in the sense that they can cover a state and check if those 2 things are the same. So if this text color is of this type, and if you want to add more types, you can add a comma, and here we can say color dot blue. And now if it's blue, it will also be here, and this else statement will just not be necessary. Anyhow, so now we'll cover both of these. And here we'll just cover this one. It also has an else statement. So it's very similar to an if statement, but it is not quite an if statement. So to give you an idea of what it could be, let's say we have all of our friends. So I have friend 1, friend 2, friend 3, and so on. And these friends all have like Mike, Nick, Jack. Now we can have 100 friends or 1,000 friends. The point is, we can have friends. Now, the problem with this is if you have 100 friends, you're going to need 100 lines to store those friends. So each variable needs a friend. If you want to go through all of your friends and check whose name is equal to a specific string, so let's say you want to check if, so this is your name. Let's go, name is equal to Mike. Now, if you want to see who else has the same name as you, you'll have to go if friend 1 is equal to Mike, to name. And you have to do something. So discard. Or if friend 2 is equal to name, do something. Friend 3 is equal to name. You constantly have to do that. Now that's also a very, very inefficient way of programming. Instead, what we could do is we could create an array that can store the names of our friends. So let's create a variable called friends. So it's plural, take note of that. That's just good practice. And now all we do is we go 1, 2, and then 3. And now we can remove this friends list because now we have an array with all 3 of our friends in it. Mike, Nick, and Jack. So now we have an array with these values in them. To access these values, we can actually just go echo friends at index 0. Take note, we will always start at index 0 when we work with arrays. In other languages such as Lua, you start at index 1. But in Nim, you start at index 0. So if you run this, you get Mike. So here we got Mike. And we say 1, then we'll get Nick. 2, we'll get Jack. 3, we'll get whoever would have been after them. So if we go 1, then we'll get Nick. So basically these indexes work like this. This is index 0, index 1, index 2. and so on and so forth, depending on how many people you add in here. If you try to use an index that does not exist, you'll just get an error saying it does not exist in 0 to 2. So instead of having an if statement for each and every friend, you can do it all with one if statement. You can even do something like this. If name in friends echo found someone with the same name. Now if we run it, it will print it out because there's someone with the name Mike here. If I said Mike's, it will not print anything out. So here with this if statement, we check if this name exists inside of this array. Now let's talk a little bit more about arrays. So let's say we have A, and this we can specify it's going to be an array. So it's of type array. Now we can specify how long this array should be and what data type it should hold. So we can say free and int. Make that equal to 1, 2, and 3. Now we have a variable A that's of type array. It can only hold up to 3 values that are of type integer. So if we say 2.0, we're going to get an error. If we were to say 4 here, which is a 4 value, we're going to get an error. So it can only hold up till 3 values, and it has to be of type int. So that is what we're basically saying here. Now we can of course echo out A at index 1, which will give us 2. Don't get confused just because I have 1 here. It still starts at index 0. So we'll get 2. And 2 here will give us 4. But as you saw, you don't need to specify anything like this. If you go like this, then it will automatically guess for you. So 0 to 2 and of type int. So you don't have to specify, but if you do specify, then you know. That also means you can't add anything to this array. So once you've created the array, you cannot add more things to it, and we'll get into that in a second. If you want to create an empty array, or at least a variable that will hold an array, then you will have to specify its type and how much it can hold. So 4, and it's a type boolean. So this I can specify an int here, and this should of course be var, because you're going to reassign it later. Because just by doing this, you'll notice we get an error, because int in this context will result into an empty array. It doesn't contain any data, which means you cannot add anything to this, you can't remove anything from it, you can't get anything from it. It's just going to be an empty array with nothing as a value. So if you want to create an empty array, this is the way to go. You have to specify the type. And we'll get deeper into that in a second. And then you also have something called a multi-dimensional array. I'm not going to dive too deep into multi-dimensional arrays. However, I will cover the basics. So let's say we have an array, and this array can hold 2 values of type array. So multi-dimensional array will hold another array inside of it. Let's say of 3 values, and it will type int. Now if we were to create this, we'll have this array, and it can have 2 arrays inside of it. That's what we're saying. So it can have 2 arrays inside of it. And each of these 2 arrays can have 3 values in them. So 2, 4, 6, and 100, 200, 300. So this array holds multiple values inside of it. If we were to echo out z, we will receive this. If we were to say z at index 0, we will receive this array. So if we go like that, we get this. So this here is index 0, and this here is index 1. Now each of these values has their own indexes inside of them. So if we say 0, 1, then it will go, okay, the first one at its first index. So this is index 0, and then index 0, index 1. So we'll get 4. Run this, we'll get 4. And if we change this to use the second array, we'll get 200. Now this is a somewhat complex topic, so I'm not going to dive too deep into it just yet, but just know that you can have an array that stores other arrays. Cool, now let's talk a little bit about indexing. So let's go and say 2, 4, 6, 8, 10, 12. Okay, there we go. So now we can echo A at index 0. We know that will give us 2. It will give us the first value inside of A. So 2. Now what you could also do is you can use this caret symbol and then 1. This means get the last element in the array, which is 12. If you use this, you'll get the second last element. So this is get the first last element in the array, and this is get the second last element in the array. Now we'll get 10. So you can use this to count backwards. However, take note, it does not start at 0, it starts at 1. You can also get a bunch of values back from an array. For example, 1 ... free. This means give me all of the values from index 1 to index 3. So from index 1 to 3. If we run this, we'll get 4, 6, 8. So it gives you index 1, 2, and 3. So it includes 3 as well. You could also do this, meaning give me all, or give me from 1 to index 3, but excluding index 3. So it will give you 4 and 6. So if you run this, you'll get 4 and 6. So it excludes the last value. And we can of course increase this to, let's say, 5 and 2. And now if we run it, we'll get 6, 8, and 10. Or we can go 1, 2, 5, and now we'll get 4 up until 12. So of course this can become very powerful depending on what you do. Now back to that var e becomes array, and let's say free of int, right? So let's say we have this. Now as I said, we cannot use let, because let is set at runtime and it's a constant value, meaning you can't change it. So this is this whole thing where now we don't have any values inside of this array, but we still need to add to it. So we cannot make this array a let. Now to add things to the array, we can just say, let's echo e, and it's also then go e at index 0 is equal to 10, e at index 1 is equal to 20, and e at index 3, 2 is equal to 30, and we can echo e again. So we can use the indexes and an equal symbol to assign values to that index if the array is a var. Now if we run it, we'll get 0, 0, 0. So by default, all of the indexes will just be populated with 0. Until we fill it, in which case they will now have their filled value. If you don't fill the middle one, then that will be 0. So it's good to take note of that. Now, unlike with arrays, sequences does not have a set length. So the length of a sequence can change at any point in time. So with an array, you have to go like this, and that's an array. It has to hold 3 values, or it has to hold 5 values, and it has to be of type int. And then, of course, you can add those values, but it can only hold up until 5 values. You cannot add values to an array. So you can't add a 6th value if the length is 5. However, with a sequence, it's different. So let's say we have a list. And this list is a sequence of type string. You'll see we didn't specify any length here. So this, as long as it holds strings, it can be of any length that we require it to be. Same with if we were to go x, and that is a sequence, you'll notice I start with an at symbol here. Sequences, unlike arrays, start with at before they start. And let's say 1, 2, 3. Now this will be a sequence of type int. So take note, this, without that, it will be an array. Take a look here, array. But with an at symbol before the array brackets, we get a sequence. That's a very important distinction to make. And you can also declare a sequence like this. So is equal to new seq int, like that. This will also create a sequence. You hover over it, as you can see, it creates a sequence of type int. How you create a sequence is up to you. As long as you know you need to specify the type, you need to use this at symbol, and you're good to go. Now let's configure this list to be, let's say, hobbies. Now here we can say hobbies then becomes a sequence, and let's go anime, coding, and I don't have any other hobbies, I'll say eating. There we go. So now we have a sequence with these 3 values in them, and we can add more later on. We can echo hobbies, and we'll get a sequence, and you'll notice Nim also puts an @ symbol here when displaying it, so we know this is a sequence. An array will not have an @ symbol before it. So take note, the @ symbol is important. Even here, if you just did that, then you'll get an error because that's an array, and this is a sequence. Now to add values to the sequence, you can go hobbies.add, I'd say gaming, could be hobby. And now you added a hobby, or you added an item to the sequence. So you'll notice now it's a longer. You can also use delete, so hobbies.delete, and this will delete an item at that given index. So let's say I want to delete coding. That's at index 1, because 0, 1, 2 works just like an array. We run this. Now it's anime, gaming, eating, so there's no coding. And just like I said, it's just like an array, so if I say 1 here, we'll now get gaming. Not coding, because remember we removed coding here, so we'll get gaming. And just like with an array, we can also check if there's an item inside of them. So if eating in hobbies, then echo, we have an eating hobby. So you can still check if this value, and take note it is case sensitive, so this is not the same as this. This is a capital E, this is a lowercase e. They're not the same. Take note, I'm putting a capital case E here. Anyhow, so we have an eating hobby, and we can also add, and we have hobbies.length, or if you prefer, just this, or if you prefer, you can go length hobbies, or if you prefer, you can go length and hobbies. Depends on what you prefer. Again, Nim is incredibly forgiving with how you do things, so depending on what you prefer, you can use. I'm going to use length like this, and you can just say -1 other items, other hobbies. There we go. Now if we run this, we'll get, we have an eating hobby, and we have 2 other hobbies. So you'll notice we still have 2 other hobbies other than this. And with this length here, we're getting the length of the hobbies, so the amount of items inside of it, but we're using -1, so we already have eating. And of course, if I were to make this a lowercase e, or if I were to make this a capital case E, if it's any different from this eating here, it will not see it. So if we go like this, it will not see it. You'll have to make them both lowercase or uppercase if you don't want anything like that to happen, or you'll just have to do them perfectly like this. Now, sequences on their own are okay, but they're not incredibly powerful just on their own. To make them more powerful, you can import SecUtils, which is sequence utilities. Now let's create a few sequences. A is equal to 10, 20, 30, and you can create a few more, B and C, there you go, 40, 50, 60, and 70, and here let's go 100, and then 1000. Okay, there we go. So now we have 3 sequences. Now let's say you want to make one big sequence from these 3 smaller sequences. Well, then we can go D is equal to concat A, B, C. So now D will be a sequence from one of these. And concat comes from SecUtils. So now if we echo out D, D will contain the values of A, B, and C. So 10, 20, 30, 40, 50, 60, 70, 100, 1000. Now here we have E, which is hello. Now E is just a piece of text. We can also have d, and while we're at it, we can go var f is equal to, and you can add a few things to the sequence. Now, some sequence utilities work on more than just sequences. So that is why I declared e. For example, echo e.count. And here we can count all of the L's inside of e. And of course, this should be of a char type, not a string type. There we go. So we need to use single quotes, not double quotes. Now, if we were to run this, we'll get 2 because there are 2 L's inside of e. Similarly, we can also do it with sequences. Now, just for fun's sake, I'm going to, instead of saying d.count, I'm just going to say count d. And instead of saying L, because this is an integer, we can say count all of the 7s inside of this sequence. If we run it, we'll get 4 7s. So this same function comes from secutils, but it works on both sequences and strings. Same with, let's say, we go e.minIndex. We can do the same for f as an example. If we run this, we'll get 1 and we'll get 11. And it will return the index of the smallest value. Now with strings, it works with ASCII. So in this case, the ASCII value of E is less than the ASCII value of H. If you don't know what ASCII is, it's not that important for right now. But basically, whenever you convert a letter to a character that computers can understand, because as you know, computers work with numbers. There's this intermediate level. So we have E, then we have ASCII characters, and then it goes to binary. The ASCII characters are basically numbers such as, I believe 65 is like a capital or lowercase a. However, my ASCII is very outdated, so I'm not sure if that's correct. But anyways, it will return the index of the smallest value in the array, or sequence, or string. In this case, 1 is at index 11. So if we were to say echo f, and we did this, then now if we run this, we'll get 1, because 1 is the value here, the smallest index. And of course, you can flip it. Instead of min, you can say max, so it will get the largest values index. So now if we run it, we'll get 4. So 0, 1, 2, 3, 4. 8 is the largest value inside of the sequence. You also have functions such as f.deduplicate, and it'll remove all duplicates from a sequence. So if we run this, then here we'll get the same sequence, but now without duplicates. So here we had like a bunch of 7s. We had 1, 2, 3 extra 7s. Now we only have 1 7 here. So remove all of the extra duplicates. We also have filter. Now this is a little bit more complex. It uses a procedure or a function, and then whatever is returned, but we'll get to that later. So basically you just say proc, then you can go, this can be any value here. So that this is just a variable, and you can specify the type if you want. In this case, it's going to be an int. I'll explain why in a second. And it will return a boolean, and we can say x less than 5. Now if we run this, and I'll explain it in a second, we get this. So what happened is we said, okay, for each value, and each value here is like an x. So 5 becomes x, and then we do this comparison. 6 becomes x, and we do this comparison. 7 becomes x, and we do this comparison. So for each item inside of f, check if that item is less than 5. If it is, return it. If it is not less than 5, remove it. So by doing this, we removed all the values that are greater than 5. This includes 5 as well, because 5 is not less than 5, like we specify here. If we were to say less or equal to, 5 would also be included here, as you can see. So this filter method here basically says for each item, which is x, that's what's an integer. If this was instead a sequence of strings, you'll have to do strings here. Then we're going to return a true or false value. Then we check, is this value less or equal to 5? If it is less or equal to 5, return it. If it's not, don't return it. We also have a bunch of others like keep if, do the same, and let's just run this. And take note that keep if will permanently change f. So you can't just echo it out, but it will permanently change this f here. Anyhow, so if we run this, then here we get the same answer. However, it's the same as filter. It just permanently changes f. That's very important to take note of. It permanently changes f. Unlike filter, which will not change f, it will just return a new sequence from it. So this will permanently modify it. Filter will return a sequence, a new sequence. So if will never change. So you see here we're actually getting an error because it returns a new sequence. It does not modify an existing one, like keep if. Cool. Then you also have, let me just echo here, map. So f.map, and here we can just say x, and it's just going to return an int. I'll explain this in a second. There we go. So what map does, it says it's the same as filter with like this value becomes x for each time it goes and does something, but this time it just returns the same value. Now the thing here is, let's say we wanted to multiply everything inside of this sequence with 2. We can say times 2. Now if we run it, we'll get 10, 12, 14, 14, 16. So for each item inside of this sequence, take that item and multiply it by 2. And take note, if you're having trouble understanding filter, keep if, and map, it's perfectly fine. A lot of people, when they first get introduced to these types of functions, they don't quite understand it. So if you're having trouble with them, then it's perfectly fine. You do not have to be perfect with them yet. Let's quickly go back to deduplicate. So deduplicate. So this removes all of the duplicates. Now let's just change this to D for now. And I'll explain why we did that in a second. So now we get this. Now, if the sequence is sorted, so if it's already sorted, you can pass in true. In this case, it is already sorted. The lowest value is here, and the highest value is here. So it's at the end, and the lowest value is at the start. It's sorted in the middle. So everything here is sorted already. Unlike here, where 5 is here, then 1 is here near the end. Like this is already sorted. If it's already sorted, and we can run this, then there's no difference. However, if you pass in true here, that means that this D value is already sorted. And it will use a faster method. So if you're working with code that really relies on speed, and you have a sequence that is already sorted, then you can do this and get a faster deduplication in the process. But take note, if you were to try and do this with if, which is not already sorted, it's not going to be able to do the filtering correctly because it's not already sorted. So if it's not already sorted, just use normal deduplicate. It is going to be a little bit slower, but unless you're really working with like you need intense performance right now, like really good performance, and it is already sorted, then you can do that and it will be a bit faster. You can also do something cool, such as, let's go back to D just so we have it. You can also do something such as distribute, and if we say free, then it will convert the sequence into 3 other sequences. So it will distribute the amount between 3 other sequences. But take note, it's also inside of one big sequence. So if we were to say 0 here, we'll get this first sequence of 1, 1, 2, 3. You can see there. And if we were to say 2, then let's go 3, then we'll get 3. If we go 1, we'll get 1. If we get 0, we'll get 1, whatnot. So it will return you a nested or a multi-dimensional sequence. Now let's say you have another sequence. Let Z, and that is my code works. And you really want to convey to your coworker that your code is not broken. It works better than anyone else's code in the whole company. Then you can just say dot cycle, let's say 5. Now if you run this, it will repeat it 5 times. It will return a sequence of those values repeated 5 times. Similarly, you can also go and you can create a string, and we can just say repeat my code works, and now do 5. And that will return a sequence with my code works in it 5 times. Next up, let's say we have if here, and we want to insert a value between these first two values, so 5 and 6. Then what we can do is we can say if.insert, and we can put 999 just so we can really see it, into index 1. Now if we were to run this, then here you'll see we get 5, 6, and you'll get 5, 9, 9, 9, 6. So we can use insert to insert new values into a specific location between, or into a specific index inside of a sequence. Nice. Let's make it a little bit smaller. Let's say we have let h, which is equal to a sequence 1, 2, 3, 4, 5, 6. I, which is a sequence of at hello Tom exclamation mark. And then j. J is a zip with h and I. This will combine the two sequences, creating a new one. Very similar to concat. However, it can also be unzipped. So let's go here and say, oh, where's my things? Echo j, right? So let's echo j. So we get this. Now it gives you a tuple, and we'll get to tuples later, but it gives you basically these values. So 1 will go to hello, 2 will go to Tom, and 3 go to this exclamation mark. So we're basically saying each one of these should be aligned to a value here. If it's not, if this one is shorter than this one, then ignore the rest, or if this one is longer than this one, then ignore the rest in here. Basically, it will make one in a new sequence of the one that has a shorter length and assign values to them. Now the neat part here is we can say j echo j.unzip. Now if we use j.unzip and we run this, then we get a tuple, and we'll get into what a tuple is later, with the two sequences. So it's not the full sequence in this case with this top one here, just because this one here was too short to contain all of the values inside of this top one. But the neat part is you can combine the two, and then we'll be smart enough to like assign values to each. So this 1 will be with hello, 2 will be with Tom, 3 will be with the exclamation mark. And then when you unzip it, it will just create a new sequence or sequences with the values that it had in that zip. And that's that. Now, tuples are very similar to arrays in the fact that it has a fixed size that you provide it. But unlike arrays and sequences, tuples can contain multiple types, so it doesn't just have to be of type string or type number. So if a sequence, let's say we have x, and that is equal to a sequence of 1, 2, and in quotation marks 3. Nim doesn't like this. As you can see, got string, but expected int, literal. Now, Nim doesn't like this. Same with normal arrays. It doesn't like this. So if we hover over x, it says it's an array of type int, not of type string. So if you need something where you can store multiple data types into something similar, but not quite exactly, but similar to an array, then a tuple is the way to go. So let's create a tuple. Here we can create first tuple. And this tuple, let's define how it will look. So we use brackets for this. It will contain a string and then a float. And it will be equal to, and then we use brackets again, cat and 12.5. This is our first tuple. We can even echo it out. So echo first tuple. If we were to run this, then we get cat 12.5. If we were to say tuple at index 0 and run it, we get cat. If we say at index 1, just like with an array, we will get 12.5. Now, tuples aren't just as basic as this. They can become rather complex. For example, tuple. And now here, so we're specifying this is going to be a tuple. But now we can also specify named places for these tuples. So name, string, and in age, int. So we're specifying this tuple will contain a string and an integer, and they will have named properties. So this one will be a name and this one will be an age. Now we can go here and we can just say Luke and 59. So as you can see here, we have a tuple and it has Luke and 59 as its value. Now if we were to display example, you'll see we actually get name and age here. But that makes you wonder, what if you were to say index 0 now? Well, then you will get Luke. So it will still work as a normal tuple, where you can still use indexes, but now you're also allowed to go .name. And that will also give you Luke. Or .age. And that will give you the age. So then you don't have to use indexes, you can just use the word. And of course, you don't need to specify the tuple as you create it. So like this, it would be perfectly fine. However, if you run it, you'll just get empty values. As one last example, let's create a tuple called pet. And this tuple will not have any values provided to it, but it can be the animal, the breed, and then if it is a cool type of animal, which of course is a boolean, this is a string, and this is a string. There we go. Now here we can just say pet at index 0. So now we're selecting the pet at its 0th index, which would be animal. And let's say it becomes cat. If we were to echo out pet, and let's actually go pet.animal, then we don't have to worry about other things. If we echo that out, we will get cat. We can also go pet.name here, and that will also assign, and that should be animal, and that will also assign this value to that index. As you can see, we still get cat. Thanks to this, we can now go like this. I don't know any cat breeds, so I'm going to go dog, make the husky, and yeah, that's pretty cool. So let's go true. So animal or pet.cool, and here it's pet.breed, and let's go animal. Instead of animal, let's go index 0, just so we have an example of that. Now if we were to run and display pet, we will get what we expect. So this is just assigning it on the next lines. So you don't have to assign it right there, and you can also assign it using indexes or using named indexes. And that's the basics of tuples. They're incredibly simple, but incredibly powerful. So what we're going to cover at this moment is called a bit set. This is a type of set that is limited in the sense that it can only store very small data types. This includes numbers or characters. And this is of course for performance reasons. So as an example, let's go var mySet, and mySet is set of type char, and this should of course be a colon, not an equal symbol. So it's going to be a set that contains characters. And here we can say A to Z. So this set contains all of the letters from A to Z, lowercase. We can also go A to Z. So it also contains all of the letters A to Z, capital case. And take note, I'm using single quotes here because single quotes are used for characters and double quotes for strings. Very important distinction to make. So this set here contains all of the letters A to Z, capital and lowercase. We can also make this set contain all of the numbers through 0 to 9. As simple as that. We can of course echo my set. And if we run it, we'll receive a set with all of the numbers from 0 to 9, all of the letters from A to Z, and then again, but this time in lowercase, A to Z. There we go. Now, sets also has more power that comes along with it. It has a standard library module that you can import to make it even more powerful. As an example, let's say import std, and this means standard library, and from there we want to import sets. You could of course just say sets. This will work perfectly fine, but it's recommended to say std/sets. I'll get later into why this is important in a future tutorial, but for right now, this is recommended, but you don't need to do that, you can just do sets. Now by importing that, we open up a new world for us, such as to#set. And here we can put in an array 1, 5, 6, 3, 4, and 5 again. Hash sets do not have the limitation of a normal set. They cannot contain duplicates, and they're also not ordered. Let's just echo out A and see what we get. 3, 4, 6, 5, 1. So as I mentioned, it cannot contain duplicates, and it will also not be ordered, unlike a normal set. And as I said, it also doesn't suffer from the limitation that a normal set does, where you can only store very small values. So I can say, hello, I am cool. I can say this, and it will work perfectly fine. So unlike a normal set, a hash set will not yell at you if you put something in here that's a little bit too big for it. As an example, if we were to do a normal set here just to show you, then we'll get an error that says mismatch, got string for hello but expected a range. And if we were to say this is of type set and it contains a string, it's going to give us an error because ordinal type expected, that's what it says first, and here it says there's a mismatch again because it expected a range. So as you can see, a hash set does solve that problem for you. Alright, let's bring back that hash set we have. And let's put back the numbers. There we go. We're going to use this a little bit later. Let's create another set. And this set we can call B. And it will be toOrderedSet. And this is an ordered set, so it will be ordered later on. So it's the same as a hash set. It's just ordered. So it keeps the original order of the set. But this will of course make you struggle in performance later. But here, as you'll notice, this toHash set, it doesn't contain a specific order, so this one here won't be first, it will be last. The toOrder set, it will try and keep this order here as it is. So it's the same as a hash set, only difference is, if we print that out, you'll notice it stays in the same order. I'm going to call this C, and then I'm going to change up the numbers a little bit. So here we can have 9, 8, and 0, and let's make one shorter than A. So now we have A and C. Because we imported this set module here, we can actually do things such as times C. And this should of course be a toHash set. It cannot be a ordered set. When you do this, you'll receive this output, 5 and 1. So by doing that, we are basically saying, let me just copy that. We're saying A dot intersection of C. Now, for those of you who do not know this sort of math concept, which I had to learn myself when I learned about this, it will return what is in both set A and set C. So you'll notice both 5 and 1 is in set A and C, but 6 only appears in set A, 3 only appears in set A, and 4 only appears in set A. Same here, 9 is only C, 8 is only C, and 0 is only C. So this returns what is in both. Similarly, you can merge the two sets by using a plus symbol. Or alternatively, you could say union. If we do that, the two sets are now merged. As you can see, both of them has each other's value. You can also return the difference between the two, for example, A minus C, or alternatively, A difference C. Now if we were to run that, it will return all of the values that does not appear in C, but does appear in A. So you'll notice 6, 3, and 4, these only appear in A, but they do not appear in C. Of course, sometimes you want to have the values that is in each other, but not in both. As an example, you might want 9, 8, and 0 here, and 6, 3, and 4, because they only appear in their respective sets. If you want to do that, you can just say minus plus minus. And in here, you can say, as an alternative, if you don't want to use that, symmetric difference. Now if we run this, you'll see we get 3, 4, and 9. So 3, 4, and 9, as well as 6, 8, and 0. 6, 8, and 0. So the same as difference, but this time, instead of just returning the difference of one, it returns the difference of both. So what exists in one, but not in both. Let's create another variable. We can call it D. D will also be a 2-hash set of 9, 0, and 5. 9, 0, and 5. Now, one thing we can do is we can say D lesser than or equal to C. Now, this will return true if D is a subset of C, meaning if all of the items in D exist in C. So if 9, 0, and 5 both or 3 exist in C, then it will be true. If we run this, we will get true because 9, 0, and 5 exist in C. But if we were to say 9, 0, and 2, we'll get false because this number 2 does not exist inside of C. We can also say just lesser than, which means return true if D is a proper subset of C, meaning that C has more items than D, and that D is a subset of C, which in layman terms just mean C should have more items and should have all the items inside of D. Let's create another variable E, which will also be a 2-hash set, and it will just be 2 and 10. And in here we can echo out D dot disjoint E, meaning return true if set D and set E has none of the same items, which in this case would be true because D and E do not contain the same values. So it will be true. But if we try to do this with C and D, so let's say C here and D here, then it will return false because C does contain values of D. You can also compare these, such as C equal to D. This will return true if both the sets are the same size with the same items. So basically they're going to have to be the same, just like a normal equaling here. In this case it will be false, but if I were to copy this, meaning D is the same size as well as containing the same items, it doesn't need to be in the same order. This could be 0 and this could be 8, just order swapped. It will return true. So if it's the same length with the same items, it returns true. You can check the length of a set with either len or with card, and this will check the length of a set. In this case, the length is 5. Potentially, let's say you wanted to clear a set, such as D. We'll just make that a var so we can modify it. Then we can say, let's echo out D, just so we know what's in D. Then we clear D. And then we echo out what's inside of D. And of course, we can't echo clear, that's a function. We run that. Then now we have that. Then it clears D and then it echoes out nothing because D has been emptied. You can also check if a value exists inside of a set using contain. So echo c.contains 9. This will return true if C does contain the number 9. So it contains the value 9. You can also do something similar to D.contains or include. And here we could say 4. We can then just echo out B and do it again. So this will check if B contains the number 4, and then it will return true. Otherwise, if B does not contain the number 4, it will add it to D and return false. So let's run this. So here we have false. So it's checked, it couldn't find the number 4, so it added the number 4. Here you could see we added it. If we were to echo out the D before we added it, then you'll notice we get a value, there's no 4, we get false. Now there is a value and we get true. So if it does not contain the value, it will add that value to the set. So strutils, like I like to call it, or string utilities, is a module in Nim that allows us to work with strings more than we already can. So as an example, let's import it. Import strutils. And this already, right off the bat, gives us a lot of things we can do, such as echo letters. And this will give us all of the letters in the alphabet. A all the way to Z, capital and lowercase, all in a set. We can also get digits. And if we run this, we'll get 0 to 9, also in a set. Var spaces. So this is a variable that's going to contain a lot of spaces. Hello world. I am Steve. As you can see, it contains a lot of spaces. When we echo it out, then we'll of course get hello world, I am Steve, with a bunch of spaces here at the front, and at the back we just can't see it. We can of course make sure we do see it by just appending some random text. So as you can see, there's a bunch of spaces here at the end. Now we can change that by saying, and it will actually return any value, it won't modify the original, spaces dot strip. So this will strip our string, so it has no spaces at the beginning or the end. So it has no empty extra spaces. So as you can see here, instead of being a bunch of spaces, it just starts with the next amount of text. Same here at the front. So it removes spaces from the front and the back. With this power, we can also go dot split. And this will split our text into a sequence via what we put in here. So let's do spaces and commas. And take note, this is in set, meaning you need to use characters. Now if we run this, we'll get back a sequence where all of our words have been converted into items of the sequence. The reason I said comma here is because if we were to remove this comma, then you'll notice this here becomes one long string. So I just included comma. So basically at each and every interval of a string, we are going to create a new item in a sequence. And then finally, we can also check contains, and let's say ll. So this is in hello. And we of course don't need to append anything. We run this, it will return true because this string does contain 2 letter L's right after each other. But if we say OK, we're not going to receive this as a true because OK does not exist inside of the string. Now, string utils also allows us to insert values into a string. So as an example, let's go here and echo $1 is my $2, and I'll explain this in a second. My fave color is $4. Now these dollars here are basically where we want to insert variables or values. To do that with string utils, we can just use a percentage symbol and then an array with our values we want to pass in. Let's say Jack is my friend. And then let's just put a random word here, moon, and then blue as my favorite color. So I'm going to explain this in a second, but if you run this, we'll get Jack is my friend and my favorite color is blue. So with these dollar symbols, we are specifying the first item in this array. And take note, we don't start at 0, we start at 1 here. So the first item in this array is going to go here. The second item is going to go here. The fourth item is going to go here. You're not limited to specifically only having one of each. Here I could do $2, $2. That will work. Or I could even go $3 and then here $2. So the order and stuff doesn't matter as long as you use numbers. However, it is only optional to use numbers. As an example, let's change blue to 200. And let's change this sentence to $hashtag. This time we're using hashtags instead of numbers. Is my $hashtag. My fave color is $hashtag. I have $3 symbols, a hashtag, and I'm going to explain this in a second, in my pocket. If we were to run this, we'll get my Jack is my friend, my favorite color is moon, I have $200 in my pocket. So what is happening here is we don't specify any numbers, so it will go from the start to the end. So if you don't specify any numbers here, it's just going to take the first one, then the second one as they come. That's what the hashtag means. So you don't need to specify a number if you don't want to. You don't need to specify an index. Otherwise, it will just go from the start all the way to the end as default. And in here, we needed to use $3 symbols because this dollar symbol refers to this value here. This one right here. And you need to use a dollar symbol to escape dollar symbols. You might have remembered escape strings such as echo, let's say, I want double quotes here. I have to escape the double quotes with a backslash. The same concept applies here. You have to escape these dollar symbols with a dollar symbol. The reason is we use a dollar symbol to specify when we should display one of these values. So we need to use another dollar symbol to say escape it. Cool. That's one way you can modify a string. We can also go echo a brief, and let's go PLO, and we can specify an array with the values park, plot, and plaza. Now what's happening here is it returns an index of an item in an array. So in this case, we'll get either 1, which is the index it has been found at, -1 if it hasn't been found in this array, or -2 if there's more than one item with the same pattern. And in this example, it will give us 1. Why? Because here at index 1 is our answer. We run this, we'll get 1. Similarly, if we were to maybe move this one to the back here, we'll get 2 instead of 1, because now it's at index 2. So it searches this array for anything that contains these letters. Let's say we also have plop. This means there are 2 values that contains PLO, as you can see with these highlighted sections. So if we run this, we'll get -2 because it can't give us an index because there are 2 values that fill this category. And then finally, let's say we make this Nick and we make this pizza. Then now it will return -1 because there's no value that contains PLO. Cool. Let's create a string A, and it will contain hello. We can now say a.add world. And take note, this add method will permanently modify this variable. And we can then echo out A. If we run this, we'll get hello world. We also get add if for add format. This allows us to use that same method we talked about. So in this case, we can say hello world, my name is $, let's go $hashtag, and we just say Nick. Now if we were to run this, it will say hello world, my name is Nick. Or we could specify $1, it will work the same, but this time we'll just specify an index. You can also align text, such as, so here we have our hello. We can then say align A, and we say 30. This will align the text to the right with 30 characters. This means that it's just going to add to this, but it won't add 30 spaces to the front. It will add the amount of characters here. So this is 5 characters. As you can see, there are 5 selected.
So 5 characters, so it's going to be 30 minus 5. So we're going to get 25 spaces from this align. If we run this, you'll see here we get our 25 spaces. If we were to make this longer, such as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. If we did this, and we run it, as you'll see, it starts at the same point here at the end, and this amount of spaces gets less. So it's just going to align it with this amount of spaces or characters that you want it to have. So this line here, this piece of text, should be at least 30 characters in length, and it will just add spaces to the front to match that length you want. You can also specify align left, and this will align to the left. So it's the same as what we just did, but this time you just specify you want it to align on the left, meaning there's spaces here at the end here. So it's going to align itself here to the left and add spaces on the right. So if we were to just add a piece of text here and we were to run it, you'll see there's now a bunch of spaces here. And then finally, you can also align to the center. So saying center, and now if we run this, it will split it up evenly. So here we have our spaces 1, 2, 3, 4, 5. 5 spaces on each side. So it will try and center the text with the amount of spaces that we have left. And you can also specify third values, such as, let's say, dash. If you specify that third value, it's going to use dashes specifically to align it. Now here is something that I wish was in more languages, built right out of the box. Capitalize ASCII. We can just say, I am very cool. Now what this is going to do is it's going to capitalize the very first letter in a string. I truly wish more languages did this, because now, with something so easy, we now have our first letter as a capital letter. Let's change our A variable back to what it used to be. Hello world, my name is Nick. There we go. Now here we can go a.contains, and it will see if it contains this piece of text, such as name. If it does, it will return true. True. Simple as. It will just check if this string contains this word. We can also specifically check if A starts with, and let's say hello. This will return true because A does start with the word hello. Take note, it is case sensitive. So if you were to put a lowercase h there, you'll get false. And you can also check if it ends with, and here we could just say Nick. And it will return true if this piece of text ends with the word Nick. So let's create a variable. I'm going to call it B. B will contain I am very cool. It is interesting to see very high places from very far away. Now, one cool thing that we can use from string utils is the count function. b.count very. So the amount of times very is used inside of the sentence. We'll count it. If we run it, we'll get 4. So very is used 4 times. 1, 2, 3, 4 inside of this sentence. You can also use count lines, so .count lines, and it will count the amount of lines in here. Now there are 3 lines because we're using a \n. If we were to just echo out B here, then you'll notice why we get 3. So here it's split into 3 lines because we're using this \n, which means new line. And here it says 3 lines because it's split into 3 lines. You can also use delete. So b.delete, and let's say 3 to 10. This will delete the items at index 4 up to 9, both included. So here, this is the first one. You'll notice it's normal, and then you see I, aul. So 0, 1, 2, and then 3. So index 3 here will start, and then the rest will be deleted, or 2 and the rest will be deleted up until 10. So it basically deletes chunks out of your string. Let's create a variable called C, which is equal to a documentation string. So that means it's this string that has 3 double quotes. And this means you can split it into multiple lines. So you can say hello world, this is intended. Alright, so now if we were to echo C, you'll notice we get hello world, this is intended. You could also dedent it by going dedent, and this will unindent all of the text. So now you'll get this. So it dedented them all by 1. Now let's say you want to indent instead of dedent. Then you can go indent, dedent, C by 10. Now if you take a look at this, it will indent everything by 10. Now if you didn't say C here, you'll get, or dedent, then you'll get this. It will be much further. What we did first is we dedented it so there's a little less space here. So it's more predictable how far it will be indented. You can also count the amount of indentation used by going indentation C. Now if we count that, there's 4. So this counts the amount of spaces used per indentation. So if we were to just print out C, you'll notice each indent is only, actually you can see it here, so there's only 4 spaces per indent. This was just indented twice, but there's 4 spaces for each indent. Cool. Let's create a new variable, call it D, and let's go like this. The name's Jack, pronounced Mac, I am / was cool. And let's print out D just to see how it looks. My name's Jack, pronounced Mac, I am / was cool. Now we can escape all of these special characters such as these quotes, this backslash, because here there's no problem, but there might come a case or scenario where you need to escape them. We can do that easily by saying d.escape, and I will escape all of the special characters, of course using a backslash to escape them. Similarly, let's go let k is equal to d.escape, and then echo k.unescape. So we just escaped D here, but we can also unescape it with unescape. So now we'll just get what we used to have without any escaping, because we used to have this. As you can see, backslash and then double quotes. Here we don't have those backslashes, we only have what we need. So you can unescape it very easily. Cool. Let's create a variable E, and E is equal to this binary value. Now we can echo from bin uint8, and this uint8 should be here, E. This converts binary to an unsigned 8-bit integer. Meaning, if we do this, we'll get 153. So this binary becomes 153. Useful if you know binary. Now one awful thing is that when you have a large number, let's say, and if is like one like this, it's very difficult to read and know exactly what this is because the zeros, they confuse you. What you could do is say insert sep for insert separator, and you specify f. Now if we run this, it will have a separator inserted to make it easier to read. So now it's easy to see, okay, 1,000, million, billion, 10 billion. You can also specify what separator to use. So let's say sep is equal to, and then a dash. Take note that I'm using single quotes here to specify character. And instead of underscores, it will use dash. And I can also specify the amount of digits it should include when separating. And let's say it should be 2. Then 2 digits each time instead of 3. Cool. Let's go G. G is a number, 2014. Now it's very simple to convert something like G to a string. It's just int to string G. So you simply converted an integer to a string. It looks the same here, but this is in fact a string and not an integer. You can also specify the minimum amount of characters. So let's say 6. If we run that, you'll get this. So now we'll add 2 zeros to the front of this value here. Another useful function you can have is alpha ASCII. And this will check if an item exists in the alphabet. So this is true, this will be false, and this will be false. So only that A will return true because that's the only value that exists in the alphabet. You could also check is alphanumeric. And it's the same as what we just did, but now it also includes numbers. So it will be true, false, and true. But if you just want to check numbers, you can also check is digit. And this will only check for numbers. Now another useful function you can have is empty or white space, which will check if a string is empty or if it contains just white space. So if we were to check these 3, we'll get true, true, and false. Because this is an empty string, so it will return true. This string is just white space, so it will return true. And this string isn't empty, and it isn't just white space, so it will return false. You can also easily check if something is uppercase or lowercase by going is lower ASCII and is upper ASCII. Now if we say C, that will, or V, that will be true. Capital V, that will be true. So it will check specifically if a character, so single quotes, is uppercase or lowercase. As you can see, both of them return true because this is a lowercase v. If I were to change that uppercase and this one to lowercase, it will both be false. You can also use to lower ASCII and to upper ASCII. And that will convert these characters to uppercase or lowercase. And of course, it doesn't just need to be characters. You could specify strings. So I am uppercase, and if we run that, this lowercase v became uppercase, and this uppercase text became lowercase. We can also check if a specific character is a space. For example, let's take these two and say, is space ASCII. And here we could add a space, and here we can actually add a \n. Because a \n still counts as a space. If we were to add a \\, that will not count as a space, that will count as a \. So it will be true, true, and false. Because both of these two count as spaces, and this does not count as a space. Let's create a variable, or not a variable, but an array that contains eat, work, sleep, repeat. Now we can make this array a string by saying .join and then specifying what we should use to join them. In this case, I'm just going to use an arrow and say each word inside of this array should be joined with an arrow. If we print it out, we'll get eat, arrow, work, arrow, sleep, arrow, repeat. Cool. Let's create a variable. Let h is equal to my name is Tom and I am my worst enemy. Now here we can echo b or h dot replace, and this will replace specific pieces of text inside of this string. So let's say am with are. Now take note, this am will be triggered everywhere. So even in this name, this am here will be changed, as well as this am here will be changed to are. If we run this, we get nari, because this ARE replaced AM. And in here is Tom, and IR because am my worst enemy. So we replace any word where it finds these characters with this word. Similarly, you can replace multiple items by using multi-replace. And then you pass in an array with tuples. So AM will replace R, and here we can say worst with ultimate. Note it has the same downsides where AM everywhere will be attacked. Let's say my and replace with your. Cool. Now let's run it and see what we get. Your, because your name is Tom. And I am your ultimate in a your, because my was here at the end, so it said in a your. That is something you should take note of, so I displayed it 2 times just so you know that that is a thing. You should watch out with your words. This will replace any characters that appears in this sequence. If you wanted to only trigger on words, you can use replace word. And it will only replace words. So now if we were to display this, then your name is Tom and I am your worst enemy. So it didn't trigger on this. So you can use replace word to not replace depending on characters. You can easily convert a string to an integer by going parse int. And let's say 99923. And just to make sure that you can see that this is an integer, we'll plus 9. Which you cannot add an integer to a string, so this has to be an integer. If you run that, you'll see 99932. So this string was converted to an integer using parse int, and then we added 9 to it. You also have parse bool, and this will parse Boolean-like values. For example, yes, this could be considered true. You also have no or off, which will be considered false. You also have 0, which will be considered false, where 1 will be considered true, and you can also have true. So it will parse these into normal booleans. As you can see, true because yes is considered true, off is considered false, 0 is considered false, and true is considered true. You also have y and n. Now these are very useful if you're creating like a terminal application or command line application where you need to get true or false values, yes and no's, from the user, where they might input y or yes, and then you receive those values. Cool. Let's create a variable var I, and var I is equal to hello world. Now here we can say remove prefix, and take note this is a permanent change, I and X. So it will remove any X's before the text. So remove prefix means remove from start. When we were to put X here at the end, you'll notice it won't be removed. So now if we echo I, then here we go X, hello world, XX. So remove the first item that matched this as its prefix. Similarly, you can say remove suffix, and this will remove from the end and not the front. So now you see there's only 2 dots and not 3. A cool thing you can do is repeat. So let's echo good boy. So let's say you have a dog and you really want to make that dog know that he is a good boy. You can just say dot repeat, and let's say 10. And this will repeat this good boy 10 times. As you can see, good boy, good boy, good boy, good boy. Let's redeclare age here and put my name is Tom and I am my worst enemy. Now we can say echo age.find, well, it should be age.find my. This will return the index of the substring, and it will return -1 if it was not found. So if we go like this, we'll get 0 because it starts right there. If we were to say is, then we'll get 8 because it starts at the 8th index. What if we said WSR? You will not receive anything here but a -1, meaning nope, it was not found. So if it doesn't exist, you'll get -1. If it does exist, you'll get the index at which it exists. You can also use rfind, and this means reverse find. So it's the same as what we just did, but we'll start from behind. But take note, as I said, it said substring, not string. So we'll not find it specifically a word, but instead any place that it finds this piece of text. So if we were to run this, we'll actually get 36 because it triggered on this. It's not a substring, it is a anywhere inside of this piece of text. So this one will just go from behind, while find will start from the front. Let's echo to bin, and this will convert to binary. Let's say we want to convert this 100 value, and if we run this, we'll get this. So it converted 100 to binary. We can also use to hex, and this will convert a piece of text to hexadecimal values for us. So hello. As you can see, now we have an hexadecimal value. And we can also convert a number to hex, so 2004 for example, can also be converted to hex, as you can see there. And then finally, we can create variable j, which is equal to 3.14159, and I don't know the rest of pi, so I'll just put a bunch of zeros here. And here we can say j.trim zeros, and we can put a dot here. So it will remove zeros from a string anywhere after this dot here. So if we then echo j, we'll get 3.14159. If we were to put zeros here, it will not affect it. So you can see 300. It's only affecting it after this dot here. If we made this a comma, then it won't affect it at all. And that is that for the string utils module in Nim. Rather big and powerful module. So to take a look at it, we can just import algorithm. There we go, so algorithm. And let's create 3 variables. A, which is an array of 6 and type int. B, which is an array of 5, but it has values. So let's go 5, 1, 8, 9, 7. And then C, which is the same as B. So we can fill this array with a couple of values. So let's go a.fill. So this will use the algorithm's fill module to fill this array with a specific value we choose. So at index 1, so this is the index. At index 1 for 2 spaces, fill it with the value of 9. That is what we are saying here. So now if we run this, at index 1 for 2 spaces, fill it with the value of 9. If you wanted to, you don't need to specify these, and you can just say 9. And now all of these values will be changed to 9. So there we go. Let's take a look at B, and we can actually reverse B. B.reverse. But we only want to reverse 1, 8, and 9. We don't want to reverse the entire array, only 1, 8, and 9. To do that, we say reverse from index 1 for 3 spaces. Now if we were to run this, and of course echo out B instead of A, we'll get 5981 instead of 189. So we reverse from index 1 for 3 spaces, and we reverse these values. And of course you can do the same by just going like this, and now everything will be reversed and not just those values. Let's create a new variable, variable D, and we can make it equal to reversed, and then to open array. We can specify the array C, and then 1, 2, 3. Now if we print out D here, Then we get 9, 8, and 1. So what happened is we said create a sequence. So reversed will return a sequence. And take these 1, 8, and 9 here, reverse them, and then make them this new sequence. So we said from array C, from index 1, free spaces. So index 1, and in free spaces, reverse them and create a new sequence. Now the reason we had to say to open array was because reversed is actually being deprecated. So if we run it like this, you'll notice we get a deprecation warning. So reversed itself is being deprecated. Instead, you should now use an open array to reverse. Now we can also do a binary search. So binary search through an array. So let's say we have a bunch of characters like this. And we want to search for character C. And this will return us the index of character C in this array. We run this, we get 2. So 0, 1, 2. The index of C here is 2. If you specify a value that does not exist, such as if, then you will get -1, because -1 just means there's nothing there. Let's create another variable, E, and let's make it equal to 1, 2, 3, 4, and 5, and 6. Now we can rotate this array. Let's just echo out E here. We can rotate this array by going e.rotate left 0 to the length of E -1, 1. So what we said here is rotate the whole array to the left. So from index 0 to the last index by 1 value. So from index 0 to the last index in the array by 1. So now we'll rotate to the left, and 2 will be here at the first index, or this, the first index, and 6 will be here at the second last index, and 1 will be at the last index. So if we run this, the array would have been rotated, so 2 is first and 1 is now there, and it's just rotated once. And of course you can use this to say how many spaces, or if you wanted, you can make it 2 spaces instead of 1. So now 1 and 2 is here at the back, and it starts here at 3. So let's import the math module, and we should actually start using this std to specify it from the standard library. I've been not using it for a while, but we should actually be using that when we import. Now here, let's just get a few constants we can get from this math module, such as echo E. And we can actually just echo a bunch of things here. Then we can get max float 32 precision. And I'll explain most of these in a second. Max float 64 precision, pi, tau, inf, negative inf, and nan. Alright, now let's just print them out so we can get values. There we go. So let's explain these. This E returns Euler's number. This max float 32 precision returns the max amount of digits after the decimal that can be trusted in a float. Because as you know, with computers, they have a certain length of precision that can be allowed. And like if you have a 32-bit float, then only 8 values after the decimal can be trusted to be accurate. After that, accuracy is questionable. With 64, there's 16. Pi will give you pi. Tau will, I assume, give you tau or whatever that is. Inf is basically infinity. And negative inf is negative infinity. So you have infinity and negative infinity in Nim. And then nan stands for not a number. So if something is not a number, it is nan. Cool. Now similarly, we can have mathematical functions such as, let's say, 2 to the power of 6. We all know this. If we were to run this, we'll get 2 to the power of 6, which is 64. We could also use pow, and let's say 5 to the power of 2 this time. So this is the same as what we just had, but note it should use floating point values. There we go.
So it's the same as what we just had, but now it's using POW, and it also requires floating point values. Let's also use SQRT for square root, and this also needs a floating point value, and that will be 5. So the square root of 25 is 5. We also have round, which will round a floating point value to an integer, or to its closest value. So let's say 3.5. We also have floor and ceil, and we'll actually get to both of them. So floor and ceil. And now, if we were to run this, we'll get 4.0, 3.0, and 4.0. So round will round it to its nearest whole number. So this would be 4 in this case. Floor will always round down. So even if I make this 3.9, it will go down to 3. And ceil will always round up. So even if I go 3.1, it will always round up. So we'll still get the same values because ceil always rounds up, floor always rounds down, and round rounds up or down depending on this value here. 5 means up, 4 or less means down. We can also have this, and then we can say trunc, and this will truncate this value. So if you run it now, we'll only get 3.0. So we'll basically remove this end part here. We also have a nice function is power of 2, and it will check if this is part of the powers of 2. So let's say 16, and we'll get true because 16 is power of 2. But if we say 17, then we'll get false. We have copy, sign, and let's say we have 10 and negative 1.0, and both of these should be floats, I'm believing. Now what this will do, and take note, this is only available in newer versions of Nim, so make sure you have version of Nim 1.6 or higher. So this will copy this negative symbol from this value here. So it will copy the symbol, the sign, from this value to there. So it will make this negative 10. It copies that sign. And I believe if we go negative 10 here, and we just hit 1.0, then it will become a positive value. So it will copy the sign that's provided here. You have summed, and here if you pass in an array 1, 2, 3, 4, it will calculate the combined values of an array. So in this case, 1 plus 2, that's 3, 3 plus 3, that's 6, 6 plus 4, that's 10. So it will give us 10. So if we run this, so what's happening here is we get 1, and then 1 plus 2, that will give us 3. And then 3 plus 3, that will give us 6, and then 6 plus 4, that will give us 10. So that's kind of how it works. Each value takes the cumulative value of the previous values and adds them together. We can also convert radians to degrees, so rad to deg for radians to degrees. I'm not going to get too deep into what radians are. Essentially, you don't need to know what they are unless you really need to work with them. And this is of course not part of summed. We can just run this and we get 89.994 degrees. We can also convert degrees to radians. And now let's say we had 90.2 degrees, that will give us 1.57 radians. We can also do GCD and get the greatest common divisor. So 12, 8, if we run that, we'll get 4. So both of them can be divided by 4. And that is the largest they can be divided by. We also have floor mod, and this will floor modulo. So if we were to say 8 and 3, we will get 2. And basically it just means it will return an integer and not a floating point value. Same with div, and this should be div. So that will return 2. If you were to just do 8 divided by 3, then you'll get 2.666. All right. Now the next section is going to be for math lovers. And yeah, let's get to the more interesting part.
So these are most of the things I don't really understand, but it's just to show you that they exist inside of Nim. So you can say echo inf.isNone, and basically this will return false because infinite is a number. So isNone will just check if this is a number. Infinite is a number in Nim, so it will return false because it's not isNone. This will check if it is not a number. However, you could do none and compare that to isNone, and it will be true because not a number is not a number. And then here we have sum, and this is like summed like we did before. However, this time it won't return an array, it will return a value. So let's say 1, 2, 3, 4. Now if we were to run this, we'll get 10. And we also have prod, which is the same as a sum, but instead of adding, it will times. So it will 1 times 2, that's 2, 2 times 3, that is 6, 6 times 4, and then we'll get our value, 24. We do have things like cos for cosine, so 0.15, and then we'll get a value from that. Hyperbolic cosine, so cos h, and here we could maybe just put 1.0. We also have sin, tan, cube root, so this will get a cube root of the value. So basically this cube root is the same as saying floor is QRT, and then whatever the value is we put in. So let's say 8 for example, and then here let's just go 8.0. So this is the same as saying that essentially. And then we also have binom, which is the binomial coefficient. We have fac, which calculates the factorial of a positive number, something a little bit more easier to understand. And then we also have log, which computes the logarithm of x to the base. So let's say 10.0 and 2.0, and then let's go 6 and 2. For ton, we can say 10.0, and we can say the same for sin. Alright, for those of you who understood most of this, well done. And yeah, here's a few examples of the output. So let's import std rationals, and here we can just say let a is equal to 3, and we can say 2 forward slashes 4. This means 3, so if I can just get a hashtag there, 3 over 4. That is what this means. We can then echo $a, and this will convert this value into a string. And we can also say a if we want here and see what happens. So you just get 3 forward slash 4. So you won't get what you usually see if you do this. So if you do that, you'll get 0.75. However, if you do this, you will actually get a rational like there. And the only difference with this is an actual string. So this is converted to a string, whilst this is not a string, it's a rational. Let's create another variable. B is equal to 9 over 5. And then we can actually add them together. So echo A times B. So this will times the two rational numbers together. You can of course divide, add, and subtract as well. So now we get 27 over 20. You can of course also go, if you make B a var, B minus equals 2 over 5 as an example. And then that will actually minus the value we get from B with 2 over 5. We can also check which is greater, A, B, and it will return which is greater. So all of these work again. You can use double equals, not equals, lesser than or equal, greater than or equal, lesser than, greater than. You can use all of these just like with normal comparisons, and we'll get false because A is not larger than B. We can also use ABS, and -5, let's say over 2, and this will return the positive value of this rational, which would be 5 over 2. So it removes the negative. The abs does exactly the same with basically everything. You can use abs, -5, and you'll get 5 out of it. Return the absolute value, positive. There's another way you can create rational numbers, such as, let's say, var c, and that is equal to a rational of type int, and we just specify the number, which would be 6, and the denominator, which would be 24. And of course we can echo out c. If we run this, we'll get 6 over 24. We also reduce c and an echo c. This reduces the rational number until the number and denominator no longer has common dividable numbers. So let's say from 6 divided by, or 6 over 24, it would become 1 over 4, as you can see there. So it will try and reduce it to its simplest form. You can also go c dot to float, and this will convert it to a floating point value, as well as c dot to int. Now if we were to run this, we'll get 0.25 and 0. And you can of course convert an integer to a rational by just saying to rational, and let's say 0.19, and you could also specify its maximum denominator that it is allowed to be. So let's say the same actually, but then we specify the maximum its denominator is allowed to be is 20. Now if we were to run this, we will get, so the first one will be 19 over 100, and this one will be 3 over 16. Because we limit it and say it may not, this here, that might not be more than 20. And here it is free to be as much as we want it to. Now a loop is a piece of code that will execute over and over and over and over again until a condition is met. A while loop specifically is very popular for being able to create infinite loops, which is a loop that never ever stops. As an example, let's create our first while loop. While true do, and we can just say echo I loop. If we were to run this piece of code, we'll get an infinite amount of these I loops, and your CPU will die of exhaustion. Now we can actually specify when it should stop. As an example, variable x is equal to 20. And if we can say while x is more than 10, so we can pass a condition in here, because this while loop will not execute if this condition is false. So we're saying while x is less or more than 10, which in this case it is because x is 20, run this loop. So now we can actually echo out x, but if we leave it like this, it will give us an infinite loop. We need to decrease the value that x is. You have a couple of ways you can do this. You can say x is equal to x minus 1, and if you were to do this and run it, you'll get 19 all the way to 10. Or you could say x minus equals 1. This will do the exact same thing. Or you could say, instead of that, you can just say dec. That means decrease x by 1. In some other languages, you can actually have x minus minus, but in Nim we use this. Now if you run it, we'll get the exact same thing. Once x is no longer more than 10, it stops the execution. So this while loop will only run while this condition is true. And for this you can also have inc x if you want to add 1 to it. So let's flip this and make x 1. Now it will work the other way around. So while x is less than 10, which it is, increase x by 1 and then echo out the value of x. Let's go back to our previous example. Now here we also have two things we can use: continue and break. Let's say if x is equal to 15, we continue. This will skip an iteration of this loop. So if this continues hit, it will skip everything after it. This means this decrement x should never be after this continue, because otherwise it will never be decremented again. It will just go to 15 and then infinite loop. But if it's like this, then it will decrease it. If it reaches this continue, it will skip this output section here or anything that's after this continue, and it will go to the next iteration of the loop. So if you run this, we'll not get 15 anymore. So here we get 15. If we run it, we don't get 15 anymore because we skipped everything after this continue once x was 15. That includes this echo x. And then finally, we also have break. So here we could actually say if x is equal to 12, break. Break will stop a loop. It will break out of a loop. So it will make sure that we actually stop the loop. So once break hits, nothing after it will be executed. So you can actually go echo running here. Nothing after break will be executed. And if break is hit, the entire while loop will stop. So you can actually go here and say echo start, echo end. And if you run this, we get start 19 running, 18 running all the way, and we skip 15, because remember, we continue, all the way to 12, and then we get end. Where if we weren't to include that break, it will go all the way down to 10, and then end. This also means we could say true here. Because while true, it can run this loop, but as soon as x is 12, it will break out. So let's go here. As you can see, now it works the same way. This is now 12, but we could, of course, make it 10. And that's the basics of a while loop. All it does is execute code multiple times over and over and over again until this condition is either false or it hits a breaking point in the code, like here, where we break out of this loop. So a for loop is very similar to a while loop in a sense that it loops over code multiple times. However, they usually are more helpful in other scenarios other than checking if something is still true and then cancelling out later. Such as, let's create a variable friends. That should be a variable, not that. And that can be a sequence of names. So Jack, Nick, Lucas, Paul, and Jesse. Now the nice thing about a for loop is, let's say I just want to get my friends. And I run this, and it gives me my friends in the form of a sequence. Now let's say for each friend, I want to get the index that they are in inside of this array, or inside of the sequence. And I also want to get the name and then display it to the screen. Now for loops make this very easy by allowing us to go for, get the index, get the friend we are looking for, and then the array or sequence we want to go through. And here we can just echo friend. We can put the index in there. So let's say it is friend 0, colon, and then we can print out the friend. So this will get the index, so 0, 1, 2, 3, the index, and this will get the actual piece of text in here. This could be a number or whatever, but in this case it's a piece of text, so it will get Jack, Nick, Lucas, and Paul. And then for each person or each friend inside of this sequence, we are going to run this command, or run this statement here. If we run this, we'll get friend 0 is Jack, friend 1 is Nick, friend 2 is Lucas, friend 3 is Paul, and friend 4 is Jesse. So just as you can see here. So it allows us to loop through things. Of course, you could always just exclude index, because I know sometimes you just don't want to use index. Now you can just say for a friend inside of our friends list here, we can just go friend, colon, and then friend. We do that, we get friend, Jack, Nick, Lucas, Paul, and Jesse. Now for loop is of course a little bit more useful than just looping through a list of things. such as you can go for a number in the numbers values 1 to 5. So it will loop through the numbers 1 to 5. If I say echo num, we will get all the way from 1 to 5. Very, very simple. If you want to make it go from 1 to the number right before 5 or the number right before this value here, you can do this. This means go from 1 to 4, or if I did this, 1 to 5. It's up to you which you prefer. If you then run it, then there we go. This is useful for, let's say you are reading from a text file and you want to get all of the lines before the very last line. Then this can be very useful. You can also count with it. So let's say count, and here we can go count up or count down. We'll look at both. 1, 10, 2. And we can just say count. Now if we run this, we'll get from 1 to 10, but in steps of 2. So this will just count up from 1 to 10 in steps of 2. Count down will do exactly the same thing. So count down, but then you just need to go 10 to 1 instead of 1 to 10. And this field right there is optional, so you don't need it. You can remove it in both count up and count down. And now it will count downwards. It's also useful if you want to just, in general, count things, such as, let's say, variable ALC for letter count, and that can be 0. Then you can say for letter in, and then we can put a string here, and then we'll go through each and every letter in the string. Hello world. And in here we can say if the letter is equal to O, then LC plus equal 1. And you can go echo LC. This also shows you, and there should be a single quotes because that's a character, not a string. Now this shows you that you can also put normal things in here, just like with a while loop. This isn't limited to anything. You can still put any normal Nim code in here, but it will just do it for each letter inside of this string. Now if you run this, we'll of course get 2. Because there are 2 letter O's in here. For loops are incredibly simple. Unlike while loops that you will need to tell it when to stop, for loops generally have a know-how of when to stop. Because you can put a value in here that will have a set length, and it will go up until the end of that value's length. Now a table is a very powerful data structure in Nim, similar to the dictionary or the object in Python and JavaScript. Let's get started. Let's import std tables, and this will allow us to use tables. Let's create a user1, make them equal to, and we just go like this, username, and it should be a string, and their username can be Nick, and their password can be this. Alright, so imagine this is a website where users can sign up, and the user can enter their username and password to log in. Then here we can just say .toTable, and this will create a table for us. Now here we can just, if we wanted to, echo out user1 and see how it looks. So here we have password and then username. Take note that these are not ordered. So if you put username first, it might not be first. Like in this case, it is second. Password as well. They are not ordered, and this is implemented as that for performance reasons. Because when they're not ordered, with most data structures, if they're not ordered, it's faster. Now we can easily access an item in here by just going brackets and in quotes putting the key, and this is the value. So if we put the key in here, it will return us the value associated with this key. So if we were to run this, we will get Nick, as you can see there. You can also change what is saved inside of here. So if we were to say instead of Nick, we would say Mike here. So we're getting it, it will display Nick for us. Then we're changing this set username here to Mike. Then we're displaying it again. So this one will be Mike and the top one will be Nick. So it's Nick, change it to Mike, and then Mike. You can also use this to add new values such as age, and let's go 99. And we of course display the age here. Save this, and my bad, this should be a string because it can only be the string or whatever type you put here, and then another specific type. You cannot have a string number and then a string string. These should always be the same type, these as well. So now if we were to run that, we will get 99. So you can add more items here. If we were to remove that, we will see age is displayed in here. So age, password, username. Now let's say you want this to stay in the order you set it as. Username and password, these two should be first username, then password. Not like this where it's password, then username, and sometimes age is put before them and whatnot. To make sure your table stays in the order you create it in, you can say to ordered table. It's the same as a normal table with the difference that it is ordered. So if we were to run this, we'll get username, password, because that's the order we're giving them here, and then age, because that one has been added last, so it will appear last. So this is the same as the normal table we just took a look at. However, the primary difference here is that it will always stay ordered. This is of course at the cost of performance. If you do not care too much about performance at the moment of coding, then you don't need to worry about keeping it ordered. But if you need to debug or anything like that, then ordered tables can also be useful. You can also check if one of these has a specific key, such as username. And of course, we just go .has key username, and it will check if they have a key. If this key does exist, and we run this, it will return true because username does exist in here. If I were to say usernames, this key does not exist in there because there's username, not usernames. Then we will get false. And then finally, let's say we create this username field here again. Now, instead of saying to ordered table, we say to count table. Now, what's going to happen here is we're going to count the amount of times a key and value is inside of this table. So if I were to display user1 here, we will get password 1, username Nick 2, because username :Nick is found 2 times inside of this table. So it will have a 2 here. Whilst password with the key of passwd, these only appear once, so it will have a 1 here. Now one thing I want to show you is, let's create a couple of tables. We can create friends, and let's say we want to create an empty table. An easy way we can do that is init table, and then we say what the key should be. The key should be a string, and we say what the value should be, which should be an int, and then we just call it as a function. Now this is a table where we have a string and an integer, where the string is the key and the integer is the value. We can also do another one called letters, and we can say init count table, and we just say char. This will create an empty count table for us, which has the values of char in here, meaning count the characters. And let's just create a here just to show an example of init order table. But since it is the same as an init table, just ordered, I'm not going to spend too much time on this. String, because order table is the same as init table here. So not much of a difference except that it's ordered. So I'm not going to spend a lot of time here. Okay, so now we have free variables. All of them are tables. Now you can of course add values here, as we said before, by just going friends. And let's say Jack. Now the key has to be a string here. That is what we're doing here. The key has to be a string. The value has to be an integer. So here I could say 90. So it could be the Jack is 90 years old. And here we can go Mike is 59 years old. Now if we were to echo friends, you'll see it's a normal table. But the difference is now we have numbers here as the values instead of strings. And the key could also be an integer if you want. So int, and here we could maybe go 1, 2. We run this, then 2 will be 59 and 1 would be 90. So you could change this to a different type if you want to. I will keep it a string for now. Let's assign letters a couple of values. So letters is equal to count table. So this will create a count table from this here. Now it does say open array A, but what we can put in here is just a normal string, and it will convert that string into an array of characters for us. So hello world, this is a great place to be. And now we just display letters. So here we can see there's one D in this whole string. There is 3 O's in this whole string. There is 8 spaces in this whole string. And it basically counted all of the characters for us, which can be very useful in some scenarios. Take note, a capital letter is not the same as a lowercase letter. So a capital letter H, a capital letter W, and a capital letter T is not the same as their lowercase counterparts. Now you can also clear a table by just going letters, and this also works with normal tables and ordered tables. Dot clear, and if you echo it again, then now it will return an empty table right here. So you use dot clear to make a table go empty again. You can also compare tables with each other. In this case, we're just going to say letters and friends and then compare them to each other. Now these will both return trues. It will check if they're the same, but take note that you cannot you cannot compare two different types. If I were to say letters equals to friends, it will not allow us, because a friends is of type table, whilst letters is of type count table. They are different types. It is like comparing an integer to a string. You cannot do that because they are not the same type. And if we were to put A here, it will still give us an issue, because an ordered table is not the same as a table. They are defined as two different types. Now let's say we want to, let's just echo letters here. We want to increase the number of spaces here. So currently it's 8. To increase that, we can just say .inc and we go space. And this does not echo, so let's just do this. So we'll increase it by 3 and then we'll print it out again. So now spaces is 11. So we can use the value .inc or the variable .inc to increase the amount in a count table. You can also return the one with the most amount of values, so .largest. That would be spaces, which I believe has 8, so it has the most. And also smallest. That will do the opposite and return those with the least amount of values. So here we have space with 8 and then we have D with 1. Even though there are multiple with 1, such as H here, it will not return H as well. It will return the first one it finds with the lowest value in it. Space, the same with largest. They will find the first one with the largest value and it will return that. In this case, space has 8, not 11, because we removed those extra .inc lines. So it's not 11, but actually 8 here. And it will return the largest and the smallest. You can also check if letters contains, and let's say contains H, which we know is true. H, and let's try again with Z. So the first one should be true and the second one should be false. Correct. Because the first one does include an H. If we were to just print out letters here, then you'll notice we do not have a Z in here at all, but we do have an H. So if this H key exists inside of this table, it will return true. You could also go letters.delete, and we can just delete, let's say, spaces. Spaces is here. As you can see, there's 8 of it. So if we delete space, then there will no longer be a space in here. Another fun fact is if we were to say variable b, which is of type integer, and echo out letters.pop, and let's choose I. So right here, I, which is 2. So we choose I, and take note, I'm using single quotes, not double quotes. It's always important to know the difference. A double quote is for a string, a single quote is for a char. A char is a single letter or a digit like this, whilst a string is basically a full piece of text. And let's just say B. Let's also echo out B. So this does the same as letters.delete, but it makes B equal to the value that is being deleted here. So I is 2. If we were to run this, then B would be 2, and pop will return true because it could delete that I value and store it in B. So now B is the value of I, but I, if we echo out letters here, doesn't exist inside this table anymore. So you'll notice there's no I here anymore. We can also echo out letters.get or default, and it will default, let's just go here, default Z. So it will get the item. If it does not exist, it will return the default type, that would be an integer and default to 0 for this value. So in this case, if it will try and get the Z, if this Z does not exist, it will return 0. So if we run this, and take note, a lot of this I'm just doing with this count table, but you can do a lot of these with their normal ones as well. Like let's say friends.get or default, and let's go Lucy, and this should be a string, of course. So as you can see, there's 0 because Z does not exist. If we were to change this to capital T, and we just run this, so this will be 0. So Lucy would be 0 because it is a string and then the value is an integer. So Lucy would be 0. And in here, T would be 1 because it could get 1. So a lot of these functions I'm showing you works on more than just the count table. Take note of that. And you remember how we could go has a key, and let's say has key T, which would return true. We could also go has key or put, and it will try and get that key. If it does not exist, we can put a value there. So let's go Z and put 10 there. And my bad, this has key or put does not work with a count table, so we will need to go friends here. And here we just need to go Nick, and there's 10. Okay, so this will basically work the same. We can actually just put friends here, and let's go Nick. So there we go. So checking if friends has the key Nick. This will be false, of course, because it does not. And then here we check if it has the key. If it does not, we put this value here. So let's actually then echo out friends so you can see what's happening. If we run this, we get false. False because it did not have it, and then Nick 10. If we were to copy and paste this again, let's go like this, and let's make this 20 just so we can see what happens. Then we'll get false, false, true, and you'll notice this value did not go to 20 because now Nick already exists in here because we have put the key inside of the table and we gave it a value of 10. So if it does not exist, give it this value as a default. We can also get the length of a table by using len. So len, and just get length of the table, which is 2 in this case, yep, because there's only 2 keys here. We can also go here and say more letters is equal to 2 count table, and let's just go My name is Steve and I am very cool. There we go. Then what we can do is we can say letters.merge more letters. Now letters would have all of the values inside of more letters. Let me run this. You'll notice now spaces is equal to 16. Our exclamation marks has been increased to 3. Our these is now 2 because it now includes all of the letters in more letters as well. So you can use this to merge two tables together. You can also sort. So let's say here we go letters.sort, and this will sort this letter count table, but it will sort it in descending order with the one with the highest value. So spaces would be first because it has the highest value. So there we go. 16, 8, 6, 5, 5, 3, 3, 3, 3, 3, 2, 2, 2, and so on. We can also go through each and every key here by going for key in letters.keys. And we can echo out the key. So it's just a normal for loop, but for every key, which is this value here, this is the key. This here, that space is a key, that E is a key, that A is a key. So if we run this, it will echo out all of the keys for us. So there we go. This can also be done with the values. So value here, and we say, we go here, m values, and now we will get the values instead of the keys. As you can see, now we get the numbers, so the amounts. If you want both, you can go m pairs and then ask for the key, comma, value. So the key and the value. Then we can just go key, and here we just say, and there we go. And I'm not in the mood, so I'm just going to say import str format. There we go. And here we can just format this into a normal string. And here we go. Now if we were to run this, we'll get key and then the value, key and then its value, key and then its value. And that is the basics on tables in Nim. There's a lot more you can do. However, I think this is more than enough for us at the moment to handle. Now, for the previous couple of tutorials, what I've been doing when I was running my code is I was saying R hints of main.nim. If you were doing the same command, today you will not be using this command, you'll be using C-R. The reason for this is when we say R, it compiles the code and it puts it in a Nim directory away from us. So it does not put it here. It does not put the compiled program here. So what we should be doing is we should compile it first and put it here in our folder before we run it. The reason for this is when we try to access a file, it is going to search for a file in the current folder that the executable is in. So if the executable is in a Nim folder and not our current folder, it will not find the file we're trying to give it to read or write to. So when you first compile it, and you'll notice if I were to run this, we now get a main here. This is an executable. Basically, this means compile to this executable and then run it for us. This is basically short for, it's short for this. But of course it's without this R. So we don't have to do this part here. So take note, we now need to compile it and then run it. So compile it in this folder and then run it. Perfect. So let's create a file, readme.txt. And here you can just put anything you want. Hello world. This is a story about. Just kidding, this isn't a story. There we go. So now we have a bit of text in here. And now here, let me just resize that a little bit so we have more space. Here we could just say import strutils. This will just help us later on as well. And we can import that on first line. Let file content is equal to read file So this is how we read a file. We just say readme.txt. So it will search for this readme.txt here, and then echo file content. And I'm just also going to add a \n here. There we go, just to add a new line. We're not currently using anything here, so it's going to be highlighted, but we do not worry. Now if we run this, we get hello world. This is a story about, just kidding, it isn't a story. So we read from this file here. Now an alternative way to, instead of reading the entire file at once, what you could do is you could say variable if for file, and we can just call it file type. Then if open the file readme.txt. So it will first check if it can open this file, because if this file doesn't exist, it cannot open it. So we first check if we can open it. If we can, we say echo file has been opened, echo f.read line. So now you can read a single line, and also close f. So this will close the file for us. If we keep the file open and a different application tries to read that file, or we try to read that file again, we will run into an error because the file is still open. We cannot open it again, as an example. So now if we were to run this, we get file has been opened, then we get hello world. Each line we put here, it will read another line. So here, hello world, this is a story about. And the reason we do this, let's say we make it txtd. That file does not exist, so it will just not run this because that doesn't exist. You cannot open something that doesn't exist. And then finally, another way you can read it is we can just go let lines is equal to file content is equal to read file readme.txt file content dot split lines. So this is another way you can also read it, and you basically split the lines into a sequence, and you echo out lines. Now you'll get a sequence of each line in the sequence. So hello world, next line, this is a story about, next line, just kidding, this isn't a story. So that's the basics of reading a file. There's 3 ways, or technically 2 ways of doing it. Where you just read the file, or you first check if the file is open and then read line by line. So let's write a file. Let's go write file my file.txt, and let's put hello \n for new line, world \t for a tab, I am here, and then a \. There we go. Then now if we were to run this code, we go to myfile.txt, you'll see hello, new line, world, here's a tab, as you can see with that arrow there, I am here, and then a \. So that is how you write to a file. An alternative way, so let's say you open a file, then you can also go variable a is equal to open myfile.txt fm write. So we're saying open it in write mode. You also have read and append mode. Append mode basically means don't overwrite the file. Anyhow, let's say write a.write heyo, and then a.close. Save that, run that. Then here, if we go to myfile.txt, now it says heyo, it overwrote the file. If we were to say fm append instead, then if we go here to my file, now there's a second heyo. So append won't overwrite the file. It will add to the end of the file. And I believe by default it is read. So by default it opens in read mode. You can also open it in read or write, so you can read and write to the file. And yeah, there's a lot more you can do here, but for the most part I think these are all that we really require to know about. You can think of an enum as a constant that allows you to store a specific value as a piece of text. For example, here we could go type color, and color is equal to an enum red, green, blue. And in here, we can create a variable text color, which is equal to color.red. So now we know that text color will always be either red, green, or blue. We know that for a fact. That is the power of an enum. It is more something that the developer can use to regulate themselves, to make sure that the code that they are writing stays consistent, easy to read, and has little bugs. Enums helps a lot with that. We can also then do checks. So if text color is equal to color.red, echo text color is red. There's not a lot to teach about enums as they are just this. So the text color is red. If I were to make this green, we'll get nothing. If I were to make this orange, which does not exist, we'll get an error saying that this does not exist. So that is the power of an enum. You can use enums to make sure what you are typing exists in your code. It's like a middle ground between creating your own type, which in this case you are actually creating your own type here, but it's a middle ground between creating your own type and keeping order. We can also echo out color. Let's also echo out color.red, just so we can see what we get. So here we just get color because the type will just display, and here we get red. But take note, this is not a string. You can also assign them values, such as red is equal to hashtag #FF0000, green is hashtag 00FF00, and blue is hashtag 0000FF. This is hexadecimal values for their colors. But now they also have values. So now if we were to run this, we'll actually get this value in return. This is also much better to do something like if text color is equal to color.red. In fact, it is much better, let me just go something like this, to do this than to have go if text color is equal to, and then type it out, hashtag FF1212. Because this can cause issues, and technically you can't actually compare them like this because enums are used to keep the developer in line. They are basically, you have to compare an enum to an enum. So enums is basically just for the developer. If you don't want to use enum, you don't have to use them. But it is usually recommended to use them when you find that they might be helpful to keep this amount, to keep the values that you might be using here or the options available in simple order, like this. We know there's only 3 colors, red, green, and blue, and this is how we can access them. Ropes can represent very long strings, so very, very long strings, very efficiently. In particular, concatenation is done to O1 instead of O N. Now for those of you who have no idea what these are, just don't worry too much about it. Just know O1 is faster than ON. So basically, concatenation, things like that is very fast. If you need efficiency, you can use ropes instead of regular strings. So let's import std ropes. And here we can say let A is equal to rope and hello world. So it is basically the same as normal string. We can even echo out A here, as well as use $symbol to convert a rope into a string. Because this is a rope, and if we use a $symbol, it will become a string. Converts rope back to string. If we were to run this, then they'll both look the same, but this one has the type of string, which is slower than a rope, and this one has the type of a rope, which is faster than a string. You can also use string formatting with ropes. So let's say we have echo $1 is $2 and likes to eat $3. We can use a percentage symbol to say rope Nick rope 16 and then rope pizza. So you can still do string concatenation and use ropes, because ropes are in general a bit faster than strings, especially when it comes to string concatenation, like in this sense. Now if we were to run this, we'll get Nick is 16 and likes to eat pizza. So Nick is 16 and likes to eat pizza. So $1, $2, $3, they follow the same order. We have already covered the similar formatting before. Let's save this in a variable b. Then here we can just say echo b at index 5. And take note, this will be a rope. This will be a rope, since we concatenate using ropes. So this will automatically convert the string into a rope. But it works the same. We can say b at index 5 as well as the length of b. So if we go here, so I is at index 5, 0, 1, 2, 3, 4, 5. There we go. Okay, so yep, it is I, and the length of this is 33 characters. So it works the same as a string. We can also go here and say variable let c is equal to rope, and I like to eat it too. Now to concatenate these two, we can say echo b and c. It will concatenate the values b and c in a very efficient manner. So now we have Nick is 16 and likes to eat pizza, and I like to eat it too. You can also go b dot add c. And if you echo out b, it will now be basically c has been concatenated into b. So it will get the same value as what we just had, but this time b has been modified to contain c. And you can also concatenate an array of ropes, such as echo, and we just say ampersand, create an array. Let's say b, c, rope. Damn. There we go. Now, as you can see, they have been all concatenated together. And finally, ropes have been modified a lot to work very similar to strings, in a sense that you don't have to worry too much about conversion the whole time. So we can actually go variable f, which is a file, is equal to open written.txt in fm write mode. And if we just say write into f the value in b and then close f. There we go. Now if we were to run this, then here's a new file called written.txt, and here's our rope in the form of a string. So you don't have to do any changes here or make any changes to this rope to write it, because a lot of things that work with strings will work exactly the same with ropes, because in Nim, they are the same thing, but a rope is much faster than a string when it comes to things such as concatenation. There's a lot more you can go learn about ropes, but this is the basics and we'll get you into ropes. There's not too much about it. It's just this fast string. Now, a procedure is usually referred to as a function in other programming languages. Such as C++, you would have a function or a method, or in Python you have define, def, which is a function or method or procedure. Basically all the same keywords or terms to describe the same thing. Basically, it is a word of code that can run more code for you. To give you an example, if we do something such as let x is equal to 1, 2, or let's make us var x is equal to at 1, 2, and we go x dot contains, and here we could build like 2. So this contains here is a function, or in other words, a procedure. It runs code for us, but we only need to type contains. We don't need to write the code that's in here, because what this basically does is it checks if the value we pass in, so 2, is in x. So it basically returns that for us. It makes it easier for us than to just type out the whole thing. Some functions contain 20 lines for us, whilst others will contain 1 or 2 extra lines. but dumbed down to a single word for us to use. Let's create our own function, say hello, and let's say proc for procedure. Again, when I say function, I am primarily talking about a procedure. There is also a func keyword in Nim, which we'll get to later on. But when I say function, method, or procedure, in general, I am talking about this procedure, because that's what you'll be using for the most part. And here we can just go like this and say echo hello world. Now this function, we can just say hello. There we go. So this function will now be called. If we were to run this, we'll get hello world. So this function here is going to execute whatever is in here. As long as it is indented, make sure it's indented, then anything in here is part of this function and will be run. So I can call this as many times as I want, and it will execute the code in here as many times as I call it. So we go like this, then as you can see, it increased a lot. You can also specify the type it returns. In this case, it would return a void, meaning it returns nothing. You can also pass in a variable that should be used in here, which is called a parameter, such as name, which is a string type, and we can default it to Nick. So let's go here and just say hello name. There we go. So now we are saying hello to the variable that is passed in, which by default would be Nick. So if we were to go here and say Nick, Jack, and Mike, so what's going to happen is this one here will default to Nick, this one here will default to Jack, and this one here will default to Mike. So we're storing the value we pass in here, which should be a string type. We're storing it inside of this variable here, and then we can use this variable only inside of this procedure. We cannot use it outside of the procedure unless we return this value, which we'll get to later on. So if we were to run this, we'll get hello Nick. By default, it is Nick. So if you don't pass anything, you'll get Nick. This is an optional trait. If you do this like that, then this will have an error because the name is required. But if you add an equal symbol here, then the name is optional, or this parameter is optional. And then there's hello Jack and Mike because we passed Jack and Mike in there. A more intense example could be like the sum, getting the sum something. So procedure sum, and then we need x and y, which is both integer. Now you could go x colon int because that's its own variable, and y colon int. But because both of them are integers, you can do this, and int will be inferred for x here as well. And you can put as many things here as you want. So like that, and all of these will then be considered integers. But anyhow, let's just do this. So both x and y is considered an int, and it returns an integer later on. Then here we can just say return x plus y. The return keyword returns a value for us. So when we call this function here, in fact, if we were to go here and say, and let's make this sum x, and we were to just echo out x and y, there we go, void, then you'll notice the difference here. If we say echo sum 10, 1 for x and y, and then here we were to say echo sum x 9 and 1, then this one will get an error because it doesn't return anything. Unless we specify return here, and then we specify int here, it will see it as something that doesn't return anything. And when you return something, you can store it in a variable. Instead of let's say echo here, let's say we say let num is equal to sum 10 and 1, and we were to echo out num, then the value returned by sum will be found inside of num. So if we were to run this, we'll get 11 because 10 plus 1, which is being returned here, is stored inside of num. And num is being echoed here. It is also good to take note that you cannot add code after return. So I can say echo begin, but if I try and go here and say echo end, we'll get an error actually, because let's run this, and we'll just get begin and 11. So it will actually just say warning because unreachable code after return. Because after return, the entire function exits. So once you use return, you cannot put code after it. If you hover over here, it says unreachable code after return statement. So you can put code before this return, but once you add the return, it ends the function. You can also do function overloading, meaning you can have two functions with the same name, but does things slightly differently, such as procedure sum, but this sum takes in an x, a y, and a z value. Let's go int here. It returns an int. And here we can just say return x plus y plus z. So then it will choose which one is most relevant. So here we can also echo out sum and then 9, 4, 9. And now it uses both of these sums. This one uses the second sum, which takes x, y, and z. This sum uses the first sum, which only takes in x and y. This is called function overloading. You have two functions with the same name, but they take in the same variables, but this just a little bit differently. If we run it, we'll still get the same values. You might be wondering, could you change this into a float instead of an int? And yes, you can. So we go here, say 0.3, we run it, then we get 22.9. So it has the same value, or it can take in different things, but they will choose which one is most relevant. In this case, since it has two parameters here that are being passed in, it will choose this one. And both of them are integers, which also indicates that it should be this. If you were to go like this, which is float, and then remove that, it will also work because now they're just of different type. So we'll check what types these are that are being passed in. So now if we were to run this, it will still work as expected. This is called function overloading. You have functions with the same names, but they do different things. Do not overload functions carelessly, because if you overload a function carelessly, later on you might think a function does something, but then it actually does something else. So only if the functions basically do the same thing, but needs to maybe add an extra variable that you should pass in, or just return a different type, or take in different types. This is why often you'll see you can use things like contains with arrays, sequences, and I think tables, and all of these you can use contains, even though you use different types. It's just overloading the function to use or to allow different types. Now you can also go and make it a little bit more complex, such as procedure get largest value, and this takes in a values that's a sequence of int, and it returns the largest integer in that sequence. Then here we could even call a different function. So let's say we have procedure say hello, name, which is a string, and we just echo. Then here we say hello, Steve. So now you can also call a different function inside of this function. And if we were to echo out this, and of course it wouldn't do anything yet because it doesn't return a value yet. Although let's go like 1, 6, 5, -9, -2, 99, which will be the biggest one obviously, and then 3 and 4. Now currently it doesn't actually return an integer as it says it should, but we can still run it and we can get hello Steve, and it will just return 0 as the default since there's no value being passed in. Now in here we can actually go and create a for loop as well. So for value in values, if value is more than result, then result equals value. Now result is a special keyword in Nim. If you come from Delphi where you have result, then you would know what I'm talking about. Basically what result does is it removes the requirement for a return statement. Like in this scenario, we could put a return statement here by just going var uns is equal to 0. And here we can just say return uns. And here we say uns, and here uns. But it adds a lot of extra unnecessary code that we didn't need to use before. If we use result, we can remove this return statement and just do this, because result already exists inside of any procedure that returns a value. And result will automatically return a value once the function call ends. You don't need a return to end a function call that returns a value, but you can use result to return that value. So if we were to run this, we'll get 99 as expected, because result here is being given this value here. And result is being returned. And you can't do this with anything. You can't say R, because here R doesn't exist. Result is a special keyword which allows you to not have to use return. And by default, result, if the return type is an integer, would be 0. And it will, of course, have a default value for each and every type. Like with a string, it will be an empty string. But take note, this has downsides, such as if we were to pass in a sequence here with just negative values, it will return 0 instead of the last, or instead of that value. So what you could do is you could say result is equal to values at index 0. And this will make sure that even if they pass in values that are all underneath 0, it will still return the largest one there, which is -1 in this case. And if you do this, it will still do the same thing. It will just work as well. However, if you do declare the result, such as var result is equal to 0 as an example, then this will no longer be valid. If we were to run this, we'll get 0 again here. Because once you redeclare or declare the variable result, this result keyword is no longer going to be used. Then you will have to go and say return result. You will have to do this at the end. So take note, if you are going to redefine result here, then you will have to reuse return. You'll even notice if I hover over it, it says special variable result is shadowed, because there's a special variable that we can use, but we are overwriting it. In Nim, it is actually recommended to use result wherever possible instead of return. Personally, I feel you should use return wherever and result when you feel like it. It's up to you which you use. On the end of the day, Nim is basically created in a way that everyone can be satisfied in some way, such as I can go here and say echo, and let's just copy this here. I can go like this, and I can say get largest value, and I believe that should also still work perfectly fine. As you can see, Nim is made in such a way that basically no matter who you are and what you prefer, your preference is most likely going to be allowed in here. So if you don't want to use result, if you're like me and you prefer using return because it makes the code more clear for you, then use return. If you prefer using result because you don't want to use return, or you just think it looks better, use result instead. I personally find my code to be less buggy if I use return, because I might forget about results and forget to update it where I need to and whatnot. I'd rather manage the return myself. So let's create a function called count, and let's put a number in here which is of type int. And here we can just say num plus equal 1. Let's go here and say var number is equal to 0. And then let's say count number. Let's do that a couple times. What do you think would happen if you just ignore this type mismatch here? Nothing. If we were to pass in this number 0 in here, we will still get 0 in return, even if I say return num plus equal 1, or num plus 1 in this case. We will still get nothing. So we can echo this out, echo, and if we were to run this, we'll just get 1. But what if we wanted to level up this number? What if we wanted to increment this number? In that case, we will need to pass in this number value by reference, so it can be mutated in a function. By default, when we pass in a variable inside of a function or a procedure here, then it will pass in a copy of that value. It will copy it to create basically a new variable. But sometimes you want to pass in by reference. If you're coming from C++, you might be getting very excited right now, because this can be very, very useful. Because the only way we can actually change this without needing to do that is by going number is equal to count number, and then right here at the end say echo number. Now if we were to run this, we'll get 5. that is what we want. But you don't always want to do this. Sometimes you want to mutate a variable on the spot without having to reassign it. To do that, to pass in by reference, we can use var int here. This means pass this number value in by reference. Then we don't need to return an integer. We just say num plus equals 1 and we're good to go. Now we can just go here and do this. Because we're passing in by reference, if when we run it, will still return us the value we want. Now let's explain the difference between passing in by reference and passing in by copy. So usually when you create a procedure, and let's say this is our RAM. This is our RAM. These are all the things on the RAM where the variables and stuff is stored. So you create a variable here called x, right? So x. Now x here is 10. Now let's say you create a function that increments the value inside of it and then it takes in x. Well, then it basically creates a copy. So this is the original. I'll put a dot here so we know that's the original. It creates a copy, store that copy's value here. Let's call this y. Just because we call it the same name or something like that doesn't mean it will be stored the same way or it has the same value. So in this case, we just say y because it copies a new value and then y has the value of 10. When we increase this via the function, y becomes 11, but x still stays 10. So we need to make x equal to the value that is returned by y. And then we'll have to set this here to 11. Now this is a pretty okay way. That's how most things work by default. Like in Python, when you do this, this is what you'll get. You'll get basically a copy and then you have to save that new value in the variable. But there's another way. If you pass in by reference, then let's say here's our function. So this is our function and we pass in x here. Now when you didn't pass in by reference, what happened is you created a copy, you made it y, and you passed in y. That is what happened before. But when you pass in by reference, you directly pass in x here. Meaning that when we modify this x value here, it actually modifies the original value to the value we put it as. That is just how memory works. If you pass in by reference, which usually includes things like pointers or whatnot if you're in C++, but if you pass in by reference, you pass in the location of this value into the function. So where this value is in the RAM, and it modifies this location in the RAM. It's a pretty complex topic. I'm not going to cover it in depth because this is a function tutorial and not a pointers tutorial. But you get the gist of it. We'll later on jump into pointers and how they work and what you can do with them and how this actually works. But just know that when you pass in by reference, you can modify the original variable outside of this function. But when you don't pass in by reference, you cannot do that. You need to go here and you'll need to reset it each time. So number is equal to count. And then here we say num plus 1 and we need to return it. And here you also need to specify it returns an integer. So that is the different ways you can pass a value in here. As I said, I'm not going to spend too much time on it because this is not a function or this is not a pointer and a reference tutorial. It's more a procedure tutorial. The gist of it is if you pass in via reference, you can modify this original variable. If you pass in without reference, you're copying the original variable and creating a new variable. So when you have like a table as an example, so x is then a table with whatever in it, and you say x.clear, like we learned in a previous tutorial, this clear passes in by reference. Because that is the same as saying number.count. You can do that. This is perfectly fine. You can of course make this even more powerful by going, let's make this num turn into x, and then you can go here and say y, which is just a normal integer. Now when you do this, you can say x plus equals y. So here we have number, and let's say we can remove most of these, number and 8, or even number.count 2. So it will first become 8 because 0 plus 8, that is 8, and then it will become 10. So we'll have 10 at the end. If we run this, we'll have 10. So you can still pass in a normal variable and still use a variable by reference. But if we were to swap these two, the outcome would not be the same. Y would not change because it is just a copy. So once you get out of this function, Y will become 0 or whatever the original value was. Next up, let's take a look at declaring a function before you actually create it. So we can go here and say procedure sub for subtract x, y, which is just normal integers, not references, and returns an integer. Here we are declaring this procedure. We're not actually defining it yet, we're just declaring it. Then we can actually use it here, echo sub 10 by 5, and then we'll get 5. And then if we want to, we can later on define it. So let's just copy this, paste it, and then we can say that is equal to x minus y, and we just return. There we go. This is completely valid. We define it first, and then at the end you add it. If we run this, we'll get 5. If we were to remove this definition here, then first it would not know what sub is. Because nim goes from top to bottom, it first needs to have the definition before it can call it. So if you prefer having your functions below everything else, so let's say you have a main function, and the main function should be at the top of the page, and all the other functions should be underneath it. If you like having that, then this is the way to go, where you can just define or create references to these functions, but then define them or then actually implement them later on below that, let's say, main function you have. Now, let's say you want to get the array length. Procedure get rlen. And here we can pass in an array, which is of type open array that holds integers. Open array is a special parameter. So it's just a parameter. It's a special parameter that allows you to take in an array as a parameter. And then you don't have to indicate the array size. When you usually define an array, you need to indicate its size as well. So if you want to say this is an array, you will need to define its size here. So I think it's like int 3. And we can say int, like that, is equal to return len r. There we go. Like if you want to specify a normal array, it might be free int actually, then you will need to do this. But sometimes you don't know what the size of this array is going to be. Now you have two choices. You can either ask them to then pass in a sequence, which remember a sequence has worse performance than an array, so sometimes you do want an array. Plus if they are using an array, they will need to convert it from an array to a sequence and then pass it in. So sometimes you just want to let the person using the code or typing the code just pass in an array, but you cannot confirm what the size can be. In that case, you can do open array. Then you don't need to specify the size, in which case this is perfectly fine and you can just pass in any size array in there that you want. So get array length 1, 2, 3, and we can add one here which has more than the original. And then here we can of course just echo out. There we go. Now if we were to run this, we get 3 and 4 even though these arrays are of different sizes. That's the power of open array. It basically allows you to not have to specify how big the array needs to be. And other times, you might not want to necessarily take in an array, but you want to take in multiple values of the same type, of course. Then we could have something such as procedure print, which takes in the data, which is var args, and we specify it's of type string. And then this will echo something out for us, so it doesn't return anything, it's a void. And we can just echo out output, and then variable output is equal to nothing. Now what's going to happen here is this data that is going to be passed in can be multiple parameters stored inside of one. We're going to get something similar to an array. So here we can go and say for value in data, output becomes output plus the value, and let's also add a space. This is similar to how echo works, where you can say echo output 9 and lol. It's similar to that, where echo can do this. This, in this case, is just going to allow strings. But then here, we can just say print, hello, I am cool. So it will work exactly the same as if I were to say echo, but now we have our own custom version of echo called print, which also adds spaces whenever you give a comma. You can of course remove that, and then it will be basically the same as per echo, and now it's like that. So that is how echo does it. They use var args, which allows them to take in multiple value, and here we say var args typed. And then no matter what type you pass in here, you can add a value in here. Now, if you want to create something that is exactly the same as echo, where you can say hello 1 false, and let's say there's an exclamation mark. If you want to do something like this, and we were to run this, we'll of course get hello 1 false, and you want to be exactly the same as echo, we can do var args string colon $. This means take any value and convert it into a string. Then if we were to go here, run it, it will still work, but now we can also copy the same value here and apply it to print. As you can see, now all of them work. If you weren't going to include that, here we'll get an error saying string, bool, int, and string. So it can't allow that, in which case we'll get an error. So this is how echo is made. Let's start off with operator overloading. So what exactly is an operator? When we go echo 1 plus 2 as an example, this plus here is what's considered an operator. Now when you overload an operator, what you are doing is you're giving that operator a new function. As an example, let's go and put here 10 minus 7 as an example. If we run that, we know we will get 3. And then let's overwrite or overload this symbol here, that when it gets 2 integers, it will add them instead of subtract. So procedure, and then in these quotes here, we're just going to put a minus symbol there. Note that these quotes are not the single quotes or the double quotes, but the backticks. You'll find them left to the 1 on a normal US QWERTY keyboard. Then it's just a normal function that will take in usually 2 parameters, so x and y, and we can say both of them will be integers. This here will define what this operator will be overloading, and we'll get to why that is important in a second, and it returns an integer. Then we can just return x plus y. Now when we run this code, we'll get 17, because now 10 is being added to 7, because that is what we're saying this minus symbol should do. But take note, if we go 7.9 and we run this, we'll get 2.1. The reason for that is we're only overwriting this operator for integer values. Both of these values will need to be integers in order for this to work. If one of them is not an integer or both of them are not integers, this will not work. Now, a useful scenario for this could be, let's say you want to create a function that will add strings together. You know, if we go I am plus cool, this will cause an error because you cannot use a plus symbol with a string. But if we do this and we say x and y should be a string and it will return a string, then we can just put an ampersand there, and now we can use a plus symbol instead of an ampersand, meaning I am cool. Perfect output. So you can already see how this is becoming a very useful feature. Now generally, I would always recommend to stay away from operator overloading unless you need to do it. Let's say you have your own data type, which we'll get to in a future tutorial. But let's say you have your own object. You cannot subtract one object or class or whatever you want to call it from another.
So whilst I'm giving you a very basic example, it can be used for more powerful features. Now with a procedure, you can also use an auto type to guess the type of a parameter and return the type that you want. As an example, let's say procedure do it, and do it takes an X of type auto, and it also returns an auto. And then what we do is we say return, and actually let's use result. We almost never use result. I think we can use a little bit of practice with it, and that's a 99 plus X. Now for those of you who couldn't remember, result will basically just return at the end of a function. In this case, we could have just as well gone return and it wouldn't have made a difference. Anyhow, now let's say we go echo do it, and let's say 10. Now this will automatically determine that X should be of type int. And it will automatically figure that out because we are telling it that this can be any type that can be added to 99. If we run this, it works. If we put 10.9, it will work. So whether that's a float or an integer. Or if we put a string here, you'll notice we actually get an error because this auto cannot do it, as X is not capable of adding a string to an integer like that. So if we run this, Nim is smart enough to throw us an error at compile time telling us, no, you cannot do this. So auto will automatically figure out what type is being passed in and what type should be returned. Now, when exactly should you use auto like we're doing here? Generally, if you do not know the type of something, let's say you're importing an external library, but you do not know the type that function is going, or that variable is, or something like that, you could use auto to store it and it will figure it out on its own. However, try and stay away from auto as much as possible due to the fact that auto removes features from Nim that we usually want in a statically typed language. Cool. Next up, let's talk about static. Static is a value that cannot be changed. This means that it has to be a set value when used in a function, meaning you should know what that value is in compile time or during compile time. For those of you who don't understand, you have two times that I'm talking about. You have compile time and you have a runtime. Compile time is when you compile the program, and runtime is when you run the program. If something happens during compile time, then when the program compiles, it will be able to know what something is or to throw an error or whatnot. That's why you get runtime errors, which only happens when you run the program, and compile time errors, which only happens when you compile the program. So static means that something should be known at compile time. And as we know, let and var cannot be used in compile time, or they're not valid variables for compile time since they can be set by runtime. As an example, let's say procedure speak and speak will take in a name, which is a string, and then a script, which is a static string. So note the word static here. And then that can just echo out name and then the script. So we could do something like let ghost is equal to ghostly Jack. And then we can say speak ghost, and let's put a normal string in here first. Boo, what are you doing here? Cool. So let's run this, see what output we get. And we get what we expect. However, we should take note that if we were to go here and say let sc for script, and we were to just take this, put that there, and put sc in here, we will get an error because let is not a valid compile time value. So if we were to make this const instead, it would work as expected because const is available in compile time or during compile time.
This means that when someone uses this function, they should know for certain what the value is they're going to pass in here, since it will be known at compile time. So that is what the static keyword does. It just basically means the variable being passed in here needs to be known at compile time and not at runtime, or it can be known at runtime, but it should be known at compile time. Now let's take a look at anonymous functions. Now an anonymous function is a function that is generally without a name. It can be with a name such as var summation. There we go. And we make that equal to, and then in brackets, we say procedure, num1, num2, both are integers. And then we say int and num1 plus num2. This is a valid function. There might be no return or result, but this will be returned. If we were to go here and echo out summation of 7 and 9, we'll get the sum of those two numbers. In fact, we could go like this, and in 7 and 9, then if we save it, it will work as well. So this procedure, which is called an anonymous function or an anonymous procedure, can be used without actually giving it a name. You might be wondering, where exactly is something like this useful? Let's take the map function as an example. So let's echo out map, and then we throw a sequence in here. And we just need to import Segutils. There we go. Now you throw a sequence in here. 1, 2, 3. And then we can put an anonymous function in here. Let's remove that one. So we can say procedure, and in the value we get, and I'm going to explain all of this in a second, which then returns an int, and we get x times 10. All right, if we run this, we get 10, 20, 30. So what is happening is we are passing in this sequence. Then we're saying map through it, meaning for each value. So it's like a for loop. For each value inside of the sequence, run this procedure for us. So this x would first be 1, and then it's 1 times 10. That will give us 10. Then we'll go to the next value, 2. That will become x. So 2 times 10, that's 20. And then 3 times 10. That is what we are doing. For each value in here, run this function. Now this is the same as going for x in at 1, 2, 3, and let's just go var val is equal to like that. Then we say val.add x times 10, and then echo val. And here we should of course just say at sequence, and not an at, but let's sequence int. There we go. So this here is basically, not exactly, but it's basically doing this. It's creating this for loop for us, and it's all being done in one line. We just need to pass in this anonymous function. This is a use case where an anonymous function can be really useful. If you come from JavaScript, you will automatically use anonymous functions so much. In fact, we can make our anonymous functions look very similar to the anonymous functions in JavaScript. If we go here and import sugar, we can use sugar syntax to make this anonymous function look more like the ES6 syntax for anonymous function. If it sounds like I'm speaking gibberish, do not worry. All that sugar is going to do is allow us to use sugar syntax, meaning our syntax can become a little bit easier. So instead of doing all of this, we just go like that. And we can also remove this procedure keyword here. And now sugar syntax has made it very similar to the JavaScript syntax. That is that for anonymous functions. They're this simple. If we wanted to, we could even go let times func and go like that, and just say times func, and then pass times func in here. This would work exactly the same. There we go. And that is about that for procedures. As always, there's of course a lot more we could cover, but I think 3 parts on this topic is more than enough. If you know anything about OOP, object-oriented programming, it will be similar to this, as in we are not creating a custom type, but it can be used in a sense like that. If you have no idea what OOP is or how it works, or you're scared of it like I was when I first started with it, do not worry, we will get to that in a future tutorial. For right now, let's take a look. So first, to create our own type, we can use the type keyword. And in here we can define the types we want. Now the first data type you can use to create your own type is the tuple. So let's say we have a person, and that person is equal to a tuple, which has a name, which is a string, and an age, which is an int. So this is the first way to define your own type. Now if you want to declare it, we can just go var Jack, which is a person, and that is equal to, and then first you give it the name and then you give it the age. So just Jack and let's say 24. Then to get these details, you can just go simply echo Jack.name, and if you want to get the age, you just go Jack.age. If we save this and we run this, then we get Jack and 24. There we go, that's cleaner. Now you can declare tuples like this in multiple ways. You don't need to do it specifically like this. Let's say we have animal. Animal, we can also be a tuple. And here we just indent it, and anything in this indentation is also part of this tuple. So species is equal to a string, and then we also have edible, which is a boolean. As an example, a cow would be edible because you can make beef from it. Then here we can say pet which is of type animal, and you will declare it the same way. So this can be a dog and false. We don't need dogs here. And then of course we can access the same values by just going pet, and then instead of name and age, it will throw an error, as you can see here. We can input species and edible. Then of course if we run this, we'll get dog and false. Now if you want something that's a little less complex, maybe something that can only maybe store a couple of numbers, we can do my range, which is equal to a range of 0 to 5, meaning this anything that is of type my range can only hold the values 0 to 5. So here we can just say range for range, and that's of my range, and we can say 5, and then we can of course just echo out rang. If we run this, we'll get 5. If we were to put a 10 here and then run it, we'll get an error because we cannot put a 10 here because it only supports from 0 to 5. And then finally, let's go for something a bit more complex. We'll actually create an object. Now this is part of the object-oriented programming section of the course, but I'll give you a basic overview so we don't have to get too complex. So let's say we have a dog, and the dog is an object. Here, we can then say the name of the dog is a string, and the age of the dog is an int, and they should both be indented. Now, if we were to declare Jack a dog, and we can just actually say equal to dog, and we can actually specify name, and here we can say Jack, because the name of Jack is Jack, of course, and the age of Jack is 5. So our dog Jack is now, and this should of course be an integer, an object. So if we run this, we'll actually get name Jack at age 5, similar to a tuple. So in a sense, this will tupleify it for us. If we go to age, we'll get age. If we go to name, we'll get name. Simple as. And this is the basics of an object. So this is in a sense creating your own type using the type keyword. You create the type and then you can assign the type. So we can actually go like that, perfectly fine. And then that type can contain whatever is needed. And that's the basics of creating your own type. It can of course become a lot more complex than just creating an object. But for right now, I think this is a perfect place to end it off. Later on, we can actually look a bit more or deeper into the type system and creating more complex types. So a module are other Nim files outside of just your main.nim. You can use these files to organize your code or to make your life easier by putting functions in them and then assigning those functions to that specific module. Nim already has a bunch of these modules built in for us. They are found inside the standard library. So when we do something like import std, which means for standard library, and then strutils. strutils is a custom Nim module provided to us from the standard library in Nim. It allows us to do things like var a is equal to, this is a very long string, and then to go echo a.split as an example. This is part of the string utils module. If we were to not import this, we cannot use this function, because this function can only be used once we import this, since this will import the function for us. If we run this, we will get a split string. So this is a module. Now let's actually create our own custom modules. I'm going to clean up here. So let's create a file called mymodule.nim. Now this will be our module that we can use to do a couple of cool things. In this case, we are only going to have 3 functions: procedure, say hello, name, :string, and this will just echo hello, name. Now, of course, inside of this module, you are allowed to import modules from a different module, whether it is your own or one provided by Nim. This module is exactly the same as your main.nim file. The only difference is it isn't the main.nim file. This module will be imported instead. And to make sure we can use this say hello function outside of this module, we can use this asterisk, which means make this procedure public, meaning anyone can see and use this procedure. Now, if you weren't to add that, then this procedure is only available inside of this module. But once you add an asterisk, it is available inside of any module that imports this module. We can also do another one. Instead of saying say hello, we can do say goodbye. And here we can say goodbye. And then finally, let's create a module that is only available in this module. Or let's create a procedure that is only available in this module. Procedure, subtract, x, y, which are both int. It returns an int, and it returns x minus y. So this one is only available inside here. You'll notice we even get here that says it's declared, but it is never used. It doesn't say the same for these because they might be used outside of this module. Cool. Now that we have our own module with 2 public functions, procedures, and 1 non-public, let's actually import it. So we can just go import my module. And now we can say hello, Mike. If we were to run this, then we get hello, Mike. So we imported this function right here. Now let's say you want to import everything except for a specific function, because let's say you have already defined such a function in one of your modules or inside of your main.nim, and you do not want them to clash in any way. Then what you can do is you could say except say goodbye. This will import all of the functions or procedures inside of this module except for the say goodbye one. This is a great way to go about it if you have a say goodbye function already and you don't want this say goodbye function and that say goodbye function to cause issues in your code because they might work differently. If you run the code, it will still work, but now you cannot use a say goodbye unless you remove this except. Now you might be wondering, but what if the module is in a different folder? So let's create a new folder called custom. And here we can just add a new file called my other module.nim. And here we can create a procedure called print, which is a public procedure, and it can take in a word or text, which is of type string. And all it does is it makes sure that it calls echo on that piece of text. So if you like Python syntax more, then there you go. Now you have a Python print. And let's also do procedure draw line, which is public, and it just echoes out a line. Simple as. Now in here, if you need to import it from a different file or different folder, similar to how we did std/strutils, this std here, and you might also sometimes see people use pkg. These two are basically invisible folders. They're optional to put there, but they're in a sense invisible folders. Now, the same can be done here. So if I go custom, this is just not an invisible folder, it's one we created. If we say custom and we import my other module, so the one right there. So inside of custom, we have my other module. That's what we're doing here. Then we can do draw line, and now a line will be drawn. But let's say you want to import from that module, but you only want to import specific functions. Well, then you can say, instead of import, you can say from. So you're saying from this module, only import the draw line, and of course if you add a comma, you can add whatever else like print. But if you only want to import one thing, then you can just do draw line. Now the reason you might want to only import one or two things is because it can help reduce the chances of there being two functions with the same name that are being imported into your project, and now they are clashing and doesn't know which one should be used. My rule of thumb is usually if you're importing 5 or less items, use from and import them individually. If you're importing more than 5 items, then you can just use import and import everything. Now you might be wondering, okay, but what if you want to import multiple folders from this custom, or multiple files from this custom here? So let's just go mod, and I'm just gonna say mod.nim. Simple as. So let's just go procedure call me, which is a public procedure, takes in a number, and you know phone numbers should be stored as a string because they start with 0 or with plus, which cannot be stored inside of a number. And that is equal to echo calling number. There we go. So now here we have another one. Now one way you can do it is you can import like this, custom and then mod. And I think mod is a keyword. So let me just call this mod1. Okay, then here we can just, instead of mod, we say mod1. That's better because it was blue, so it was most likely a keyword. And we can just say import. What can I import? What did I just create? I created call me. And we do that, call me. Call me, and here we go, whatnot. Run it and it will work. Now there is a more efficient way of doing this. So let's say you just want to import them, you don't want to say from. So if we go like this, say import. Same here, we don't care about what we're importing. We just say import, and there we go. Now if we run this, it works as expected. However, you might notice that if you have a bunch of files inside of this folder, a bunch of modules, and you're importing a bunch of them, it might get a little crowded up here. So one thing you can do is go like this. Put brackets around here, say comma mod1, and this way, from the same folder, it will import both of these. So if we run this, it will still work because both of them are being imported. The only difference is this time we are using brackets. Now you don't need to store functions in here. Let's say with mod1, we can also have variables, such as variable name, which is equal to Nick. And let's also add another variable, age, int, which is equal to 55. Now take note, they are not public. We are not marking them as public. Sometimes with variables, you do need to mark them as public, and we'll get into when and why later in more tutorials. But for right now, just know that you do not have to mark these as public to use them. Now you can go here and say include and custom /mod1. Now what this is doing is it's including the code from that module. So if it's not public, you can say echo name and age. And now even though they're private variables, we can still use them. So we do this, Nick, and the age is 55. You could make them public as such, in which case you don't need to use include. You can just do this and it will work as well. I haven't really seen include being used in the wild, but it's good to know that it exists. And then finally, as the last module topic we have to cover, importing as. So to import as something, you can go and let's just copy this and say from my other module as MOM for my other module import, and we just import nil. Nil means don't import anything. This means if you want to use anything that is inside of this module, we need to use MOM. So MOM and then dot draw line. We can't just go draw line. As you'll see, if we remove this, we can't do that. We have to go MOM dot. Now, doing it like this, and if we run it, of course it works, is a very safe and great way to import modules. The reason behind it is, if you have multiple modules that you're importing, then those modules wouldn't fight with which function to use, and your functions won't have to fight with them either. So if I have a procedure draw line, and this procedure draw line doesn't draw line, it goes echo no, right? These two won't fight. If we just do this, import draw line, then now we have an issue because, and let's just remove that. Because now, which draw line do you think it will use? Will it use this one to be defined up here? Or this one we're importing? It will use the one to be defined up here, even though we're importing it. So if you do that, we'll get no. Now, this can also be an issue if you have two modules. Let's say my other module 2 as an example, and you also import drawline from there. Now, if we don't, let's say we don't have this one here. Now, which one will it use? We don't know. Probably the last one that was imported, even though you're importing both. That is why it is a good idea to sometimes do this. Import as and then give it an alias and then import nothing. Because when you do it like this, you know exactly what is coming from where. Now, it is not needed to do this. You could, of course, just go import OS, and then you can go OS dot and add a bunch of things here, such as is absolute, and I believe we just go /is/Google, and this will work as well. But the difference is, this here is only for your comfort. If you were to remove that, it will still work perfectly fine. So it's up to you which you prefer. You can either do it like this, or you can say from OS as OS import nil. Or you can do this. This also works. It's up to you which one you want. This one is basically, it forces you to use OS dot and what you want to use. Whilst this one gives you the option to add it or not add it. So it's up to you which you prefer. Do you like it when it's strict with you and it forces you to use OS or the alias dot? Or do you prefer it when you can remove this? In larger modules, you will always actually want to use this. Or in larger projects. In smaller projects, it doesn't really matter. It's up to you when you want to use it and how you want to use it. In this tutorial, we'll be taking a look at some useful small modules provided to us by Nim. Now, these modules are a little bit too small to have an entire video dedicated to them. So instead, we dedicate one larger video to all of them. So let's get started with a couple of them. First off, how does one get the CPU info from the host's computer? Well, one way to do it is just to import CPU info from the standard library and then to echo out CPU info and then we can count the processors. As simple as that. We run it, we get 4. That is true. If I say htop, then 0, 1, 2, 3, this is 4. These are my CPUs. And yeah, that's the only thing inside of CPU info at the moment. It will probably later on expand to hold more information or more functions that we can use. But in this case, I think count processors was the only one that's in here. Cool. Next up, let's import from std Strutils. So this is to have like C-styled string and stuff. So let's say var a is now a C string. So this is a C-styled string. Nothing really changes, but now we can manipulate it like a C string, I believe. So if we just echo out A, we'll just get hello world, not htop, my bad. We'll get hello world. But let's say we want to get starts with, and he. And this starts with actually comes from C string utils. So if we do this, then it works. Now, I don't really know what the difference is between a C string and a string. I believe it's most likely performance based, if I had to take a wild guess. Or maybe it helps with the compilation from Nim to C, because Nim can transpile down to C. And then you of course also have a bunch of functions you can use. Most of these we already know, but you also have things like isNil, deallocate implicit, I think. I don't really know a lot of C, but I believe a lot of these are C functions that we can use. So it's up to you. If you want to use a C related function to maybe have more control over your variable, your string, then you can use C string utils to accomplish that. Next up, let's take a look at strmisc, so string miscellaneous. So let's echo or let's just go expand tabs. Hello world, I am very cool. Now, if you might have forgotten, \t basically means give us a tab. Now, what this is going to do is it's going to lengthen the tabs. So it sets them to 4 spaces. If we were to just go like echo out a normal one, so echo a normal string of normal tabs. Now here we can just say 4 to make sure it goes 4 spaces. So if we were to run this now, we'll have this. Hello world, I am very cool. So we'll try and indent with 4 always. So 1, 2, 3, 4, then it starts over. 1, 2, 3, 4. Then here's the new thing. 1, 2, 3, 4. 1, 2, 3, 4. 1. 1, 2, 3, 4. There we go. 1, 2, 1, 2. So as you can see, it will always be 4. Now you can of course make this more. So instead of 4, we can go 10. Now it will be scary big, as you can see here. So you can use expand tabs to make tabs bigger, so be more spaces. You can also use partition. Now if we go here and say var :int and then put a colon here, then it will return a tuple with 3 strings split by the first colon it finds. So let's go like this. So var, and then it's split it at the colon, and then we get int. So of course, if we go colon again, var int var name, or something like that, then here we get var colon, and then int colon var name. So only by the first one it finds. Now you can do the same to get the last one by going r partition, meaning reverse partition. So if we do that, then now it will be var name colon, and then here's var int. Now let's import UNI decode. Now sometimes when you work with text, you might get code that is not English. And let's translate to Chinese. I have no idea what the difference is, and we can just go here and say English, and let's just say China. There we go. We copy this. Now here we say you need decode, and boom. So sometimes, let's say someone types Chinese into your app, and we just need to echo this. Or someone types Japanese in here. So goodbye, that would be sayonara. Where is Japanese? There we go. Just as an example, let's have two different languages, just so we know what we can expect. Okay, so now we have two different languages to test. Now if we were to run this file and decode this Chinese and Japanese we get sayonara and zonguo. Please excuse me if I butcher that. So basically it's Google Translate. It will take this and it will convert it to its English counterparts. Not the English word itself, but the English counterparts. So it will convert it into normal letters, Latin letters. But not the English word itself, just the English letters. Cool. Next up, let's go word wrap. And let me just put a nice long string here. Alright, so here I have a nice string. Hello, my name is Steve. I come from land far in the east called Shubalubagast, and it is a great place. Now we can just say word, wrap words, of course, wrap words, and we can import or put our string in there. Max line width, so this will make sure that the line width doesn't become too long. So line width is equal to 20. And then we can also say split long words, which is equal to true. So it will split long words up as well, and we just echo that, as make the max line length equal to 20 characters. So if we run this, hello, my name is Steve. I come from a land far in the east called Shubalubagast. Now if we were to make this maybe 10, and then run it, then called Shubalubagast. So it will break it up in a sense like that, where it will split long words up into two. So that will allow you to wrap text. So if you don't want text to be longer than, let's say, 20 characters, so each sentence should only be 20 characters or less, then this is a great way to go about it. Now sometimes you want to work with your Linux bros, and you want to know what distro they use. So then you just go distros, and then echo check OS, or detect OS, my bad. And let's say we try Manjaro. Now this will not be true because I do not run Manjaro. But if you run this, we'll get false. So I don't run Manjaro. In fact, I run Arch Linux, but specifically Endeavour OS. I don't know if we actually have. No, we don't have Endeavour. Arch Linux, we run that. And we get false as well. Most likely because I'm running Endeavour and it's not added here. But we can still check Linux, and this will specifically check if we are running Linux. It's true. You can also check for Windows, and we run that. It will be false. I'm not running Windows, and so on. You have macOS, POSIX, Ubuntu, Debian, Gentoo, Fedora, Red Hat, OpenSUSE, Elementary, Zorin, and the list goes on. You can even check if someone is running SteamOS, which is kind of neat. You can also go foreign dep installed cmd, and this will return the distro's native command line to install the specific software, and if it requires sudo privileges. Now take note, just because a native install tool is returned, that doesn't mean that it's the one that distro uses right now. Like if you're running Manjaro, it might return PKG. But PKG is for build packages, whilst it should actually use Pacman or return Pacman. So let's put tmux here, which is a terminal multiplexer that you can install. If we run this, we get your package manager here, install tmux true. Okay, so it can't detect my package manager. And it's most likely because I am on Endeavour OS, which isn't detected by detect OS. So it could be because of that, but if you might get something like pkg install tmux, which isn't correct, it should be pacman install tmux. And this will require sudo privileges, as you can see, it's true. So this will not work on all distros, so you just need to make sure, but it will work on the most popular Linux distros you're running on. And it will probably work on Windows if we're lucky as well, I have no idea. You can also check foreign deps, which will add dependencies to your application. So let's say as an example, lbibls-dev, there's a random word there if we run that, and this will not echo, we should just go like that, and it should be foreign dep, not foreign deps. If we were to run that, then now this will be added as a dependency for this application. So now if we go echo foreign deps, and we'll take a look at what foreign dependencies are required to run this application, it will say nothing in this case. Let's maybe just add that foreign dep and then echo foreign dep below it. Now if we were to run this, then here, there's the random package. So they will also show you that you need to use sudo, and then you need to put the package manager here. In this case, it can't detect what mine is, install and that. So we can check if we have all the foreign dependencies that we require. If not, we can actually just echo out the foreign dependencies we need. So you put this at the start of your application with how many ever dependencies you want to add. And then once you go here, it will just install. It will just give you an output here telling you what you need to install. So if one of my foreign dependencies is MPV, I can put it here and tell them, okay, you need to install MPV in order to use this software. So let's start with import std sums. And then just echo sum kbn. And this will add all the values in an array together to give you the total. So let's just add an array here, 1, 2, 3. We run this, we get 6 because 1 plus 2, that's 3, 3 plus 3, that's 6. Simple as. Next up, we have random. And here we can just do randomize. Now in Nim, just like with other languages such as Lua, Delphi, and C++, you need to specify this to make sure you get really random values. In C++, you might notice if you don't specify randomize somewhere, you will not get random values. Sometimes these values will repeat or they'll be easy to guess, but with randomize, they're more random. And of course, you can just go rand to get your random number. And let's say 5.9, meaning we'll get a random number between 0.0 and 5.9. Now if we were to run this, we will get 1.51373. You can also create an array, so var array, which is 1, 5, that should be a comma, not a dot, 6, 7, 8, and then echo sample R. Now this will take an array or a sequence or whatever, and it will pick a random value from that array. So in this case, we get 7. If we run it again, we get 5, 8, 6. Now, let's say we didn't specify randomize here, because you might be wondering, okay, but what really is the point of randomize? So I'm going to comment it out, and we're going to run this program. And we get 6, we get 6, we get it again, we get it again. As you can see, it's no longer random, it's only random once, and then after that, it repeats its normal randomness. But if we specify to randomize, then now, we'll get 5, 5, 1, 5, 1, 6, and each time we'll get a randomly chosen value instead of always getting one value. And you can also, of course, shuffle an array, so shuffle. And when you shuffle an array, and that will permanently modify the array, so echo array, it will modify the order in which the items in the array is. So in this case, we get 86571, 18657, and so on. Next up, we can have parseUtils. And this will give us a couple of utilities that we can use to parse text. So here we can go echo capture between, and let's just create a variable and hello world. Now capture between text E. Now what this means is return whatever is between the first E in the string and the end of the string. So we'll get hello world. So there. Just without the E. So we'll get hello world. So from the very first E until the end of the string. You can also specify where it should end at. So let's say R. So from the first E you find until the first R you find. So we go like that, LLOWO. You can also specify where to start. So start is equal to 5. And now it will not return anything. Let's just specify O so it actually has a value. We go like that and we get ORLD because 0, 1, 2, 3, 4, and 5. So it will start somewhere here and it will search for the first O it finds and then return from there until the end of the string. If we did not specify start, we would have gotten world. Now you can also go something like var c, and that is a float of type 64, meaning it's a 64-bit float, meaning it is accurate, I believe, until the 64th digit after the dot. Anyhow, then here we can use parse biggest float. You also have parse biggest int, and in this case we can just go 19.23532212, just a random one, put it inside of the C variable we declared, and then echo out C. Now if we were to run this, we'll get 11, and then here we get the actual value. First it returns the string length and then converts the string to the C variable that can store a float 64 data type in it. Now you also have more than just these. You can also have the parse biggest int, parse bin, parse char, parse float, parse int. And basically they all do the same thing, but just with different types. Object-oriented programming has a core fundamental idea that everything you're working with is some sort of object. Now, OOP has things like, let's say you have an animal, and that animal is an object. You have a boat, that boat is an object. Where in functional programming, you'd have things like a boat, but it will be a data type, or some sort of data that's raw. It wouldn't be modified to be some sort of object. On the end of the day, you do not need to use OOP in your day-to-day coding, but the same can be said for functional programming. You can choose either or use both. I use both. I use them as I see they will fit to work. So let's do an example of that. Let's create a new file. Let's delete everything else in here, except for main.nim. Since we now know how modules work, we don't need these. And let's create a new file called animal.nim. Now, animal.nim will contain our animal object, and our animal object will contain data of an animal. So we can say type, and we specify animal, and we use an asterisk to specify this object is going to be public, so we can use this object outside of this file. We can then make that equal to an object, and by indenting, we will be adding attributes to this object. So we can add a name, so every animal can have a name. We provide an asterisk here as well, because if you don't provide an asterisk, this will be a private property of this object. A private property of this object cannot be accessed in a different file. So if you add an asterisk, then if another file imports this object or this file, we'd be able to access it. So this name. But if it was like this and we said string, we would not be able to access name here. We'll take a deeper look at this a little bit later. And we can add two more. One can be alive, so the animal is it alive, and one can be fullness, so how full is the animal after eating. Alive can be a boolean and fullness can be an int, so let's say 20%. Cool. Now we already have this object, however we can't do a lot with it. Currently it's just structured data. We just have an animal object and it has a name, an alive state, and how full it is. So it's not very useful, but we can add functions to it. So let's start by creating a procedure called unlive. Now the reason I'm calling it unlive is so I can still say they monetized on YouTube. Thank you, YouTube. And we can say animal. Now we go var animal. Now by doing this, we're saying this animal here is linked to this animal object. So this function here is linked to this object. It's now a function of that object. And here we just specify animal.alive. So this is how we can access the alive property of this animal. And we'll get to actually using these stuff later and whatnot. But for right now, this is how you can access this property inside of animal. And we can set that to false, so they are no longer alive. And we can just maybe echo animal.name. So now we can access the name as well. And was overfed. So in this case, we're assuming they're overfed. We're not going to go super complex. Note, unalive is a private function. It cannot be used outside of this file. That's why we don't have an asterisk here. Next up, let's create a procedure called feed. And feed will be public. And just like with unalive, we will take animal, pass it in like this. So it is this property here. And the reason we use var here and not just this is because when we do this here, we need to modify the original animal. If we do not specify var here, we will not modify the original object. We will create a new object and give it that new attribute. By specifying var here, we're saying pass it in by reference. Then here we can say if animal.fullness is less than 100, then animal.fullness plus equal 1. Else, if their fullness is not less than 100, then animal.unalive or unlive. So here you'll notice we access this unlive here by just using a dot. So we just use dot and unlive. As simple as that. Now, by running unlive here, our animal will now no longer be alive. And note, we can still use this unalive or unlive because it is part of this animal object, and just because it's private doesn't mean we can't use it. It's just a private function to this animal object now. And then we can also go procedure is full, which is public, which will get the animal. However, in this case, since we are not modifying any values within this animal here, we can just go animal. If you are modifying a value, such as fullness or name or alive, if you are changing them, then you want to pass in by a reference. But if you're not changing anything, there's no reason to pass in by reference. You can just pass in normally. And of course we can say boolean, because it returns true or false. And then here we can just say return animal fullness more than 80. So if it's full, it will return true. So in this case, we cannot modify the original. If we were to go animal.alive is equal to false, it will not affect, as you can see here, cannot be assigned to. It will not affect this animal alive because we are not passing in by reference. We're just passing in a normal variable. It copies it and then changes it here. We're not even returning this animal again. So there's no reason for us to change it here. So that is the difference there. Now let's actually use this object we created. in main.nim, to use the object, all we need to do is go import animal. Now we import our module, and as simple as that, we can use this animal. So here we can say for Timmy, like all other human beings, is an animal, and they have a name, Timmy, they are alive, and their fullness is, let's say, 98. There we go. Now, Timmy here, we can access about any value from Timmy. And it does not need to be var, it can be lit. Doesn't really matter. Anyhow, by going echo Timmy dot, and then here is everything we can use. Notice unlive is not here, due to the fact that unlive is private, but everything else we can access. So we can check is Timmy full, and here we can go dot, we can check the fullness itself, we can check the name, and we can check the live status. Run this, and there we go. They are full, it's 98, Timmy is the name, and they are alive. Now we can simply go Timmy.feed, and again, Timmy.feed, and then Timmy will no longer be of this realm. And the reason we're getting that is this should actually be var, since the values inside of it can change. So that actually does matter. My bad. Now when we feed Timmy 2 times, he will now be full and he will be unalived. So if we run this, we get 100, Timmy, and true. Now I think, yes, as long as it is less than 100, okay, so we just need to feed Timmy one more time and we'll get the message saying Timmy is no longer, or he is now overfed. And then he has been unalived. And that is how you modify these values in here. Hopefully this gave you an idea of the basics of objects and how they work. However, there's still a lot more to cover, so let's actually go to covering a couple more. So this is the basics of creating one of these. Of course, you don't need to create a module for it. That's just generally good practice to create a module for each and every class. But you could have done this and it would have worked out perfectly fine as well. In our case, creating a module just keeps everything cleaner. Alright, so let's create a couple more objects. In this case, let's create a type, and we'll call it person. Person is a ref object of root object. Now, let me explain this. So, ref is just used to extend, or in other words, inherit from an object. In this case, we're inheriting from the root object, which is just a basic object that is provided by Nim. It is like the most root or the most bare bones version of an object you can get. Without root object though, other projects would not be allowed to inherit, or other objects would not be allowed to inherit from this object. So you need to extend root object so other objects has the ability to extend this object, if that makes sense. However, you mainly don't have to worry about this. This is only if you want your object to be extendable. And we'll get to what I mean by extendable later on. So here we go, name, and let's just make that public. It's a string. Here we have age, and that's an int. Age, however, is going to be private, just as an example. Then let's create another type. This type will be called student. Now I can think of a student as another person. If you look at the student next to you in class, that's a person. Even though you may not like them, they're still a person. So in our case, our student is still going to be a person. They're still going to have a name, they're still going to have an age, but this time, because they're a student, they might have a grade and an IQ attached. So we can say ref object of, and now we'll inherit the person, and we'll add grade, which is an int, and IQ, which is an int. Now, let's just use this a little bit just so we know what we're talking about. So let's create a person, and we can even go as far as doing something like this. Person person, and we can later on implement the actual person. We're going person is equal to person, name, Nick, and age 50. As simple as that. Now it's as easy as going echo person.name and person.age. If we run this, we get Nick and 50. However, take note, unlike with other languages, just because this here is a private property does not mean we can't use it outside of the function. That is one thing you do need to take note of. This only means you can't use it outside of a file. So that is why it's usually a good idea to create a whole new file when you want to create an object, because this will allow you to have easier access control to properties inside of your object. But as simple as that, we have Nick and 50. Now if we want to create a student, we can do student, which is of type student, and they are a student, and here we can add all of the properties. Grade, let's say they are a grade 10. So let's just make it an average of 50. But the difference is here, we have more than just grade and IQ. Because we extended the person object, we also have the name and age. So here we go, name, and we can make their name Jack, and age, which we can make, I believe 16 is the age, that's in grade 10. So now we have a student, which has all of the properties of person, as well as all of the properties of student, because student inherits of person, meaning student gets everything person has. This is nice because that means each object you build can build off of the previous object you made. For example, a car object doesn't need to have a ton of things. You just have a wheel object, and then the car object inherits the wheel object. Now the car can have the wheels and all of its properties. And it can inherit the windows and everything else and all of those things' properties. That means you don't need one massive object. You can just have one big object that has a ton of minor objects inside of it. Inheritance is something you have to play with to grasp. So if you're new to programming, you might be thinking to yourself, you don't quite understand what's up with this. The whole object-oriented approach to a lot of beginners might be difficult. So if you're a beginner and you're having trouble understanding, it's not as difficult as you try to perceive it. It's just an object. You can think of it as a car is an object. A car has windows, a car has tires, just like a person has a name and a person has an age. And here all we're doing is we're giving that person their name and age. And now we're saving it in this variable. Whenever we want to access it, we do this. Now, next up, let's go and let's give these methods. Or let's give student method at least. And also we can put student here and it should work the same. It's basically drop-in replacement, IQ, and grade. If we run that, we get Jack, 16, 50, and 10. Anyhow, so let's create a couple of methods for our student to use. Now we could go procedure and say study, and this will make the student study. However, I want us to use, instead of procedure or function, I want us to use method. Now, method is the same as a procedure, but it has been specifically made to be used with classes. The reason for this is so it's easier to understand your code. You might have procedures, which is basically the all-around thing you use, but methods, since it's directed to classes, it makes a couple of things easier for you. For example, we can do something such as this, or self, or whatever you want to call this. You can even call this person, or X, or Y, or whatnot. In this case, I'll call it this, because a lot of you might be coming from C++ or Java, and this might make it a bit easier. And we say student. Take note here, we do not have to say this var student, because this is a method. So it will automatically go, oh, okay, I am part of this. I'm part of this student here, so it will automatically get that mentality. So you do not need to go var student. In fact, let's leave it there for a second. Say string, and then also at the end, add this base. So this is currently out of the scope of this tutorial, but just note that basically all methods requires this base tag here. But we'll cover these more in the future. For right now, just use base. And we can make that equal to just this dot I. Yeah, let's of course indent this dot IQ plus equal 5. So now it'll be 5 IQ smarter. And you'll notice you won't get any errors if you do this. In fact, let's go student.iq here. Now, oops, my bad. Let's just remove that. We didn't need that string there. That's for a different function. Here, now all we need to do is just copy that. We then go student, of course, dot study. And if we run this, my bad. If we run this, we'll get 50 and then it's 55. If we remove this var, you'll notice we don't get any errors and it works the same. That's the benefit of using a method over a procedure when it comes to classes or objects, because this method here just makes it 20 times easier since it knows it's going to be used with a class or an object. We can also give a method to person. And here we can go birthday. And we can just go age plus equal 1. Now, we can actually copy this. And the first one can be a person. And we can just get their age. Same here of student, get their age. And we just go dot birthday. And I deleted my person. Let me just go person again. There we go. You'll notice we can use student here as well. We'll also have birthday. So student and person both have the birthday function. And here you'll notice we get 50, 51, and then 16, and then 17. And we can of course pass in more values in here. For example, we can say years. And in years here, we can specify it in here. Like have a birthday with 5 years in the future. And of course, it won't do anything unless we go years. And let's just make that 1 by default. Now, if we run that, we go 50, then 55. And here, it's 16 to 17. This is just to show you the versatility of how these methods and functions and procedures and whatnot work. The first value here, that's just what you're going to be using this with, the object. And then the rest is just values you can pass in. And then finally, let's add one more, just so we can get the hang of this. Method getIQ. This student, so this will be a function of the student. Note, however, now that we're on this topic, we cannot use study with person because person doesn't have grade or IQ. It doesn't have study, and it's not going to have getIQ. Only student has that. Student has all the things of person because student is inheriting everything from person, just like you would inherit things from your parents. You might inherit your parents' wealth. You might inherit your parents' hairstyles or eye colors. Student inherits from person. So you can think of this as the child and then the parent. And then this is the grandpa. And you can use this child-parent method to think of how everything will work. Like I inherited my name from my dad. So I have my dad's name. So that is something I inherited. It's also a property I inherited as a person. Every person has a name. Anyhow, so that's just something you take note of. And in here, let's go getIQ. It will return a string. And we can just specify base. And in return, this.name has an IQ of this.IQ. And we can use $symbol here since we need to convert this integer into a string. So that's just a normal function for Nim. Doesn't have anything to do with the classes, just $to convert. And now here we can of course go getIQ. And now it will get us the IQ of this student. And of course, this needs something, so we can go echo. We can't just not do anything with it. And boom. As simple as that, Jack has an IQ of 50. So that's the basics of OOP. If you're having trouble wrapping your head around this, it's perfectly fine. Some people do take a while to grasp the concept of OOP, what it does, how it works. But in simple terms, it's just an object. It's just like a car or a person, as you can see here, with properties like name and age, and functions attached to it. You cannot use this getIQ without a student, as simple as that. And it just makes your code somewhat more structured. You don't have to use it. Some people are completely against it. Others are completely for it. I myself do not care for it that much. If I see a use for it, I'll use it. If I don't see a use for it, I won't use it. Usually, when I do game development specifically, you'll notice I would use this because I find it to be easier to manage when you do game development. Okay, and then finally, I would just like us to do a couple more things. So here we have student. If we do student like this, you'll notice we get an error because it doesn't know how to display student. But if we add brackets to the end, it will be able to display student for us. There we go. Grade, IQ, name, and age. Simple as that. Next up, we can also go if student of student. And this will check if the variable is of this type of object. So you want to see if student is a student type. We can then just echo it is. If we run this, we'll get it is. If we were to say person, we'd get it is because student inherits from person. So student is still a person. It's just a person extended. But if we were to put person here and say student, then we won't get anything because a person is not a student. Just because you're a person doesn't mean you're in school. You might be at work now, so you're not a student. But a person is still a person. And even though, notice here, Nim is telling us like, hey, there's no reason to compare them because a person is a person. But yeah, there you go, it is. So that's an easy way to tell if something is of a type object, or if it's inheriting from it at least. Let's import std strutils. Then let's say we have parse int, and let's echo that out just for interest's sake. Now when we run this, we get this error here. Well, we don't get any error here. When we try and run this, we get an error because this right here cannot be parsed into an integer. A is a string and a string alone. However, the code still runs. So if we go echo test, you'll notice we get test and then we get an error. This is known as a runtime error. You get a couple types of errors, but the ones you need to know most would be runtime and compile time. So runtime errors, as the name suggests, happens during the program runtime, whilst compile time errors happens when the program is compiled. Usually Nim's IntelliSense will tell us if there is a compile time error. For example, if I try to do this, it will tell me, hey, this isn't going to work. So it can see that here will be a compile time error because the compiler will notice we cannot put a string inside of single quotes because that would be a character. However, compile time cannot figure out that this will be wrong because it doesn't read the value we pass in here, only the type. So here, it won't see anything, but when we run it, we'll get this error. Now, there's a way we can get around this. We can say try and accept. Now, let's first just do normal accept here, and let's put this here. Now, the idea is we're going to try to execute this line of code. If an error happens, we should do something here. So try, but if an exception occurs, do this.
So here we could say echo, oh no, error. If we run this, we get oh no error. Now the reason this is useful is because when a runtime error hits us, so if we just run this normally, and here we then try echo hello, you'll notice that once a runtime error is hit, the program quits. And a lot of times this is not what you want. If an error occurs, you don't want the user that was running the program to see this. You either want the program to go on or to display better error message. But if we try this try except here, then you'll notice the program never stops running. So it will continue running while we're doing this. If you wanted to stop running, you could always exit the program in except here. But if you don't want it to stop running, this is a great way to do it, like a web server. You don't want a website to go down if one person accidentally made an oopsie. You want the website to stay up for everyone. Thus, you should have a lot of try and excepts, and you make sure the website stays online. Now, what if you want to get the error message? Well, then you can just say let e for error, but you can give this any type of variable name, is equal to get current exception. And this will get the exception. So you'll notice here this is of type exception. And in here we could of course go e.msg for error message. Now if we were to run it, it will also display the error message for us. So here, error invalid integer a. However, if you don't want to store it in a variable, you could also just go get current exception message, and I will of course get the current exception message. Now if we run this, it will do the same thing, but this time you don't have to store it in a variable first. Depends on what you want to do. Now oftentimes you want to catch an error depending on its value. In this case, it will catch any sort of error. It doesn't matter what type of error it is, it will catch any of them. But in this case, it throws a value error. So in this scenario here, it would actually be better to go accept value error as e. So we'll get the value error and store it inside of e. This method here is an alternative way if you don't want to store it like this. So if you don't want to store this value inside of e, then you can always go let and store it using the method we used, get current exception. But if you have this, then we could go here and say, oh no, or even value error, and then something like can parse string in variable a or whatnot. And then here we can say message, and it's the same syntax. All we have to do is just say e.msg, and boom, Bob's your uncle. There we go, value error, message, invalid integer a. So here it threw a value error, and it's simple to see how we can fix it. Now we go up here to know what error you're going to get. When you don't use a try and except, it will actually show you what error you get. So we go to the previous output, you'll notice when we didn't use try except, it showed value error. And that's how you can get the error message that you should try and except here. But it's also a good idea to have another except here, just in case some sort of error that you haven't planned for happens. So this will catch any and everything else. And here we can just say echo unknown error. And now it will get any other error that is not a value error. So if something happens here and you don't get this, it will go to this here. And then of course, if you wanted to do more, you could of course go except and then whatever other error you want to put here. So there's key error, value error, field error, index error, like index error as e, and you can of course do the same thing. Now I can say, hey, there has been an index error as such. In this case, it seems index error has actually been deprecated. So in this case, I believe we should use index defect. Yeah, that seems to work. But yeah, so that is how you can do it. So you can catch individual ones, and you can catch all of them that does not fall into this here. Now you might be wondering, okay, but what if I still want to do something, even if I get an error? or even if I don't get an error, doesn't matter which one. Let's say we have a file. So if our users is of type file. Now if open users.txt, so if we open up the users.txt file, and it is open, we can try and do a bunch of things. Let's go like that. In fact, let's try and parse users.readLine. So it's going to read a line, and we're going to try and parse it, but that will probably not be possible. So we'll get a value error. Now here, we can add a finally. Now when you hit a finally, you can basically do anything. Whether you get an error or whether you not get an error, this finally will always execute. So we can say close users, because we would still want to close this users file. Now of course, in most cases, you don't even need a finally, you can just do this. But let's say you do not do this exception here, so any exception can happen. Then in that case, this finally will still execute before the entire program terminates, making this finally incredibly useful because you will still close the file. Because if you were to try and put this closed file here, it won't execute because this will cause an error. So it won't go to the next line. So finally here, you can at least make sure the program or the file will close. And we can even go echo closing file just to see how it works. Now let's go here and create users.txt, and we go hello. Now if we were to run this, here we go. So we get value error, message invalid integer, hello, closing file. So even though it caught this error, it still closed the file. So even if I were to remove this value error catch here, and I were to run this here, you'll notice we still get closing file. Even though the program terminated because we don't have an except to handle this, it still made sure to close this file for us because this finally will run whether there is an error or not. And only once this finally has completed running, then it will break out of the program and show us the error. Alright, now that we know the basics of try and except, let's use them a little bit more. So let's say we have a variable a, and that should be a var, and variable a is equal to try, parse int, and actually let's import strutils again, and now we have parse int, and we try to parse int 1. Now trying to do this will actually cause an error. So we can say except. So if an error occurs, any error whatsoever, just make it -1. And finally, echo variable was assigned. Now finally here is optional, but the idea is we're going to try and assign this value to a. If an error occurs during the process of trying to sign or save this value in a, then we're going to run this exception here, and that's just going to return -1. Finally, it won't return anything, but it will run this piece of code for us. And this is all in one line, just to make it nice and easy. So now if we try and echo a, and we run this, we get variable was assigned and -1. But if we were to make this 2 here, then you'll notice now we have 2. So if an error occurs, use this one. If it doesn't, use this one. And as I said, finally is optional. If I were to remove that, nothing will change. And of course, you don't need all of this in one line. If we do this, then all we need to do is indent it. And now it will be part of this try and except here. If we run this, then we get the same value or the same output. This is actually a very nice feature because a lot of times you want to assign a value to a variable, and in other programming languages you will need to wrap this entire variable inside of a try-catch block. But in this scenario, Nim makes it so easy that you literally assign a try and except to this variable, and that will provide you with a value. Let's create our own exception. So currently we have pre-built exceptions which are basically like the IO error, the OS error, all of these that we're trying and then accept the type of error as E, whatnot. But we can actually raise our own custom exception. Such as if we were to say try, then here if we go IO error as E, then here we can actually raise, in other languages this might be called throw, in custom error or a custom exception. So we say raise new exception, and here we just say what exception we are inheriting from. So this will basically be, let's say it's a custom version of an input-output error. So we want to inherit from that error. So IO error. And here we can just say custom IO failed error message. Then here we could of course echo out in IO error has occurred. And we can of course just e.msg. Here we go. Now if we were to run this, we'll get an IO error has occurred custom IO failed error message. So here we're throwing our own IO error, but also giving it a custom message. So this is like our own custom exception that we're throwing. So whenever an IO error is thrown and we raised one here, then it will pop up here and we can manage it however we need. Now you can also specify what type of error should be thrown in a function or a procedure. So we go procedure throw error, and then we ask, do you want to throw an IO error? If not, we'll default to an OS error. We say boolean. And in here, we can actually, and this is primarily just if you're creating a library and basically someone else will use your code, or if you want to make your code more readable in the future, this pragma, which is this attribute we're adding to the end of this procedure, which we'll get to more in depth later. But this pragma will allow us to specify what errors this procedure may throw, such as raises, and we say colon, and in this array here, we specify the types of error. In our case, either an IO error or an OS error. And then finally, we actually go to the procedure. So that's how it would look if it didn't wrap my text. Then here we can say if they passed in IO error, then we raise a new exception. We say it is of type IO error, and we just specify IO error was raised. And then of course we can say else raise new exception OS error with the same type of error message, and then OS. Now of course we can try this, and we can say try, and first let's try and go IO error, and we say throw error true. We can catch this error as E, and we can echo out e.msg except, and here we can just say OS error. Now if we were to run this, we get IO error was raised. If this were to be false, we would get an OS error. Now note, when you specify these here, you can still run normal code. These are just the errors it might throw. For example, let's just say it might throw an OS error. In that case, we can maybe just go here. Yeah, that's fine. If IO error, it will throw in, or not IO, we can just say error. There we go. So if we specify an error, then we can just print out or throw this OS error. Otherwise, we can just return cool, no error. And of course here we can just specify it will return a string. And if we throw the error, let's say false, and let's echo that out. And then we can of course catch an OS error. Now if we run this, we'll get cool, no error was thrown. However, we do know this function may throw an OS error. So if we were to say true here, we can run this and we'll get an error that was raised. If we were to do this, which is, I think it's this by default, but if we were to do this, it means that no error will actually be thrown here by us. It might be thrown by a different function happening inside of this function. So let's say this reads a file, and all this does is it calls the read file method. And when it calls it, that read file method might throw an error. Let's say you get an error of authentication because you're not allowed to read the file. Then you might get an IO error. Let's say we say raise new exception, and we specify an OS error. And we say OS error. Now here we get an can raise an unlisted exception because we have this here. If we were to specify OS error here and save, we will not get this issue. But because we specify that we will not be raising any errors like this, we are getting this error because it says, hey, you cannot do this. You cannot say that. So if we try to run this, we'll actually get, you cannot do this. We'll get a big error. But take note, not all errors are created equal. You also have some defects, such as the div by 0 defect. If you were to raise this, it will not throw an error, or it will not see this as an error. The reason for this is because if we were to try and do something like this, let's just say discard, meaning throw away the value we get here. We don't really care about the value, we just want to run it. Then div 0. Now if the user passed in a value in here, let me also remove this, and it was not 10 divided by 0, it was 10 divided by the value the user passed in. This is a defect instead of an error because we cannot know why this error or when this error will occur. So in this case, we will just get a normal error, but we will not be forced to not run this. As you can see, we get an execution, we get an error here, but it was during runtime. And here it says div by 0 defect. So that is what's happening here. We can of course prevent this by putting our own try and except here. So try doing this, except div by 0 defect, return failed, otherwise return passed. Now if we were to run this here, it would just say fail. Now this is somewhat in the form of your custom error, but it's more like just throwing an error. If you really want to create your own custom error, let's get into that. We can go type, so we're specifying a new type we want to define. Let's say custom error. And this is of type object, or not type, it is equal to type object of exception. This is the same as what we had in the OOP tutorial, almost same as that. In this case, we are extending this exception here. So we're creating our own custom exception that extends exception. So here we have two custom errors, but you'll notice if we go here, it says inherit from more precise exception, like a value error, IO error, OS error. So we could just put this OS error here. So that then you're inheriting from a more specific error in a specific place. The reason you might want to do this is if your error is related to an already existing error, but just differentiates a little bit, it's better to do this because an exception is everything. An exception is every exception imaginable. So it's not a great idea to inherit from specifically exception. But for this tutorial scenario, let's just do that. Then here we can have var c is equal to, let's say 2. Then we'll go try. And here we can say if c is equal to 1, raise new exception. We throw our custom error here. And this is my custom ERR. There we go. Then we can say elif c is equal to 2. We can raise our second custom error. In this case, it might say OS error, but for our scenario, it doesn't really matter what it says here. And we just say 2 here. And then of course, we can just say else, and we just raise a normal input-output error. Then here we can catch specific errors that we created. Now you can give your own little name for these errors that is more descriptive than custom, such as C not equal error or something like that. But then we can say custom error as E, or in this case, let's go a little bit back here, custom error 2 as E, just so we can have a little bit of variety here. And then we can just use normal except. Then here we can echo custom error. Here we can echo e.msg. And in here we can just echo all other errors. There we go. So this is just an example of creating your own custom error by inheriting from an already existing exception. And here we're just again going through the basics, so you can just accept specifically without no message. You can accept, but then save it in a variable, and then you can accept, and it will just throw everything else in that accept. Now when we run this, then here we get this is my custom error 2. If we were to make this equal to 1, of course we'll get our custom error, and if we were to make it equal to 3 or anything else, then we'll get that IO error. Alright, and finally, let's take a look. This is not really error handling that much, but it does something very similar to it. Let's look at defer. Now this is a very popular feature in some other programming languages, and I personally love using it in a lot of places. Now take note, defer cannot be used on the top level, so it needs to be inside some sort of function to be able to be used. So it needs to be indented somewhere. So let's say procedure defs for defer. And here, let's say we try and open our users.txt file, the one right here. Let's say we try and open that in append mode. So var d is equal to open users.txt in fm append mode. And in here we say d.write JSON. Okay, there we go. Now the issue of this is we forgot to close D. This is something that happens very often, and we need to close it. So let's go here and say close D. But now we have another issue. What if during the write process, this right here failed? Then D would never get closed and freed from memory. What do we do then? Well, what we could do is we could throw this in a try and accept, so try, and we'll try to do this. And then finally, we say close D. But what we could do instead of this is we move close here and just say defer close D. Now what defer here will do is everything we just showed you. It will write that try and finally for you. So if an error happens, close D will run before that error stops the program. And of course we can test this out by going defs. And if we run this, let's run this. Okay, it seemed to work. If we were to take a look here, then we get hello in JSON. So let's get started. Let's go import std re. And this will allow us to use a lot of reject features inside of Nim. Alright, let's start. So let's go let a, and let a is equal to re, and then end quote \S. Now re is how you define a regex string in Nim, which is different than a normal string in Nim. If we were to hover over a here, you'll notice its type is regex, not string, but regex. And \S matches any character that is not a white space. So if we were to say echo contains hello world, and we specify a here, then we will get true, because it matches any value that is not a space. But if this was just a space, we will get false, because there is no value that is not a space in here. We can also use without a variable by going RE, and let's specify E as an example. This is also perfectly fine. We'll get true because there is an E here, but we can also specify where it should start searching, at what index. So if we were to specify 6 here, it will start searching for any letter E from index 6. So let's see here, that is 5, so 0, 1, 2, 3, 4, 5, 6. So about from here, it will start searching, but there's no E in world, so we will get false. So it's the string, the regex you want to test against, and then this value here would be the index at which this regex should start working in that string. Now you can also use find. Now find here, if we were to take a look, would be like this. I am 28 tomorrow. And this will be a little bit more of a complex example, but it will still be pretty good. So here we go \d asterisk, and then in brackets 0, 2, 4, 6, 8. Save that. Now this find here, we'll see if it contains any of these digits in here. If it does, it will return the index at which the pattern has been found at. In this case, it should return 0, 1, 2, 3, 4, 5. It should return index 5. And it will only work here because this 2 is in this pattern. So any digit that is in this pattern, so either 0, 2, 4, 6, or 8. If we were to run this, and let's put another one below it, called 20, or not 27, let's just put it 17. In this case, it won't match anything here, and let's put another one here. Let's make this top one actually 18. So it will match the first one here at index 5, then index 6, and then no index at all. If we were to run this, we get index 5. And the reason this one is also index 5 is because this is where the entire word starts. So if this was something like this, it would still be 5 because this here is one word. So it will still be 5 because that's where the word starts, not the pattern. And then of course you'll get -1 if there is no pattern at all. And of course, again, you can specify at what index it might need to start at. So let's say when you start at index 7. Now if we were to run this, we'll get 7. Because it cannot see anything before it, so even if it's in the middle of a word, its lowest index will be 7. In this case, if we were to do this, it will be a bit higher because now there's another word there. So it's 12 because it only matches here first. Now you can also, let's add another thing here. Today I am 27. Let's say you don't want to find just one, you want to find all of them. So then you can say find all. Now if we were to run this, it will find all the substrings that contains this. So in this scenario, it will only return the values that match it, but not their index or the whole word. So it finds the substring. In this case, it finds 28 and 2, because 28 is here and 2 is there, but 7 does not fall in these digits, so it doesn't find them. You can do the same with ends with, and here it will be true. If we were to do this, it will be true because it does end with one of these values here. So it's true.
But what if we were to say 27? Would it match it because the word is like that, or would it match it because the last value? It will match on the last value. Take note of that. Find is one of the only matches that will find a specific word index and not a letter. Most of them will always work on the letter. But you also have starts with. In this case, it will be false because it doesn't start with a value. But if I were to say 2i, it will be true because it starts with a value. And then you have match. Now, match only returns true if the entire string matches this regex. Not only if parts of the string match, but the entire string. So against this regex, this string will be false because this entire string isn't built out of that, as you can see. But if we were to remove this and just say 28, let's do one that says 27 as well. Then you can also use match ling. This is the same as what we have here with match, but it returns the length of the string that was matched. If no string was matched, it will return -1. So let's do this, and let's just put some text here. We'll get 2 and then -1. Now that we know how match works, or how regex works, we can go into the more powerful things, such as echo multi-replace. Now multi-replace matches a regex, then it replaces a value for that regex. As an example, let's copy this piece of text, which I am very happy that I saved. There we go. Now here we specify in an array the regexes we want to match. So let's first match this regex here. So first we'll match this regex, and then, and just take note, this needs to be like this, and then we can specify the value that should be replaced here. So let's say number as an example. And just as another example, let's say here regex tomorrow. So find any tomorrow and replace it with today. Now if we were to fix echo and put a comma there, then if we were to run it, we'll get I am number today, and today I am number 7. Now the reason we get number 7 is because 2 matches this regex, and the reason we get today is because tomorrow matches this regex. Now if you only want to replace one of them, we can just do, instead of multi-replace, we just say replace. And if we were to do this here, and remove the array, because this is just another argument. So we look like this. Then it will replace these values with number. So if we were to run this, we'll get I am number tomorrow, and today I am number 7. Now if you want something a bit more powerful, you can use replace if instead. So here we have replace if, and we can say I'm 28 tomorrow, today I'm 27. And we can say am in brackets just for fun, and in here we specify our regex, and let's just make this so we can see what's happening. And then finally here where we say number, we can say $1 but not is $2. Okay, this is the fun way. I'm going to explain this in a second. If we were to run this, the string we'll get will be I am, but not is, 28 tomorrow, today I am, but not is, 227. So basically, it does the same as replace, but it matches the value in the string, and then it saves them inside of these. So the first case in brackets here, that will become $1. So we match am here. Am then goes from am but not is. And in here we match the second value, which is any digit. And we say $2, which is the digit itself. If we wanted to go SSS here, then each digit will instead have a bunch of S's next to it.
And then finally, let's just take a look at split, which is up to this point is now self-explanatory since we have this with almost everything else. And let's just remove this. And let's just remove this and this here. There we go. So now it will split wherever it matches these values and we'll get a sequence. So if we were to run this, we'll get I am space it splits. That's where the number would have been. Then space tomorrow, today I am, space it splits, and then we get a 7. So wherever it matches it, it removes that value and it splits it. Now the OS module stands for the operating system module. It gives you some operating system features, so like working with files, a better way of working with files, and a bunch of things such as that. Now the OS module is one of the best modules in them, so let's jump right in. Import std os. The first thing I find is really cool is to get command line arguments that has been passed into the program, such as, let's echo out command line params. Now let's compile this. So I'm just gonna C here and not R. So I'm gonna compile main, and then I'm going to run that main file that was compiled, and I'm going to pass in a couple of things. Let's say I am cool 22. You run that, you'll notice we get this I am cool 22, so everything except for main was printed out for us in a sequence. You can also loop through the parameters by using a for loop, so for param, and here you can of course use command line params or one dot dot param count. So this will give you the amount of parameters that has been passed in, and then we can just echo param string. And in here we pass in param, and this will get the parameter from here. So as you can see, this is an integer. So we pass in an integer into param string, and it will get the parameter at that index. Now, of course, if we run this, compile and run it, then here we get I am cool. If we were to make this from 0, then we'll also get main, as you can see here. So that's why we made this 1. Now let's take a look at some of the constants in Nim that is provided to us by the OS module, such as echo cur dir. So this here gives us the current directory symbol, so the symbol used for the current directory. If we were to run this, we'd get a dot because that is the symbol for our current directory. If we were to go ls-l or ls-a, you'll notice here we have dot, and then here we have the rest of the files. This dot here is for the current directory, and this dot is for the previous directory. We also have alt-sep, which uses the alt path, the alternative path separator. So let's actually just add a couple of these here, so we don't have to spend too much time on this because there's a lot. There are also dir separator, directory separator, dos like file system, and I'll explain a lot of these later. Alright, so here we go. Now, if we go here, then let's explain this. So the alt separator gives us the alternative path separator, which is a /. In Windows, you might get multiple or a different one, but in our case, we just have a / because I am in Linux. We also have the directory separator, which is the same as the alternative path separator. So on Windows, this would be a \, and on Macs and Linux, this would be a /. Then here it returns true if this is a DOS-like file system, which was like really old Windows. In our case, no, it's not. And in ext, this returns the extension of an executable on the system. On Linux, anything that doesn't have an extension could be considered an executable if it is executable. On Windows, it would be .exe and whatnot. And in exts, this returns nothing on Linux.
So there is not a specific valid executable file extension. However, it will return exe on Windows and cmd and bat and whatnot. But on Linux, it is nothing. On Mac, it might return something like dmg or I don't really know. Then file system case sensitive returns true if your file system is case sensitive. I think on Windows this would be false, but take that with a grain of salt. In our case, what that means is if I were to go ... Now here I was in my nim tutorial. If I were to say cd nim, which means change directory or go into the folder, and I do this, it says there is no such file or directory. But if I do the same but just without the capital case, then it works perfectly fine. That is because our file system is case sensitive. Then we have invalid file name characters. So these are characters that are invalid to be kept inside of a file name. In Linux, it is all of these. This here isn't a backslash quote, this is just a double quote. So I cannot have a file name that starts with a double quote. That isn't allowed. And then you have invalid file names. So basically you'll see a bunch of these on Windows as well, that you're not allowed to call your files. On Linux, I think it's a bit more flexible. You can call your files some of these. Then you have your parent directory. So this is the same as the previous one we had where it was current directory. So it is the same as curdir. Just this is for the parent. So if we go ls-a again. So this is the current directory. This is the parent directory. That's why we got 2 dots here. And then path separator. This is the character that's used to separate the components in your path variable. So $path. Here we go. So you'll notice each one of these are separated by this colon, and then it goes on to the next path variable, and so on and so on. That is how it works. Then we also have this cool new feature where we can append strings together using a slash. So path to file. Now if we were to run this, well, we get path /to/file. I believe this / will change depending on your operating system. So if you're on Windows, you might get a backslash when you print this out instead of a /. That is because OS, this specific function, basically builds this for you. However, if you don't like this specific method, then you could also use join path. And then you just remove these and add a comma. There we go. It will give you the same output, as you can see there. Cool. Now, if you want to check if a specific path is absolute, you can go is absolute, and let's go /home/netsu, which is absolute. An absolute path is a path that is usually inside of, or usually from root. So that's an absolute path. If it starts from your root directory, that means if it starts from here, that's /. In this case, this is absolute, whilst something such as like this /documents, this wouldn't be absolute. So you can see this one is true and this one is false. Basically, if it starts with a /, it is absolute. There's also a couple of ways you can get specific directories. So let me just echo them out. So this gets the home directory. So in my case, it's home netsu. If I were to go $home, we'll also get home netsu. And this is just where you can find like all my documents and whatnot. Then you get the configuration directory. This is where all your config files go. So if I ls.config, here's all of my configuration files, as you can see. On Windows and Mac, these directories might be different. Here's the temporary directory. So basically anything in this directory, once you reboot, everything gets deleted. So everything in here gets deleted on reboot. Here's the current directory. So this is where we're currently at. It's the same as saying PWD, which means present working directory. This is where we currently are. Then you have get app dir. this is the location or the folder of the application executable. So to give you an idea, if we were to go dot dot and then go /nim main, then you'll notice this one here is home netsuite document toots. So that's the current directory. Then the app directory is /nim. That is because the executable is in this folder, whilst we ran the executable from this folder. And then get app file name returns the name and the path to the executable. So this part here is the name of the executable. If I were to go there, here's the main file, that's the executable. All right. Now you can of course change the directory you're currently in. So let's create another directory here. Let's delete all of these, we don't need them. Let's create a folder, test. Now to change the directory, you can just say set current dir test. In this case, we will go to this test folder in our current folder. Now if we were to run this, and let's just go back into Nim so I can execute this. Then we did go into this directory. So if we were to then say, just to test it out, if we were to echo get current directory, then you'll notice we get this. So we are currently in the nim/test. But once the executable stopped executing, we went from the test directory back to our original directory. And that is normal. So if you notice that happening, it's normal. Absolute path, and here you can like pass in a path such as I am cool, and it will return the absolute version of this path. In this case, /home netsuite documents toots nim I am cool. So the absolute, as I said, starts from root. When using this, it figures out where root is for you and works its way up to the current folder it is in, and it appends this. Then here we can also have expand file name, and let's say lols.txt. Now if we were to run this, you'll notice we get an error. The reason is because this file doesn't exist. So if you're just going to run that, it won't work, but you need to go lols.txt, and now when we run this, we'll get the absolute path towards this file. Now you can also extract the file name. So in this case, let's assume this is by default what you get. So let file path is equal to boom. So now we have the file path, but now we want to get the file name only, which is this part here. So just imagine we didn't have this part. Then we can say extract file name and then file path. And this will extract the file name from the path. And there we go, lols.txt. Now let's say you have a very weird path, such as let path is equal to /home /netsu /docs /test. Let's say you have this. Now, usually this isn't really considered a valid path. The reason is there should only be one slash. When you put two slashes here, you might get unexpected results. So 2 or more is basically bad. But if we were to go normalize path, then this will fix that for us. And let's just say path. And this needs to be var. Let's just go like that. So we don't have to worry about this. And then we just echo path here. Now if we were to run this, you'll notice all of those extra forward slashes, they're gone. Now we only have these, which makes it look like a much more normal path. Nice. Now we can also check if a file exists by going file exists. Let's go lols.txt. And then if we were to run this, it will tell us if the file exists by giving us true or false. If I were to say lols2, it will tell us, nope, this file does not exist. So we'll get false. Then you can also check which file is newer by saying file newer. And this just means which file was created last. And here we can say main.nim. We run this. And we get false because main.nim was updated last. So if I were to then go like this, save it, since this was now updated, it will say true. So it checks, is this one newer than this one? So every time we update main.nim, so not just create, but when we update main.nim, it changes which of these files were newer. So each time we update either one of them. You can also get the creation time. So let's say you want to get whenever this file was created. So get creation time. And I believe this also means modify. So let's actually check here. Note under ParseCfg returns may actually be the time at which a file attributes were last modified. Yeah, so you might get the modified date, the last time this file was updated, instead of the last time it was created, or when it was created. And then it gives you the seconds and then the nanoseconds. And in here we can also do split file. Now when we say split file, we can go here and say get current directory. And let's also add to this current directory lols.txt. And this will split it up for us. So we get this, the directory, so the folder where this file can be found in. Then you get the name and then you get the extension. That's going to be very useful when you need to debug maybe a directory and file and see what is going on there. To check if two files are the same, so if they're duplicates of each other, we can say same file. And we check against lols.txt as well as main.nim. It will return true if these two files are the same, but they are not, so we will get false. If you want to check if two files have the same content and not just the same titles and whatnot, you can say same file content. That means even though these two might have different names, if I do this, it will return true, as you can see. Now let's say we have var file, and file is the name of a file, so let's call it secret. Now, what if you wanted to add an extension to this file? Now, one way you can do this is by just appending your extension to the file. However, if you do this, then if that file already had an extension, it will now have two, which is not really great. So we can do file is equal to add file ext. And here we can just pass in the file name and then the extension, so txt if we wanted to. And then we can echo out file. Now when we run this, we'll get the name that it now provided. But if we were to say .txt and we were to run it again, you'll notice we didn't get an extra extension added to this file. And you'll notice if we change it to a different extension, it won't add this new extension. So this way you can always make sure that you don't modify the extension when you shouldn't be. However, it's still completely possible to go here and say echo file.change file extension. And here let's say we want to change it to zip from txt. Now when we run it, then here we get secret.txt and then it changed to secret.zip. So if you want to change one that already has a file extension, this is the way to go. Alright, so let's say here in test.t or just test, we add text.txt. Right? So now this folder has a file in it called text.txt. Now we can say copy dir, and here we can say my dir, or no matter, we can say test, and copy it to test dir. There we go. Now when we do this, it will copy this directory and its contents, as you can see here. Now take note, when you do this, the permissions may change between these two. So let's say this only has read permissions, but not write and execute permissions. Then this here will have the default permissions provided by your operating system and not whatever the permissions this folder has. So if you don't really know how permissions in Linux work and whatnot, you don't have to worry too much about it. But just know that this will change permissions if this one has permissions that are not the default provided by your system. If you want to also copy with the permissions, then you can say copy dir with permissions. Then it will copy it with those permissions. So let's go also dir. And of course, if you want to see what their permissions are, you can go ls-l. In my case, they all should have the same permissions, as you can see. Read, write, execute, whatnot. So now when we do this, it will copy it as well, but then it will copy it with the permissions provided or given to that one. You can also copy files. So let's say copy file. And here we can say lols.txt. And we can copy it to test. And you can also specify exactly what you want to call it. So here we can say lols.txt. You might want to, instead of doing this, you might want to go like that, just to make sure you get the right thing here, because if you're on Windows, this might not work. You might not be allowed to use a /. Anyhow, and here we can say txt. And now if we were to just open up test here, there's no lols.txt, but if we were to do this, it will copy it and make a lols.txt with the same content. Take note, again, permissions will change to the default permissions. If you want to keep the permissions, you can say copy dir with, not copy dir, but copy file with permissions. And now it will do the same thing, but it will copy it with those permissions. To create a directory, you can just say create dir, and here we can say noise dir, so nice directory. And you can also check echo if that directory exists, so dir exists, and we can say noise dir. And yeah, let's check this out. So here it creates noise dir, and yes, it does exist. However, what if it doesn't exist? And if it doesn't exist, you want to create it. In that case, you can say echo exists or create directory. So it will check if it exists. If it doesn't, it will create it. So basically combined those two commands we just covered. So you can say my dir. Now, if we were to run this, it doesn't exist, which it says false, so it doesn't exist. It returns that it did not exist and that we just created it, as you can see there. However, if we were to do this, it will return true because it already exists, so we didn't need to create it. We can simply, to remove a directory, go remove dir. And note, this will delete a folder and everything inside of it. So be careful with this, but we can go my dir, which if we take a look here, has nothing in it. And there's also dir, which we can delete. Also dir, just to show you, it will also delete whatever inside of it. There we go, both of them are deleted, as simple as that. You can also delete a file. So here we can say remove a file instead, and we can specify test/lols.txt. Now if we were to run this, it removed that file. Then you also have try remove file. Now this one is special because it tries to remove a file. It will return false if it failed, but it will return true if it's a success or if the file does not exist. So here, if I try and do that, it's just going to return true because the file doesn't exist. And why am I getting up? Because I need to echo it. There we go. Now, if I were to run this, you'll notice we get true. because it never even existed. But let's say we tried to delete text.txt. So it will also try to remove. So if we say text.txt, it will be able to remove it if needed. There we go. All right. Now let's learn a little bit about file permissions. For example, let's say we go here and say echo get file permissions. And we say for lols.txt. If we were to run this, we get all of these. Now let me explain this. So fp is just like file permissions. And then you have user, you have group, and then you have other. So if I go ls-l and let's say lols.txt, here's what it represents when we take a look at it in the Linux file system. So you'll notice we have user write, user read, so there, read and write, group read, which is this part here, so it has read, and then others read. So this basically says who is allowed to touch and read and modify this file, whatnot. Cool. I'm going to save this into perms. And here let's say excl file permissions. Now you'll notice here it actually gives a little IntelliSense, says it's convenience for set file permissions. Do that and we get the permissions and then we subtract the permissions. So this will remove permissions. And we can specify which ones we want to remove. So here we could say fp group read. Then we can just echo out this right here. And we also need to specify exactly which file. So let's go here and say lols. Actually, let's also go var file. There we go. Then I don't have to type that out the whole time. So say file and boom. Now if we were to run that, then now we don't have group read permissions anymore. If I go like this, you'll notice there's no more read permissions here. So we removed this permission. Then you also have set file permissions. We specify a file, and here we can specify what permissions, such as fp user exec, fp group read, and fp user read, like this. Now take note, this will erase all other file permissions. So when we run this, all other file permissions will be erased, but now we will have these permissions added. So take note, it will erase the existing permissions if you have any. Now let's go here and echo out get file info, and we can just pass in file here. And this will return a ton of the file's info. So let's run this. And here we go. So we get the ID. There's like the file ID, I'm assuming. The kind is a file. The size is 60. I'm assuming that's kilobytes. Here's the permissions we have. The linked count, last accessed, last time it was written to, and when it was created. We can also get file size. And this will get the file size for us. So we go ls-lh and we say lols.txt. You'll notice it is 60. So as I'm thinking 60 kilobytes.
So let's say you want to set an environment variable. Now for those of you who don't know, an environment variable is something such as $home. This is an environment variable. It points to this directory. I think a person can echo it out. Yeah, as you can see, it points to this directory. That is an environment variable. You have a bunch of these such as path. This is also an environment variable. Well, it's a big one, so I'm not going to print it out, but you get the idea. So it's basically a variable, just like a nim, but you can use it inside of your shell. so inside of your terminal. Now you can set your own environment variables in Nim, such as put env, and then you give the environment variable name, such as node env. This will usually be like your Node.js environment variable. And then whatever value you want to put in it, such as test. Then to get the env, you can go echo get env and node env. And this will get the env and print it out for us. So if we compile this, we'll actually get test because that's what we saved in node env. However, note that when we echo out $node underscore env, we don't actually receive a value. This is because once the Nim program shuts down, this node env variable is also removed. Because when you run a new Nim program, it basically works in its own shell. You can also delete in env. So here we can actually remove this, and we can say del env, and this will delete the environment variable. And then we can also check if it exists by going exists env. Now this will of course be true if this environment variable exists, but it won't because we deleted there. So if we run this, we get test and then false. But if we never delete that environment variable, we'll get test and then true, because then the environment variable does exist. You can also execute shell commands. So the type of commands I would put in here. It is generally frowned upon to do so, however, so take note of that, because usually when you write a program, people don't really like it when you directly interact with their shell. So if I go exec shell command, and we say dir as an example. If you run this, there you go. So basically, if I were to say dir here, we'll get the same output. Now again, this isn't really something that people like because it can have destructive properties, such as sudo rm-rf/. Don't execute this because this will delete your entire system. But this command here, very dangerous, so people don't like it when you directly execute shell commands. Instead, it's better to install a library that will run shell commands for you, because then you don't have to directly interact with the shell, and that also keeps other people happy. But as an example, let's say rm lols.txt. If you're on Windows, rm might not work. I don't remember, I think it's del on Windows, but I don't remember how to do that on Windows, since this is system specific. So if you're on Linux or Mac, your commands you put in here might be a little bit different than on Windows. That's why I use dir as an example, because dir works both on Windows and Linux. Anyhow, so when I run that, and here it actually asks me if I want to do it because it is currently write protected because of our last tutorial where we changed up a bunch of things. I'm just going to press enter, and now do we still have it? No, because I didn't say yes. But what they could have done is they could have said sudo and say this application needs super user privileges and you need to enter a password. This is a very easy way to make a very dangerous program. So generally don't use this unless you really have to and you have no choice. But in Nim there's always a workaround, so it's always best to avoid it. You also have echo get current process ID. So this will get the current process ID of our application. So if we were to run this, we'll get 124688, and it will change every time we run it because we will have a different process ID given to us when we run the program. You also have is valid file name, and this will check if a file name is valid, such as my file and my file. So this one will be false and this one will be true for obvious reasons. So we go here, it will say false if I say touch my file like this. We will get the file here, but you'll also notice it's in quotes because luckily Linux is smart enough to kind of fix this for you when you do it in here. But this here is generally frowned upon. That should not be in a file name. A useful function you can have is sleep.
such as sleep 1000. This means sleep the program or wait the program for 1 second. So if I say echo start, and then I say echo end, and I run this, we get start and end. But you'll notice there's a little wait every time. So let's actually make it a little bit longer so the wait is easier to see. So run that, we get start. Now we have to wait 10 seconds. Once 10 seconds is over, end will execute. So sleep is an easy and quick way to just say stop and wait. There we go. We can also get all of the environment variables. So echo, so for env and its value in env pairs. So this will get all of the environment variables in pairs of the env itself and its value. And we can just echo env colon and then its value. And this will of course get all of the environment variables and their values. Now there's of course a ton here. But in our case, as you can see, there is environment variable there, there's one there, there's one there. So you basically get each and every one and you can work with them as you need it. I have a ton of environment variables, but as you can see, it's pretty easy to get them if you ever need to work with them. Here we have a for path in, and in here we can actually put a path that we want, dot parent ders. And just echo path. Now the idea here is that it will print out every path until it gets to the root directory. So if I go, and let's go pwd, I copy that, paste that there, run that, then here you see it prints out every parent directory until it finally gets to the root directory of your system. So if I go ls/, this is my most root directory, so all of my system files and stuff goes here. So it basically makes its way back to the root directory from wherever you put in here. You can also do it the opposite way by just going from root and making that true. So if we were to then run this, it will do it from the other way around, so it will start at root and make its way up to this directory here. For item in walk dir, and let's actually just use this. So what's going to happen is we're going to walk this directory, meaning we're going to get all the items in this directory. Let's echo out item and see what we get. So if we run this, we get the kind, such as PC file. It can also be PC dir, PC link to file, which is just a link, a symbolic link to a file, and PC link to dir, which is a path that refers to a symbolic link to a directory. But for the most part, you just have to concern yourself with PC file and PC dir, where PC dir is a directory or a folder, and PC file is a file. So if we were to go like this, you'll notice we have PC file, and here's the path to lols.txt. This is a directory, it's nim/test, also a directory, tester, file, main.nim, and so on. So it allows you to get all of the files in the directory that you put in here, and then also get what type of file it is. So is it a link, is it a directory, is it a file, and so on. If you want to do it recursively, meaning you want to get the files inside of the folders as well, then you can also do rec, which basically means walk the directory but also recursively. So in this case, if you go like this, we wouldn't get the file type anymore, but we do get all of the files inside. So here is tester, and in this case we just said tester. We didn't get the txt file inside of tester. So this will allow you to recursively walk through each and every directory. However, it does not return the type of file. Another thing we can do is let's go. So here's my nim directory.
It has a folder and thumbnails file, and there's all the tutorials inside of it. Now let's say I want to walk this directory. So let's copy this. We paste it in here. And in here, instead of saying walk dir, we say walk files. And now what we can do is we can say /star.mp4. This means walk through all of the files, but only get the MP4 files. So if I were to run this, we'll get all of the MP4 files. But if I were to just grep-i xcf, you'll notice we didn't have any XCF file here. But I could go XCF here, and now we'll only get the XCF files, which is my thumbnail files. If I run that, you'll see there's an XCF, and that doesn't get the video files because they end in .mp4. So you can use a little bit of regex to get specific files that you want. However, this doesn't support full regex. What you should instead use is walk pattern. And this supports you entering a pattern. So here I could say star.xcf. If we run that, that would still work. But I could also go here /a star, or there wouldn't be actually, let's go 1 star. Run that, and we get all of them that starts with a 1, and so on. So this allows you to really put a pattern in here to search for files in a directory or to walk it. Nim provides a lot of ways in which you can communicate with the terminal in it. So this is the terminal for those of you who don't know. In VS Code, you can go terminal, new terminal. Again, here's the terminal. So it allows you to interact with it and make it look good or change a couple things of it without needing to install a third-party library to get it to do things. Like in Python, you need to install colors or something like that to really get things out of the terminal that you want it to do. So let's import std/terminal. This will import the terminal library for us. And let's say std out. So we can't just say echo in this case. We need to say standard output. So the std out is for standard output dot style right line fg red. So this is a foreground color red. And we can put a little bit of text here. So this is red text. Now if we were to run this, and it should be styled right line, it's not style right line. This is red text, and I can see the text itself is red. We can of course make cooler things, so here we can also go bg blue, and this will make the background color blue. So if we run this, we'll get red text in a blue background. Maybe not the best for the blue terminal, but it's good. You can also specify specific styles that you'd have, such as style bright. This will be bold text. You have style blink. This will be blinking text. And then style underscore, and this will be underscore text. So if we run that, so you can see this is pretty cool. The text is blinking. I actually like that a lot. But in here you have red text or bold, and here you have underlined text. But note, this only really affects this one line of text. So if I go echo test, you'll notice test does not really get affected by it. It's just normal. So this will only affect one line of text. If you want to affect everything, then instead of saying styled right line, you could go set, and then what you want to set. So background color. And now I can set it to, and let's go here, BG red and true. And why's my caps lock on? True. And this will say, okay, make the background color red. In our case, true would mean should it be bright or dark. So we can actually have a couple more here. Let's copy this. Let's go false, and then we can actually see
how it differs. So here you'll see there's a light red and here's a dark red, and all of the echoes are being affected by it. You can also change the foreground if you want. So let's go set foreground color. And it should of course be FG and not BG. If we run that, in this case, our background color is still being applied, but now I can also set the foreground color. Let's maybe instead of going red, we go FG blue, or yeah, blue would work. If we run that, then there we go. You can also set a specific style that should persist for the rest of the program, such as std_out.set style reverse, and this means basically it should reverse the style, so a blue background and a red foreground now. So this here would be reversed. So if we go and let's just maybe add a test here, boom, and I forgot to close that, there we go. If we run this, then as you can see it has been reversed, so now it has a blue background with red text instead. And to of course reset all of this so it doesn't do that anymore, you can just say reset attributes, which is a very easy way to just bring everything back to normal, to how it should be. So there you go, this is just normal text. Now of course I have a lot of styles and I recommend looking at the documentation, but you have a black, red, green, yellow, blue, magenta, cyan, white, and just default. And of course you can just add BG and then the colors as BG default, BG white, or FG red. You can just add those there. For text styles, I'm not going to go through all of them, but I will mention a couple of them. You have style bright, style dim, style underscore, style blink, style reverse, style hidden, and style strike through, and style italic. Note that style italic will appear reversed if the terminal does not support it. So if I go style italic, and we go like this, my terminal does support italic text, so it will just look normal, but it will be reversed and not italic if your terminal does not support it. So just keep that as note. Alright. You can also go std_out.write. So this is just like echo hello world. Just as a little recap from the start. And there we go. std_out.erase line. And this will erase the current line, so the above line won't be displayed in your terminal. This is pretty cool because that means you can add text and then later remove that text. So if I were to go here and run it, you'll notice it's no longer there because the line was erased. That's a very cool feature that you can do using std_out and the terminal package. Let's say we echo out something cool and echo out text. Then here we can say std.cursor up, and this will move the cursor up, and we can say 2 to specify 2 lines. And now if we were to echo out I am new, and we were to run this, and it should be std_out, not just std. And now if I run this, we get I am new gcool. So without this, it will look something like this. Something cool and text. But when I do this, it will move the cursor up, and it will add that there. We can of course make the cursor go down, and let's say with 1. And you can move the cursor just how we like. So now we could go cursor forward with 2. You can also move the cursor backwards if you want to. And let's go right std_out hello world. Now I wanted to do this a little bit because sometimes we forget you don't have to do this. You could also do it like this. We sometimes forget about these cool Nim features, so I need to bring it back every once in a while just so we can get a little bit of a refresher. So in this case, you can still do this. This is still valid Nim code, it means the same thing. Now if we were to run this, we get I am new G cool, text, and then hello world. The reason we get text now is because we moved the cursor back down. Because when we moved the cursor up, it didn't render because the cursor wasn't there anymore. It only renders where the cursor is. So in this case, it also moved a little bit forward because that's where we moved it to, and we also moved the cursor down. Now you could also go stdout.erase screen. And this will erase, but not clear everything in the terminal and return the cursor home. So if I run this, as you can see, it clears it, but it doesn't quite erase it. I'm going to remove that because that's pretty much annoying to work with, unless you have a specific reason for it. You can also go var s is equal to get ch, and this will halt the process until a character has been entered with the such as getting the user input. And you can of course echo out s. So now we run this, and that's waiting for a character input, so I can go L, and there it actually echoed L, but it didn't look like it, but it did actually echo L. I could also go, and this would also work, so if I go boom, they'll see it also adds that. You also have hide cursor, and this will hide the cursor, so if I were to run that, you'll notice my cursor is now missing. But this actually lasts after the session, so it's always a good idea to later on just say show cursor, just so the person's cursor can be shown again. And there we go, my cursor is back. You can also stdout.set cursor position, and then you can specify the X position, so let's say 10, and then the Y position, which is 5, and then let's say echo I am here. Now if we were to run this, you'll see it positioned it 10 downwards, so I think it's about 10 characters and 5 left, or 10 left because X is from left to right, and then 5 downwards because Y is from up to down. So let's say you're trying to get the user password. You can go std or var a, and we can just say read password from standard input, and we can tell them enter your password, echo a, so you can get the password back. So now here it's telling me to enter my password, and I can type whatever I want. So I enter my password. When I press enter, there you go. Now don't hack me, please, now that you know my password. Let's say you need to get the terminal height, in which case you can just echo out. I'm just going to add a backslash in there. And let's get the terminal height. And this will get the height of the terminal in rows. And you can also get the width in columns. And if you want to get both, you can just say terminal size. So we're to run this, and these are of course functions, so I need to call them. So now if I run it, we'll get 33, 45 for the width and the height. And if I were to do this, the width will change. So if I run that, it's now 72 and 33. Now, sometimes you have a variable, but you cannot be guaranteed that that variable will contain a value once set. For example, let's say you have an asynchronous function. So this is a function that will return a value in the future, but not right now. So let's say you make a request to YouTube. It may take some time for YouTube to respond.
But you don't want your program to just stop running. So in a synchronous function, you request data from YouTube, and then you wait for the data later in the program rather than now. But when you do that, your variable that you store the data in might not have any data in it. Or if YouTube responds with no data, it might not have any data afterwards. In a scenario such as that, you would want to be able to store either nothing or a specific value in a variable. And that's where the options modules come in play. So let's say import std/options. And let's start off simple. So let's go procedure, get letter position. We have a word which is of type string, and we have a letter which is of type char. And then it is option, and it returns an int. So what we are saying here is that this function will return either an integer or nothing. That is what we are saying. So if index character in word, or not if, that should be for index character in word, if character is equal to index or letter, return some index. So when we do this, we are saying we are returning an integer. In this case, we have to use some because we're using an option. But you actually can just ignore a sum out of your brain. It should still be here, but you can think of it like this. Sum is just what we need to use to make it compatible with the options module. So we need to wrap it with a sum. It basically just says, hey, we do have an integer, return that to option. And in here, let's say nothing gets returned, so then just return none, and we pass in the data type that should be returned. In this case, it will either return an integer or it will return nothing, but it will say we wanted to return an integer type. So let's say we go let a is equal to get letter pos. My name is Steve. We want to find e, single quotes, because this is a char. As you can see, char, not string. And let's echo out a. Let's see what we get. We get sum 6. So we get this value here with the index that it was returned in. If we were to ask for a letter that does not exist, we'll get none, and then the data type we wanted to get in return. Now we can easily check if something was returned in this value here by going if is sum a. So we're checking if a sum was returned, which means a value was returned. If it was, we can then echo get a. This means remove this sum here and just give us the normal value. So if we do this, we'll just get the normal 6 without this sum. So this will return us the value hidden inside of this option. Let's create another variable and call it b. And here we put an x to basically say there's nothing here. And as we know, that will give us a none of int. Then here we can say if is sum b, then echo exists get b. And what if there is nothing? We can say elif is none b. So it will check if it returned a none instead. And we can just echo nothing found. So this allows us to see if there is a value, and this allows us to see if there is no value. Of course, when we run this, we'll get nothing found. Now let's say you wanted to convert this to a string, which is pretty simple. It is echo $, and let's say B. You could of course compare this against none int as a string, because you converted it to a string. We run this. This is actually a string now. It's no longer a none type. And here is true because this string is the same as this string. Now you might be wondering, if you have, let's say, let C is equal to sum, and let's do 6. And you echo out C, then you'll notice you do get 2 sums and then 6. Now this will happen where you have 2 options that contains 1 value. In a case such as this, you can just do flatten and then pass in C. That will remove 1 sum from this nested sum here. So if we run that, you'll notice now we only have 1 sum, and that contains our value. If you try to flatten this again, you'll actually get an error because there are only 2 sums. And because nim is typed, it will know that you cannot do this. So it will actually tell you, hey, this isn't going to work because there is no more sums to flatten. If we were to add another sum here, nim would have no problem with this because now there are 2 sums that we can remove. We cannot use flatten to get the value, but we can use flatten to reduce the amount of sums we need to do if we wanted to get something. So we don't have to go get like this, because this is too much nesting. It's very confusing. So we'd rather use flatten, so we only need to use 1 get. And that's the basics of options. The idea behind options is a variable may contain a value or may not contain a value. In a scenario where you have one of those 2 options, you can use option to say it might contain this value or not. So here is an example. Now the idea is I built a little Telegram bot just to see how you can do it in Nim. Don't mind all the little squiggly bits. That is just because I don't have the Telegram module installed. But you'll notice here we also use isSum. Here we also use get. That is because message here is of type sum. Because we may receive a message or we may not. Because of that, we will need to check if it exists. So you will sometimes, even within libraries, see things like this happening, where you need to use the options module to get some values from a message or from a value that gets returned to you. So whilst this example I showed you was very, very small, it actually scales up pretty big once you get to places like this, where you may or may not get values back. Now, oftentimes you will find yourself needing to parse some sort of data. And very often that sort of data would be in the form of JSON, whether you're working from MongoDB or any sort of maybe pinging an API. So let's get to it. Let's import std JSON, and let's also import options. Now the reason I'm importing it like this is so we don't have to split this into 2 lines. So we could do this. This is perfectly fine as well. But if we want them on the same line, we could do this. Or optionally, you can exclude that it comes from the std library and import 2 modules like this. Anyhow, so let's create an age, make that equal to 19. Then let's create another variable called converted JSON. Now to form JSON inside of Nim, we need to use special syntax. So it first starts with a percentage symbol, followed by an asterisk, and then our array with our JSON data. Now, for those of you who don't know JSON, JSON data is simply like this, where we have, let's say, a field and then a value, a field, then a value, field, then a value. This is JSON. So we're going to be replicating the same idea here. So here we can then do this. And let's say name Steve. And here we can actually pass in an already defined variable into this. So you don't need to specify an existing or a new value every time you want to insert a value for a key. Now sometimes you end up in a scenario where you have a field but the value itself cannot exist. Usually in JSON we can use something such as null or undefined. Actually just null, it seems. So where we can use null, which means there's nothing here. In Nim's case, we don't necessarily have null to use, but we can use nil for the same purpose because it is the same thing. It means nothing. And here we go. We have some basic JSON data. Now if you want to display this, you can just say echo converted JSON. And here we go. Now it's not really formatted, so it looks very difficult to read, but it's the same thing. Name Steve, age 19, and it goes on until it starts right here with this second part. And then we have name Jack, age 24. So as simple as that, we have created some JSON. You'll notice if you hover over this, you also get a type of JSON node. We can also go let string JSON, and that can be a string version of this JSON, because this dollar symbol, like with most things in Nim, converts something to a string. In this case, it converts this object into a string. We can parse a string into JSON by going, let's go let parsed, and we can make that equal to parse JSON, and we can say string JSON. And then we can echo out parsed, and we'll get the same value. So this converted this string, which if you hover over this, you'll notice it's a string, back into JSON for us. Cool. Now I can also get the first object inside of this JSON by specifying the index you want. So if I do this, I'll get the first one and only the first one. It will no longer be in this array here. It will just be this first one here, the first object. Where name Steve, age 19, hobbies, eating and coding. So to make it easier, we'll save this into obj. And then we can echo out obj. And in here we can specify the field we want to get inside of this object. So name, age, hobbies, username, or type. So in this case, let's just say name, and then we have to say .get string. This will get the string from this value here. So if we run this, we'll get Steve. So we said in this first one right here, because this here we select the first object by saying index 0, get this value from this name field, which is Steve, and get that as a string. Without that get string, it will give us this. And we would say let x is equal to obj. You'll notice this x here is of type JSON node and not of type string. That is why we say get string, and that's why when we print it out we get quotes. Where here where we said get string, we did not receive quotes. So you'll just need to remember that when you try and get a value. Same with if you want to get a number value, you will have to say get int. And that will give you an integer. But if you don't specify this, it will return a JSON node type, not an integer. They may look the same when printed out, but they are not the same type. So they will work differently. You can't add something to a JSON node as simply as you would add something to an integer. Let's say we try and get the username dot get string. Now we'll know this username here is a null, meaning we don't have a value in here. So when we try and run this, we'll just get nothing. However, we can give it a default value. So if we have a null or a nil value in this case here, then we can just say, give it a default value of, let's say, Luke. Then when it gets it and it sees it is null, it will give us this default value here. So if I were to put name there, we'll just get Steve. But if Steve was nil, we'll get Luke. So if I were to make this nil now, then we'll get Luke instead. Now if you want to access arrays, they're pretty simple. So in this case, let's say we want to access hobbies. Hobbies, so now we have the array, and now we specify the index. So let's say index 1, meaning coding, because 0, 1, and then get string. So there we go, we get coding from this hobbies array right here. Now note, this can all be added here, like this, but I find this to look very complex, and I didn't really like it when it's too complex, so I like to do this, just so you know. Now you can also add to this JSON here by saying obj dot add, and you can do this with any object or any node type. Old, and then percentage, and then what you want to save there. The percentage is to convert that to a JSON value. So if we echo out obj, then here we get old false. And here we could say no in a string, and if we run that, we'll get no. So as simple as that to add to any JSON object. In this case, to keep it simple, I just selected this object here, which is also considered a JSON node. You can also check if one of these keys here exists inside of this object. So here we can say object.contains, and let's ask if it contains name. And we get true, because it does contain name. If I were to say name2, there is no name2 here in this object, we'll get false. So it checks for the keys, not the values, but the keys. Now you can also copy some JSON by going let a is equal to obj. However, take note that this is a shallow copy, meaning if we change something in this variable here, because it is a shallow copy, it will modify the original variable here. So if I go and say a.delete, which means delete a key and its value, and I say name, then echo out a, and just to separate them, and then echo out object, you will notice both a and the object have removed the name, key, and value from the object. If you want to do a deep copy, you should go .copy. What this does is it creates a new variable. It does not reference the old variable, but it creates a new one and sets it in A. Meaning if we change something in A, object here will not be modified. So now if we were to run this, you'll notice only A lost the name, key, and value pair. So always remember this when you want to copy in JSON object, that you will need to use deep copy if you don't want to modify the original variable. And you can also do a couple of other cool things, such as escape JSON, and let's just put a string object in there. Now if we were to run this, you'll notice that it escapes everything here, meaning that if you were to pass this in somewhere, it will see this as a string, and it won't try to break out of it at some point or whatnot. So this will make it string safe. If you don't want these quotes before and after, you can also do
escape JSON unquoted, and this will do the same, but it will just remove the quotes before and after this string here. Perfect. Now let's say we want to specify the object type here. Because currently when we get this JSON, we don't actually know what's inside of it. We don't know what key and value pairs they have. It's not typed. So let's try and type it. So let's go type, and let's make it a person, which is an object. The name is a string. The age is an int. Then we can also specify hobbies, which would be in sequence of string, username. And because username can either be a string or just nil, we can use the options module that we imported right here. We can use that to say option string, meaning it can either be a string or it's not a string. And in the type, which is a string. And we'll just add backticks here because we already have type here. Because sometimes you will end up with an issue where sometimes people will put a API up, and when you pull data from the API, some of the keys will be actual keys that your program uses. So you will need to use these backticks to escape them and make sure that it doesn't conflict with the keys in your language. So let's say let Jack is equal to converted JSON at index 1. So this right here. And we say .to, and we specify the object it should be converted to. So now if we hover over this, we don't get a JSON node. We get a person object. So just like that, you basically typed your JSON object. So here we can then go echo jack.hobbies and jack.type. If we run this, we get hunting lizard. So just like that, you can convert a JSON node into something you might feel easier understanding, into a normal object in Nim. Finally, we can also parse a file that contains JSON. So let's say let f is equal to parse file, and we just pass it, and here I have a file called users.json, which just has this users.json, and we can specify / to specify this folder, so in the same directory. We can echo out f just to see what we get, and here we go. So here we get the JSON object. If we hover over if, we see it is a JSON node type. And then if you want to make sure that printing it out is easier to read, what you can also do is then go echo f.pretty, and then the indentation you want. By default, it would be 2, so it would look like this. And we just stop that first echo. So by default, it would look like this. But you could make the indentation a little bit more, meaning these spaces here, and we get this. So instead of 2 spaces, now it will be 4 spaces. And this might make it easier to read when you try and display it in the terminal. Now I've built a custom API just for this. So ytapi.stevesteacher.com. Now when you visit this, you'll actually just get this. You will need to add /quotes. Alright. And this is just a basic endpoint. We're not going to go too deep into like APIs and stuff because that's not what this current tutorial is focused on. But anyways, you'll notice we have this right here. We can actually paste this into Firefox. Firefox gives us
Firefox gives us a nice look at this JSON in a more readable form. So you'll have an ID, you'll have a quote, you'll have an author, and this author is another object, and a user with another, that's another object, and so on. Very similar to this JSON right here. So what we're going to do is we're going to query this endpoint, and we're going to get data from it. So first, let's remove all this and just say import std slash, and we can say async dispatch http client JSON and options. Now we already know what most of these does. JSON allows us to read and parse JSON. Options allows us to say if something is an optional value, meaning it may not exist. HTTP client allows us to request data from some sort of website server or whatnot. And async dispatch allows us to create asynchronous code. And we'll get into what that is in a minute. So our first order of business is we need to define in Nim how these objects look. I'll actually keep it open in Firefox so it's easier to see. So first we'll have an ID and quote, both of them, which are strings. So let's go here and say type quote object, which is an object. And let's leave the ID for now because that's a special one we'll need to do, and I'll explain later. So let's say quote, so we look here, quote, and that's a string. Then, let me just size this up a bit. You'll notice we now have two objects we need to enter. One is called author, which has these values in it. So let's create the author object. So quote author object. That is an object. And we can say name, which is a string. Language, which is a string. Age of death. And age of death will not be guaranteed to be here because not all of these people have died yet. For example, age of death here is 55, 56, 68, and here is no age of death because this author has yet to perish. So age of death may not actually return anything. So in that case, we can say option int because it may return nothing. And then we can say date of birth, which in this case is a string. But in JavaScript terms, it's actually a date object. However, we do not have a date object in Nim that can be simply compatible with this, at least as far as I know. So now we have the author. So here we can just specify author, quote author object. And then finally, we can just create our quote user object, which is an object, and which is an object. There we go. We have our username. Now notice username does not always actually return anything. So here I have Carlos277. We have null. So it still exists, but this time we get null. So in that case, if it's null, again, we can just use option string. In Nim, it doesn't really differentiate between an undefined null or just empty value. All of them will just kind of fall into option. Then we have verified, which is a boolean, and we have type, which is a string. But you'll notice type here is in blue because a type is a keyword in Nim. Now you cannot do this with a keyword. So to avoid this, we can use these quotes, these backticks to say type, because type again is a keyword in Nim, so we cannot use that as a key for this object. Then we have a user, and that will be a quote user object. And Bob's your uncle, here we have our object. However, we still need one more value, one more key, and that is this underscore ID. Now, some APIs won't use an underscore, some will, but it depends. But I chose to use one of the more difficult scenarios just to show you. But there are other alternatives to this in them. If you do not want to use the JSON parse method, so this right here, there are other alternatives to create JSON type objects that does not require what we're about to do. And you can just go look for a couple of libraries, and I'm sure you'll find quite a few. So we cannot go underscore ID string. Why? Because, let's take a look, invalid token underscore. Because it cannot start with an underscore. If I go X underscore, it's perfectly fine, but it cannot start with it. Now your first idea might be to do this, but that just expands the error. Now it's colon equal symbol expected but got underscore. Expected backtick but got underscore. That is strange. So the way you get around this is by putting double quotes like this. But I have an auto formatter, so I'm just gonna save without formatting here. So now it will work. So you'll have to use quotes here because it starts with an underscore. So this is something you'll have to take note of if you're working with a field that has an underscore and then the ID. Alright. Now we can actually get to the asynchronous code. So let's create a procedure main. And this will have an async added to it, meaning this is an asynchronous function. Now, what exactly is asynchronous? Well, let's say we have a piece of code and we have to wait for it to get data from a specific input, from a website, because first it needs to load the website and then retrieve the data from it. We can use async to tell the program, hey, wait here until all the data has been fetched. So I'll get into actually showing you how this works. So just put a echo. So just put a var quote which is a sequence of quote object. And that can be equal to await. And I'm going to create this function later, fetch quotes, and then echo quote at index 0. Now, whenever you create an asynchronous function, it is also highly recommended to just wrap it in a try and except block. Now, why is it important to do this? Because here we're going to actually fetch information from some sort of server or API or whatnot. When that data doesn't get fetched, so let's say your internet gets disconnected or that server is not online at the moment or something of that nature, when something goes wrong, your entire program will stop. So you'll need to use a try and except to make sure that your program still continues to run if the await fails. So basically what will happen is, let's say we say echo 1 here, and then here we say echo 2. Now what's going to happen is it's going to use echo 1, then while it's fetching this data, it may take like a second or two, it's not going to do anything. This is going to, once it has the data, it's going to print out echo 2. However, if we were to remove this await here, then it will go echo 1, it will start the request here, print echo 2, and this may or may not work. So we can use await to wait for it. So it will actually wait for this to execute. It will wait for it to return data to it. That is what async and await does. That's asynchronous code. When you use async and await, you're just telling the program, hey, please wait for this function to finish executing first. But take note, async and await only really works with other asynchronous functions. Most functions are synchronous, not asynchronous but synchronous, meaning they execute in the order you place them. It's only when you have an asynchronous function that you want to use async and await. When you do want to wait for a function, but they're not asynchronous, you could do wait for and then just put the function here. Because we cannot use async and await at the top level of our program, we need to use wait for instead. Because this is still an asynchronous function main here, but we cannot await it. We cannot say await here. Because await cannot work. So if we actually take a look here, can only await inside of a procedure marked as async. Use wait for when calling a synchronous procedure in a non-async scope instead. Basically meaning we just need to say wait for because this is asynchronous and we cannot use async at the top level. Only once in a function or a procedure or whatnot. Cool. Let's actually create the fetch quotes procedure. So procedure fetch quotes. And now we actually need to specify what data does fetch quote return. How do we specify it returns in a synchronous type data? Meaning it's not going to return data now, but if we wait for it, it's going to return data later. Well, for that we can use future. Meaning the data we'll be receiving will be provided to us in the future. So we won't have it right now. But if we wait for it later, meaning if we use async on it, or await on it, we will receive that data. But if we don't, we might receive it much later than we expect. And if we can paste or put whatever data we're going to receive once we have waited for it. So sequence of quote object. And in here we can just say this will be in asynchronous function or procedure. And here we can actually say what we want to do. So we're going to say var client is equal to new async HTTP client. This means we're going to create a new asynchronous client, meaning it's going to try and get data in an asynchronous way. You could do this without using async and await, but that is up to you. Now here is where we actually request the data from that endpoint. So variable response is equal to await client.get, but remember you do have different ones. You do have async and then you have one without async. We are specifically looking at async, so we can also use await here. Anyways, we use await.get to get a get request, meaning get data from this API. And then we paste in our API endpoint. For now, I'm going to make this HTTP instead of HTTPS, and I'll explain why later. So here we're getting data from this API. Note this link will be in the description below, so you should be able to just copy and paste it. Also, the source code to that API is also open source, so you won't have to worry about what's it actually doing. You can actually go look at the code and see, oh wow, this API is very basic. It doesn't even do much. So yeah, you can actually go look at the code yourself if you want to. This will also be linked in the description below. I'll need to specify that because for the last month, I've been getting non-stop hits from YouTube saying, hey, you can't put these links in your description. But why not? I verified that they're okay. But no matter, it's fine. These links, YouTube, are owned by me, the creator, just saying. And they are all open source as well, meaning they cannot be malicious. You can go look at the code. I'm pretty sure it's pretty good. How do I know that? Because I made them. So please, YouTube, do not remove these links from the description. Alright, now here, I think for now I'm just going to await fetch quotes up here and comment this out. Now to get this data, we can just say var body, and we can make it equal to response.body. However, note, body here is actually a feature, so we're getting data again from the body. Now the body is just the part of the request we care about. You also have things like the headers, but these things are a little bit complex for our scenario. Unless you're becoming some sort of web developer, you don't need to know too much about this. You just primarily care about the body at this point. And let's say await. So we're waiting to get the data from this body that was stored in response. And then let's actually echo out body. And let's see what we get. And for now, I'm just going to say sequence void. There we go. Now if you run this, we get this. This is exactly the data that we requested. However, take note this body is in a string form. So this here, that's not JSON, that's just a regular piece of string. So what we can do is we can actually convert this JSON or this string into JSON by saying return parse JSON, which uses the JSON library we imported. We specify the body, and we say .to sequence quote object. So we're going to parse it and we're going to get JSON, but then we're going to say this JSON is actually of this type. So it's actually this right here. If we don't use to, we don't know how the data will look. Now, if I were to do this, and my bad, this here should use curly brackets. There we go. Now, if we were to run this, we get 1, we get 2, but after a wait, and then here in our sequence, or here we get an object that we requested, a quote object with the ID, the quote, the author, and we can even specify that we want a specific field. And there we go. Now we specified a specific field. And take note, if we were to remove this await here, we'll actually get an error because this here is actually of type future. But this means you can actually do this. You can start the request right here, and you can first run a bunch of other code that you want to run, such as these echoes, so there's not a wait between these echoes, and only once you really need the data, you can await it. Because then you can actually fetch the data, or you can finish fetching the data. So here it will actually start the request, but it will continue with the program. Perfect. Now look closely at how fast this now runs. We're going to get 1, 2 quickly, and then it's going to be a short wait. Then we're going to get 3 and the data we want. So make sure to take a look at it. 1, 2, and it took a while, and then we got 3 and false. So this is the nice part about await. You can await wherever you need, but you can start the function early. So we'll start running this function, but it will only actually wait for the whole function to complete once we use await. Alright, now let's backtrack a little bit. Let's go back up here to client.get, because I said we're not going to use HTTP yet. And why did I say that? That is to show you that you can actually use both HTTP and HTTPS, but they actually come a little bit in different packages. Because if I try and run this right now, we'll actually get an error because HTTPS requires SSL in Nim. To enable SSL in Nim, it's as simple as going -d:/SSL, when you compile the program. This will allow you to make requests to HTTPS endpoints. And there we go. It worked like a charm. And that is basically both the async and await and a little bit of the HTTP client. So let's just import URI. And this allows us to work with URIs, or in similar terms, URL. There is a small difference between the two, but it's not too important to really get into it. So let's jump right in. Let's go let URL is equal to parse URI. And here we can actually put a link. For example, HTTPS and then www.youtube.com. And now this allows us to work with this URL in a way that is easy for us to just visualize in the code. For example, let's say we want to go and search for my YouTube channel, or we want to go /Steve's teacher. Then it is simply echo URL, and because we imported the URI module and made this a URI type with parse URI, we can use a / and just say Steve's teacher. Now if we were to echo this, we would get https://www.youtube.com/Steve's teacher. So this allows us to work with this URL in a more friendly way than what we would usually do in other languages, where we'll need to convert it to a string, add this, convert it back, or work with that however. But this allows us to just use a / and Bob's your uncle we can append to this link. We can also get the host name simply by going echo url.hostname, and this will echo out the host name for us, which is youtube.com. We can also echo out url.scheme, and this will return things like if it's HTTP or HTTPS. So there we go, HTTPS. We can also check if a link is absolute. So we go is absolute and URL. This is true because this URL is absolute, because it starts with this. However, if we were to do something like parse URI and just said stevesteacher.com, then we'll get false, because this is not absolute, meaning it doesn't start. It's like working with a file system where you have your absolute paths, which is like /home/net. That is your absolute path. In this case, this part here says it's the absolute path. However, if I were to just go documents /tuts, this would not be absolute in the file system, because it does not have a absolute starting point from where you can trace back to. Same with this. It doesn't have a www, it doesn't have an HTTPS, so it is not absolute. Now let's say we have a little FTP server. Let FTP is equal to parse URI, and we just go FTP : /127.0.0.1 : and let's just go 3001. So basic FTP server, a file transfer protocol server, and it's just pointing to localhost port 3001. And we're not creating anything, this is just parsing the URI. We can easily get the port of this by just going echo ftp.port, and that will allow us to get the port on which it's running at. So if you do have some sort of URI that does use a port, then you could easily get the port by just using .port. Now you can of course go a little bit stronger here, and let's say we go netsu : my password 123 at Linux desktop, and here we have
another version of FTP where we basically have our username, our password, and then I have no idea, I think this is our desktop or our host name. And in here we can just say username, password, and hostname. And it will automatically be able to parse the username, password, and hostname from this FTP URI that we passed in. This is the awesome thing about the URI module. It is so powerful because you can pass almost any URL in here and it will be able to parse it for you in the correct way. So now if we were to run this, we would get netsu, my password 123, and then Linux desktop as the hostname. A nice feature it also has is, let's say we echo out encode url.com/ and let's say it says this is my website. Now we're lucky enough that if we run this, it will actually parse it for us in a way that is easily understandable by the computer. So it basically encodes it into a normal URL, an actual URL, where spaces becomes plus symbols and forward slashes becomes %2f and so on. If you don't want it to use plus signs, you can just pass in false at the end, and now it will no longer use plus signs, but instead %20. So it depends on what format you want, but this allows you to easily encode it into the format you need. Let's save this in A. We can also easily decode a URL by just going echo decode URL and just passing in A. And there we go. Now the link or the URL has been decoded into what it was originally. If we were to include plus symbols here, so we were to remove that false, then here we could pass in false here and it will not decode plus symbols. So now we will still have our plus symbols here. So it depends on how you want it. If you're going to have plus symbols here, you could pass in false here so it keeps the plus symbols after decoding it. Let's go let URL is equal to parse URI. So here we have a URL we can work with. And let's go /quotes. Then the nice thing about this is, let's say we go echo and we say URL. We add a question mark and we can add an object here. For example, user mic. And this will add a query parameter. So at the end, it will add that query parameter, which some GET requests use in URLs. Nice thing about this is, again, it keeps the syntax very similar to what you would see in a normal URL, making reading the code a lot easier. And that's the basics of working with the URI module in Nim. It's great if you're working with URLs and you need a little bit extra support. So let's start off by just importing std/times. And let's start off with something cool. Let's go let CPU duration is equal to CPU time. Now it's just a little cool function that allows us to calculate the time a program took to execute. So you can say echo took so long to finish the program. And here we just go CPU time, so we call it again, minus the CPU duration. So this is basically the start time. I can actually call that start time. So basically what's going to happen is it's going to get the current CPU time and minus it from the time it was when we first started the program. And it's going to tell us how long the program was running for. So if we were to run this, but this is a great way to time code if you want to see how efficient your code currently is and what pieces of code is taking the longest. If you put some CPU time on it, then you can see, okay, I'm saying this one is taking 50 seconds as an example, while this one here is taking 2 seconds. And this will allow you to configure your code to be more efficient. But that's just a nice tip. It's not really too much part of the rest. So let's go let A is equal to parse. And here we can input a date string. So let's say 2002, the 8th month, and the 5th day. Now we could just do this. However, we need to keep in mind, Nim doesn't know what is the year, month, or day, because everywhere it's different. So what we should do is we should say, comma, specify, these are the years, these are the month, and this is the days. For example, if we put 3 Ds here, then this could be something like Sat for Saturday or Sun for Sunday. Just as an example, where 2 Ds would represent, if I just go back here, 2 Ds would represent 2 digits. 1 D would represent here 1 digit, so it will be like that. Whilst 2D will always be 2 digits. And in 4Ds will be the full day name, so not just Sat, but Saturday, and so on. It's also available on the Nim documentation. Anyhow, we can just say echo and then $A, the dollar, just with everything else, will convert it to a string. So here we go. So now this is the date that we currently have here. If you hover over this, this is of type date time. So it's not a string, it's not something else, it's specifically a date. You can also do something like echo between, and this will get the time between 2 dates. So here we can pass in A, and then pass in parse 2024-01-15. And we can again pass in the format it is currently in. And now it will tell us the time between these two. So here we can say it's 21 years, 5 months, 1 week, and 3 days. We can also go, let's say, let D is equal to date time. And I believe this is only for newer versions of Nim. So anything after version 1.5. So Nim version 1.5 and up. From Nim version 1.4, you may not be able to use this. So just take that as note if you're using an old version of Nim. If you have Nim version 2, this should be perfectly fine. So we say 2005, M, which is month, and then August. The 5th day at hour 23, 42 minutes, so 11 p.m., 42 minutes, and 21 seconds. And here you'll also see it gives us this. You can also add nanoseconds and zone if you want to. And of course, echo D as a string. And there we go. So 2005, 8th month, 5th day, and so on. So that's another way you can create a date time object if you're not fond of parse. We can also have B, and that can be init duration. And let's say weeks is equal to 3, so 3 weeks, 2 days, and 4 hours. Basically, this is a duration. It's not necessarily a time. So we look here, it's a duration. The nice thing about this is we can do something like echo A plus B. So now we're going to take this datetime and we're going to add 3 weeks, 2 days, and 4 hours to it. So if we take a look at it now, you'll notice times have changed. Of course, again, to convert this to a string, you can just say $, and I will convert this duration to a string. It also works with mathematical operations, so B times 4. And if we were to run this, it will be 13 weeks, 1 day, and 16 hours. So if you want to double the duration, it's simply just a times, which is awesome. You can also do comparisons. So let's say let D is equal to init duration, weeks equal 5, days equal 1, seconds equals 44. Now you can echo out, is D larger or equal to B? So now, if we were to run this, we'll get true. Ignore this one here, that's still from this echo. We'll get true because D is longer than B. You can also do in days and pass in D, and it will get the time or the duration in days. So if we go like this, 36 days is this. You also have things like in hours, in microseconds, in milliseconds, in minutes. So you can do this with more than just days. You can also convert it to an array by going to parts, and by doing this you'll get an array 000440015, where this is the weeks, this is the days, and this is the seconds. You can of course also go weeks like this, and then if you were to run it, you'll only get the weeks from it. So you're basically passing in a constant pointing to the index in the array where the weeks are being stored. So that will return the amount of weeks that is currently in the array. Cool. You can also do something like init duration. Let's go minutes equal 5. Let's divide that by 3. So now you get 5 minutes divided by 3. And this is because we can do mathematical operations with duration. So that will be 1 minute and 40 seconds. Anyhow, let's echo out, convert, days, weeks, 99. So it converts from one interval to another, and this will return us with 14 weeks. So it's going to convert from days into weeks. So there's going to be 99 days in weeks. So if we run this, we'll get 14 weeks. If we were to swap this and say weeks, and maybe try and convert that into days, we'll notice we had 693 days. Now sometimes you want to get the current time. It's as simple as going let f is equal to get time. This will get the current time. So if we echo out f, then here we go. So this is the current time. You can also do something cool as let d is equal to days 5. If we were to echo out d and run this, we'll get 5 days. So we get the duration here, or in this case a time interval. So this will give us 5 days. We can easily go f plus d because we can add time intervals or duration to time and date. So if we were to run this, then now 5 days will have been added. Alternatively, instead of get time, you can also use now, and this will also get the current date and time, as you can see here. Now if you want something more like a string, you can echo out get clock string. This will get the current time and convert it into hours, minutes, and seconds. You can also pass in values like now, and let's say we say minus hours 3. This is the same as days, but in this case we're using hours. If we were to run this, we get currently it's 9 AM, 40 minutes past, 55 seconds. Then here it is 6 AM because we subtracted 3 hours from it. So if you pass in nothing, it will return the current time. If you pass in something, it will return that time as a string. And in this case, we can actually subtract and whatnot from that time to get the specific time we want. Now we have a similar item, but for the date. So we can say get date string. And this will get the current date as a string. 2024, first month, 15th day. We can also get the time of week, so get day of week. And let's say the 7th of August, 2005. If we were going to run it, we'll get Sunday. So this day here was a Sunday. We can also get day of year, and this will return us 218. So this was the 218th day of the year. You can also get the time in month, or the amount of days in a month. So get days in month, and let's just go Ctrl+C+V. Then here we can just say, go like this, February, and let's do between 2000 and 2001. You'll notice one has 29, one has 28, because one is a leap year. So this is very useful if you want to know if that year is potentially a leap year. Another way you can do this is you can say get days in year, because a leap year has one extra day. So then we just have to pass in the year, not the month, and Bob's your uncle, we get 366 days and 365. You can also get UTC, and this will get the UTC time zone. And again, you can pass in a time if you want to be more specific. So here, if we run this, then here you'll just get an etc/UTC, and in here you'll actually get the time, but UTC is leap year 2000. Just to end it off in a simple note where this will return true because this is a leap year. If we were to make this 2001, we'll get false because it is not a leap year in 2001. So let's import std/colors, and let's echo out coal brown. So if we were to throw this here, so let me copy that into a color picker, let me paste that, then here we go. So we'll get this color if we were to throw it into a color picker. Similarly, we could do something like call lime, which will give us the code for lime. So we paste that in here, then there we go. Now, a quick overview of what these digits actually mean is this is a hexadecimal digits. Now, basically it's red, then it's green, then it's blue. So every 2 digits is a color. You can also do 1 digit of each. So 0F0, that will give us the same color. And for example, F0 is F, that will give us this purple. So you could do only 3 digits if you want, but generally it is 6 for accuracy. Where 0 means none of that color and F means all of that color. So if we were to say F00, which means all of red, none of green, none of blue, what do you think we'll get? We will get red because there is none of the rest, there's only of red. Or 0000FF, none of red, none of green, all of blue. There you go. So you can go from 0 to 9 and then A to F. So for example, 09 AF EC, something like this will give you this color right here. And here, if we actually move it around, you'll notice how it changes depending on the color we choose. WeSchool is actually a great place to learn things like this as well. So if you want, you can actually check out here. They will actually explain a lot of this for you. So if you're interested in it, you could take a look at this. For example, color hex will probably give you a good example of what it all means. There you can see red, green, blue, where RR is red, and you see. So if you want to know more about it, go to WeSchool. They're actually a pretty great source to learn more about it. But see, that's basically all that this means here. It just defines what colors you will be using. Next up, you can convert this, because currently this is of type color. But if you want to convert this to a string, you can just say $. And then here you will have the string representation. Of course, it will look the same, but this is now of type string. So if I were to say let x is equal to this, you'll notice x is a string. If I remove this, x is a color. $. Will almost always convert something from a type into a string. You can also add colors together. So let's say echo call lime with call brown. This will actually add the 2 colors together, which is nice because since they're being added together,
With the nice thing about colors is they can't overflow, so you can add any color you want with it, and it will almost mix the two colors. So we can actually copy this and take a look at how it will look if we were to paste it here. So that's what you get if you were to mix those two colors, is you'll get this ugly greenish color. Or lime plus coal red. That will give us this. As you can see, all red, all green, but no blue, because we just added green and red. So that's all it really did here, is it maxed both of those two up to the limit, but then did not add any blue. So then you get yellow. You can also add things like this. So let's say coal lime. Is that equal to color? And in 0x, this means you're going to do a color. So you're going to tell it about a color. And here you can put in a hexadecimal value. So 00FF00. Let's just go capital F just in case. And this will return true because that is the color code of green in hex. But if you were to go, then you will see it actually returns false, because the color has changed just a bit, and we know color lime is just green, so there's no red in it. You can also create RGB using color. So RGB 255.199.38. This will return us a hexadecimal value, but we created it using RGB. You can also extract RGB by going extract RGB, and let's say color lime. Now we get red 0, green 255, and blue 0. Now RGB is very similar to hexadecimal, where the only difference is, instead of working with letters, it only works with numbers. So it will start with 0, and then FF would basically be 255. So all green and no red. So if we go call brown, that will return us 1654242 for red, green, and blue. You can also change the intensity. So intensity to, let's go column red 0.2. And if we run this, you'll notice we get 330000 instead of FF0000. So if we take a look here, all that's happening is this here. So if we were to go F00, it will be up here. If we were to go 300, it will be down here. So all it's doing is the intensity moves this little box here from the top to the bottom, where 1 would be at the top and 0 would be at the bottom. That's all the intensity really does. It moves it up and down here, making it lighter or darker depending on the value you set. You can also check if something is a color by saying isColor and inserting a string such as silver or hashtag F0F1A0. That should work. Or even here, hashtag IamColor. If we save this, we should get true, true, false, because silver is actually a valid color. This here is a valid hexadecimal color, but this here is not a valid hexadecimal color, so it will not accept this. And to prove these are colors, you can actually also go parse color, and now it will return these colors for us. So CO is silver, and here it just returns the hexadecimal value we added to it. And that's really that for the color module where we work with colors in Nim. Now we'll be parsing this config or this conf.ini. This is a very basic example of how a conf.ini will look. You might have seen this if you played games on Windows, and you might have had to edit a couple of ini files. But it's a very basic configuration file. Okay, let's get to ini file reading. So let's import std/ParseCfg for ParseCfg. Then we can just say conf file is equal to conf.ini, which is in the same directory as our main.nim. Cool, so now I can just say var conf is equal to load config, and we just pass in the conf file. And let's just go conf, or let's go echo conf dot get section value. And the first part we're just going to leave empty. This is the tag. And the second part we're going to say char set. So we're trying to get this right here. The reason the tag is empty is because this is called a tag. So these are the tags. Char set has no tag, so we don't need to pass in a tag for char set. Now when we run this, you see we get UTF-8, which is what is stored here. Then of course, if you would want to get the username, you can use the tag profile and fetch username. So profile and username. Now we'll get the username. Give me 34. And let's say we want to get the GPU tag here, so to use GPU. Then we can say system, because it falls under the system tag, and we can specify -- use GPU. And here, if you run this, we'll get on because -- use GPU is on. So that's how you can read from a config. Let's actually go to writing and creating our own configuration file. So let's go var new conf, and that is new config. And we can just say new conf dot set section key. Then here again, this would be the tag. Let's just leave that empty. Then this right here, that would be this. So it will be the item, which is char set. And then the value you want to put in there. So let's go UTF-8. Then here, let's create one with the tag of package. So again, here, that's a tag. We say name is my conf. And let's create two more here. -- RTX on version 3.10.1. And let's create one more that's under the tag of author with the name Steve's teacher. Now we can just echo out $new conf. Again, we use $ to convert something because there's a config. We want to convert it to a string, so we use $. And this will print this. So we have our UTF-8 char set here. Then we have our package tag with the 3 items we set. And then we have our author with the item we set here. Now let's say you want to modify an existing value here. Well, that would be simple. We can go here. Let's update this name to config file. And this also works if you're reading a config file. So if you said load config here, you can also use this to update existing values. Now, if we were to print this, you'll see it now says config file. You can also delete parts of this. So let's say you instead want to delete this right here. So then you can just say del section key. So now we can delete the name in package. So if we run this, we'll see name is no longer under package. So let's also import alongside this streams. This will allow us to read files in stream. So let's go var f is equal to new file stream. And yeah, let's just bring back this variable right here. We pass in our conf file and we say fm read, which means we just want to read the file. Then we can assert if f is not equal to nil. Otherwise, cannot open. And we can just append conf file. So let's do this. I want to actually see if we run this. There we go. So it did work. We just got a warning that this is not being used, but that's fine. Now if we were to change this to INIS, we'll now get an assertion that fails right here. Just so we can practice a little bit with the things we don't really use very often. So assert will basically crash the program for us, telling us, hey, we cannot open this file. Then we can go var p, which is of CFG parser, and we can open. I'm just going to give these better names. Let's just go file and parser. Then we can say open parser file conf file. And of course, at the end, we want to say close parser. And this is var, not char. Cool. So I'm going to say while true. So we're creating an infinite loop here. Then we're going to go var e is equal to next p, which basically means go to the next line, and this should be parser. So we can actually go and make this line. So var line is equal to next line here. And we can say case line.kind of CFG EOF, which basically means end of file. So if we reach the end of the file, we want to break out of this while loop. We can also do a CFG section start. And we can simply go echo new section line.section. And in here we can say CFG key value pair new key value pair. We can go line.key line.value CFG option. Here you can go option, and we can again just do a key and value, and then finally CFG error, and we can then just echo out line.msg, which will return the error message. There we go. So we basically created a little file reader for our, and let's go file, for our parser. So this CFG parser here allows us to parse a file or a config file and then read that file later with file stream, where we can get each and every line until we can close it. So if we were to run this, and let's just resize this a little bit, we get new key value pair charset UTF-8. So this right here, that's a key value pair. New section profile. So this is their section. This is the tag. The tag is the section. Value pair username and gimme34. Value pair description. New section system. And then finally this here, this is an option because it has 2 dashes at the front. So this is considered an option and not a key value pair. So here it gives us that. These are often most commonly found in, let's say, when you're working with a large amount of data. This could include things like the username, the email, and the age of a person. Anyhow, so yeah, it's very simple. You have whatever the field is, a comma, the next field, comma, the next field. The stop here is a header field. It explains what all of the following fields will be structured like. And here you have the actual fields. So it's like a mini database where now we have the username, this is the email, of course, and this is the age. All right, so let's get started. I'm just going to delete these 2 files. So the first thing we want to do is we want to import std/ParseCSV, and this will allow us to parse CSV files. So let's create a parser, which is of type CSV parser, which is from this import here. Then parser.open, and we can open up this users.csv. So users.csv. Then we can echo out parser.headers. Now by default, parser headers are nothing, so it's empty. But we can read them by going parser.read header row. And what this will do is it will read
this row right here, which is the header explaining what the following values would be. So now if we run this, we'll get username, email, and age. We can also specify the separator with single quotes, not double quotes. So single quotes, this is to specify a character, not a string. Now the separator is this part right here. It can be anything. Most commonly, you will see it as a semicomma or a semicolon or whatever that is called. But sometimes you will also see something like this or something like this. But most often, most common practice is to use this. So now, instead of getting this one big sequence here, we can just run it again and we'll get each one in the sequence as such, because now we're parsing with the correct separator. Now we can of course go echo parser.readRow, and this will read the next row. So in this case, it will start with the first row, and for each read row, it will go to the next row and read it. So then, if you run this, we get this. Now by default, you'll just get true, which means, yep, it has successfully read that row. But to get the current row data, you can say row, and that will return the current row data. And without that, because it's not a function, so then if we run this, we get true because it did read it, and then here we get this. So Mike with the email and then the age. So Mike, email, age. And then finally, we can do row entry, and we can specify which one of these we want to fetch. So if we want the email as an example, we can specify the email field. And just so we don't get confused, let's just discard this output. And if you don't remember, discard basically just means take whatever this output is and just throw it away. We want to run the function, but we don't care about the output. Now, if we were to run this, we'll get mag.com, which is the email field in here. Now, let's say we read another row, Then we can echo out parser.processedRows. And this will return the number of rows that has been processed, or in other words, number of rows that have been read. So in this case, we have read 3, and that includes this header up here. And then we can just say parser.close. And this is good practice to make sure you close the file after working with it, because if another part of your program is maybe reading this file, or another program also wants to read this file and you didn't close it after working with it, you might get an issue where you cannot read this file, or the other program cannot read this file because they assume this program is still open with it. But anyways, that doesn't really put any output, it just closes the file. Working with CSV files in Nim is incredibly easy, and this is really all there is to it. It's as simple as this. So an XML file is very similar to if you have ever seen it in HTML file. However, with HTML you have specific blocks that you need to use, such as a body, a head, a p tag. You have specific elements that works with HTML. In XML, there's a similar concept, but there's no specific element you have to use. You could specify, I think, like what sort of XML you're using at the top of an XML file, but in this case, I'm not using it. I'm just using the basic XML, where you can define something like a person. The person has a name, they have a surname, they have an address, and as you can see, they're all getting nested inside of each other with these elements, with an opening one and then a closing one, which has a /. So this is the basics of an XML file. It's another way to store data, which you can then use later on. XML is also used in things like designing Android UI, if I'm not mistaken, where you can modify XML files to modify the UI. But that's for a different tutorial, different language, different day. Anyhow, so here we can learn how to work with this. So let's get started by importing std/
XMLTree. Now we can use XMLTree to generate XML. So we won't be writing or reading just yet, we'll be generating this. This is a good visual to show you how this XML will look, or how it is supposed to look, where you have a person and that contains all of the details of the person. You have an address that contains all of the details of the address. So let's go var name element is equal to new element full name. Now what this will do is it will do this. It will create these two tags here. So if I were to just do this, I can copy that, and all this will do is it will create that. So now we have a new element called full element. And in here we can say name element dot add new text Jack Smith. Now what this will do is it will add Jack Smith to this element. So what will we get if we echo out name element? We'll get this full name Jack Smith and then full name. So it's what we expected. You can also go name element dot add, just a new comment. And the reason I'm doing this is because it might look neater for you to instead do this. It might bring back some memories of older programming languages that did something similar. And you might prefer this. I would just like to show you that you can do this if this is what you'd prefer to do instead of brackets. However, I will for the most part still always use similar syntax because I don't want you to get confused too often. So I'm just making a point of showing you that you can do this if you want. This is the user's full name. Now if we were to run and display this, you'll notice we get a comment. So this right here, if we go here, basically did this. Oh, this, there we go. Anyhow, so it basically did this. This right here is a comment, meaning it doesn't really display in the data. It is ignored when this data is being parsed. So this here wouldn't be read normally if data is parsed. And we can check that by going name element dot inner text. Now if we were to run this, we'll get Jack Smith without this comment here because that is a comment and wouldn't be read once parsed. We can of course create more elements. So here, let's go var email element is equal to new element email. Then email element dot add new text jack@gmail.com. And we can of course echo out email element dot inner text if we wanted to, and then get the result. Then finally, let's add one more, and we can remove these echoes for now. So then var address email element is equal to new element address. Now we want to add something similar to this. So to do that, we can say address element dot add new element street, and then postal code and country. They won't really contain any details, it's just so we can add elements to this. And then we can actually also echo out the length of address email. So you'll get 3 because this right here has 3 elements inside of it. If we were to do the same with email element, we would get 1 because it only has one thing inside of it. It would have this inside of it, or the actual email, but it will have one word inside of it. Whilst this has 3 items inside of it. And that's why we got 3 when we got the length of address element. Now one can of course go address element dot delete and let's say 2. When we do this, it will delete item at index 2. So 0, 1, 2. So it will delete country. If we then were to echo out address element, we'd see we don't get a country because we deleted it. If we didn't delete it, we would get the country. Now the reason these are closing like this is because they don't contain any data. So they are self-closing tags. So don't worry that they are doing this, just note it's because they don't contain any data. Now what if you wanted to make this, a tree of XML and not just have individual elements? In that case, you can go variable myXML is equal to new XMLTree, and we can say user data. So that would be this right here, that's user data. Then we can specify what we want to put inside of it. So we can say name, element, email, element, and address, email, element. I don't know why I want to say address, email the whole time. And that is an array. So then you will have this. Then you can go echo $my_XML. So the reason we're using dollar again is to convert it to a string. It's pretty much optional, but, and as you can see, we do get similar to this. But as dollar is optional, if you remove it, then you'll not get a string, but you will still see the same result. So that's just to convert it to a string as always. So dollar always converts to a string. All right. Now you can also, to this, add things like this right here. And these are extra attributes you might want to add to your XML. And that should of course not be an L, that should be a colon. There we go. So then by adding this, you can add extra attributes to this XML tree. So if we were to run this, and let's copy and just paste it here so we know what we're looking at. You'll notice we added these attributes to this XML here. So now it has the class of user data holder and secure of no. So here secure no and class user data holder. These don't really matter that much. It's more for the developer. So you could add a class if you maybe want to add some CSS if you're trying to display this in a web page, because somehow that's possible. Pretty interesting. And secure no, that's again something just for the developer. You can maybe put it in there to maybe notify the next user who views the data that this data is not secure. Cool. Now I also have some couple other things you might want to learn, such as echo XML header. Now this here will give you a generally used XML header. So if we were to look at this header, we could actually copy that and put it here. Because oftentimes this is the XML header that you'll see on the top of your XML. This is to specify things like the version, encoding, and other details that might need to be known for the parser later on. We can also go my XML and say, let's say index 0. This will get the first item, which is a full name. Because if we were to remove this, we'll get this. And then you'll notice the first item is full name inside of this. You can also get .attribute or attrs length. And this will return the amount of attributes in your XML node. And yeah, we'll have two because there is version and encoding. These two are version encoding. My bad, I'm looking at the wrong one here. There is, if we were to just print this out again, run this, you'll notice we have secure and class. So class and secure. These are the two attributes that are being counted here. There are two of them. You can also go .child address. And this right here will get the address element and all its children. So it will just return the address. You can also go .find all. And let's say email as an example. And this will find all of the elements that are email and return them in a sequence so you can access all of them. So if you have a really big XML file with multiple users who then have multiple emails and whatnot, you can do this to get all of the emails inside of that XML. You can also do clear, and this will clear in XML node and all its children. So if we go echo my XML, and this of course should not be echoed, then we'll get this user data of the classes. However, it has no more children because everything else has been cleared. Cool. You can also insert, so my XML, an element into a specific index. For example, new element, age, and let's say at index 1. So it will currently be 0 and then index 1. So where the email element is, it will be inserted. So if we echo this, echo my XML, my bad, I open my code editor. So then here where email would have been, it's now age, and email has been moved downwards. You can also get the name of an element by going .tag. So then if we were to run this, you'll get user data. But if you go child full name .tag, you'll get the full name child element. All right, enough of that. Let's import our XML parser. So import std, actually we can just put it here, XML parser, and then we can just say let XML is equal to load XML, and you can just say index.xml. So that's this file right here. So now we're loading it into this right here. We can then echo out XML. Bob's your uncle, everything that's in here will now be put here. Note we don't get this here. That's because it's just general header information about the XML. So it isn't really important for us to know that. It's mostly important just for the parser. So it's ignored. Similarly, you can also do parse XML. And then instead of parse XML, you can do this and Control A, C, V, and there we go. So now we can parse this and then echo out XML. Now if we run this, you'll notice it is also parsed. And that's the basics of working with XML files. Simple as just parsing the file and then working with all the content inside of it. Now this module contains methods that allows us to extract substrings without actually needing to use regex. So let's start with importing. Import std/strscans. And then let's say we have a const input, which is equal to just 1, 2, and 4 without spaces. Then we have a variable x, y, z, and they're all int. Now we can check if scanf, and we take an input, and here we can pass in this little bit of syntax here. So when we go $i, not $1, $i, now $i matches a decimal integer. So it will try and match a number. And we can go $i again. Why do I keep saying 1? And then $i once more. We can then pass in where we want to store these results. So in X, Y, and Z. Then we can echo out has matched. And we can just maybe put a \n and \t there, just to give it some bit of pizzazz so it's easier to tell what's happening. And let's just do 1 for now. Oh, my bad, there should not be a dollar symbol there. There we go. So it will take this input right here, which is this string value, and then these values that we have here will be stored inside of these variables. So this $i will correspond with this x variable, which will be 1. This $i will correspond with this y variable and will be 2. But let's first just test out this and see what happens. And we'll get has matched x colon 1, because x here would be 1. We can then do the same for y, and then we can do the same for z, just so we can see that we do get what we expect. So now if we were to run it, you'll notice we also get 2 and 4. So it stored these values into x, y, and z. So you might be wondering, okay, in which scenario would something like this actually be useful? Now, in a scenario where you maybe have some sort of input that you know will be a specific structure, such as this, where you have a number or 3 numbers in brackets separated by commas, you know the input will always have this exact layout. So what we can do is we can then use this knowledge to store the values we get from these into these variables. And then we can of course use them as needed. Now of course this can also be a lot more complex. So we can do something similar to variable year, month, day, which are all integers. And why not, let's go like this. Then we have identifier, which is a string, and my float, which is just a float. So then here we can say if scanf, then here we can put an input. I'm just going to put a random piece. Let's actually pass in this input. We don't need a random piece of text. So we're going to pass in the same input, but we're going to expect something different. So then here we can just say $i, $i, space $w, and W matches in ASCII identifier. So in short, if you were to look at this in Regex perspective, it would be something like this. A to Z, A to Z, as well as underscore, and also 0 to 9, and anything that follows. So it's basically any piece of text. So it will try and grab a word. Then we have $S. $S skips any optional white spaces. So basically it just says, okay, just throw away any white spaces we have. So it doesn't store anything inside of a variable. It basically throws away whatever is there. So this $S does not put anything inside of any of these variables. Keep that in mind. And then we can use $F, which is used for floating point numbers. So 0.1516 or 3.14159, etc. any floating point value. We can then of course store all of this in, let's say, year, month, day, identifier, my float. And let's just make this normal casing. There we go. Or even underscore float, whichever floats your boat. Okay. And then we can just echo out. We have a match. So the reason we can use an if statement here, and we can just remove all of that, is because this also checks if the input is what we expect. If the input is valid, it will actually fill these values here with their respective values. So it will fill these variables with their respective values. But if the input is not valid, we won't get anything here. So we can actually say else echo no go. So if we were to run this with this input here, which does not match the input we should be receiving, we'll get no go because it does not match this input. However, if we were to make the input something that we'd expect, so in this case we actually expect a date, in case the year, month, and day did not really explain it. So we would look at something like 2002, 08, 05, because look at the dashes, so it will make sense that we have those. And then this is the word we're going to match, so this will be the identifier. And then 12.30. So let's pass in this input and see if it matches. And we do have a match. So let's parse this and let's see what's happening. So we have this $I, which will try and get a number. So year will become 2002. Then again, we have another $I, which will be the month, which will become 08. Notice we have the dashes here. So we specify that there are dashes there. Then here we have a $I, which will be 5 for the day. Then we have a space here, and we have this identifier. And that is what this W will do here. We'll put that whole word in this identifier. So if we were to do identifier here, we will get that identifier. And then we have $S here, which basically means throw away the space. Alternatively, you could have also done this. This would be valid as well. So then if I were to say my float, they will still get 12.3. But if we would do $S, it will throw away that white space. Now the benefit of $S is, let's say we have this here. And now we have two white spaces here up the top. Look at, there's two white spaces, not one. So if we were to run this, you'll notice nothing happens because our input doesn't match. However, if we were to put a $S here, it will throw away both of these white spaces here, which will make it match and give us that 12.3 we expect from my float. So that's the point of $S. So it might seem useless, but once you have more than one space, it can greatly reduce the risk that if some data were to come in and have the wrong format, you can easily fix that by just putting a $S there and make sure those spaces are ignored. Now, this is just a very basic example of what you can do. There are a lot more options out there that you can even throw in here. such as $B, which will look for a binary integer. It will pretty much just use parseutils.parsebin, in case you are wondering. You also have $O, which will look for an octal integer, $H for an hex integer, and so on and so on. And if you want to specifically match a dollar symbol, you can do it with $, so it will escape this dollar here, and so on. So there's a lot more you can actually do. You can take a look at the documentation I wrote in the description for more information about it, as well as the actual Nim docs, because there's so much here that you can do, and it can become very complex. But this is a good example of a starter point where you can actually take these values, parse input with it, and then generate yourself an output. For example, this person was born in year at exactly, and let's say my float. Now if you were to run this, you can take that strange input and you can use it to generate yourself a nice output. So let's import std/stats, and let's create a variable called class1mark. We'll call class1marks, which will be of type running stat. So stats allows us to perform basic statistical analysis of data, which is fancy pants words for it makes math easier. So class1marks.push. Now of course we could have set it up here, but this is just to show that we do get a push value or a push function from this stats module. And in here we can push a sequence of data, so let's say 70.0. Alright, so here we go. So this could be the marks that maybe the first class got on their first test. Now we can of course echo it and say class1marks, and we can see what data we get. And you'll see we get number of probes 7. The maximum value here, that would be 95. The minimum value would be 30. And the sum of them is 426. The mean value is 60.85. And then we have the STD deviation, which is 19.23. To convert it into a string, it's as simple as just putting a dollar symbol there. And boom, this is considered a string. So it might still look the same, but it's a string. Now you can also get class1marks.n. N gets the number of data in the stats. So if we run this, we'll get 7. So it's that probe value we saw earlier. So if I run this again, you'll see that number of probes is 7. We can of course later push more values here. So let's say we also want to add maybe a couple of students that did their tests late. So it's 10.0 and 90.0. Then if we echo out class1marks.n, we'll get 9 instead of 7 because there are 2 new values inside of this running stat. Now you can also do .mean, and this will get the mean value of these values. So now it will be 58. Now this is pretty much just the average of all of these values. So all of these added together divided by what would be 9, because there's 9 in total. That will give you the average or mean of all of these values. So the average this class got was 58. You can also do variance. This computes the current population variance. You can also do with an S, which will get the current sample variance, and that will give us 746. You can also get the skewness, and this will get the current population skewness, which is negative 0.36. as well as skewness S, which will get the current sample skewness. And then we also have the kurtosis, which will give us negative 0.72. And then we also have with the S, which will of course give us the sample version of it, which is 0.24. Okay, now back to things most of us will understand. We can also create another class, so I'm going to copy this, paste this here, call it class 2, and then I'm going to say class 2 marks dot push. There we go. So now we also have the same version for class 2, so well, not the same version, but the same idea. If we were to print this out, we'll see we have 7 values with the max of 100, the minimum of 25, the sum, the mean, and deviation. Now we can also add these together. So class 1 marks plus equal class 2 marks. So we can add these two running stats together to create a bigger version of the running stats. So if we did echo class 1 marks, you'll notice it is significantly bigger with 16 number of probes, the max of 100, the minimum of 10, the sum actually of 0, and the mean of 59. And then of course you can, if you wanted to, clear this data and then echo it out again, and you'll notice it is empty with 0 probes, no max, no min, no sum, no mean, and no deviation. Deviation is none, which is just not a number. And that's the basics of the stats module in Nim. For those of you who do work with statistics and whatnot, will probably find this very useful. Templates don't return anything. They are a substitute for something else. As an example, or a fun fact, would you rather, this is a template. So is this, and this, and this, and so on and so forth. All of these values that we use for comparison, just as an example, are templates in Nim. So let's create our own comparison template just so we can get the hang of it. So let's say template, and we get an autocomplete, which is nice. And we're going to use backticks, not single quotes, so not these things, but backticks. And we're going to put 2 exclamation marks. And we'll get to the backticks later. For right now, just note we need the backticks here. Then for our arguments, we want A and B, which are both untyped. And we'll get back to this. And then the return type will be untyped. We say not A equal B. Alright. So take note, this is not a function. This is a template. But it will be used similar to a function. Now let's walk through this first. So we have a template that has 2 exclamation marks. It will take an A and B, which are both untyped. And untyped are just parameters that can be passed in before they are even assigned a value. Since this will not enforce type checking, since it is untyped. This means you could pass in 10 or 5 or 50 and it should work pretty much fine, because you don't need to check the type before they're passed in. And then it returns untyped as well, so it will not care about the type it returns. And in not A equal B is pretty much what we're doing is replacing this. So we are doing not equal to, we're just replacing it. Now to use this template, we can do it the exact same way you'd use not equal to. So we can say hello, and here we can go hello. So now we're asking, is hello not equal to hello? If we run this, we get false, because they are equal to each other, and this checks if they are not equal to. So we'll get the same value if we were to use this. If we were to make this a lowercase h, now they are not equal to each other because one has a capital case H and the other lowercase. Now if we run this, we get true, because they are not equal to each other. So this is pretty much templates.
They are similar to functions in a lot of ways, but they are not quite functions. So let's do another example of templates. Let's go out and say echo, and here we can just say x not 8. So this will check if x is not equal to 8. This will throw an error because we first need to define x, which is of type int. We don't have to say what is inside of x, just that x here exists. So if we were to remove this declaration, it will throw an error because it's not declared. So in this case, we just define x and we check that they're the same. We run it, we get true because they're not the same. But if I were to set x equal to 8, and take note, remember, code goes from top to bottom, so this will not change the current outcome. But if I were to put this echo underneath that x, it will be false because now they are the same. And this checks if they're not the same. However, take note, when we pass in untypes like this, these two need to be the same value or the same type. If I were to make this 8 here a string, we'll suddenly get an error because there's a type mismatch. You cannot do x and 8 here. And we'll get back to this later when we discuss the difference between a template and a function. But just keep this in mind, that you cannot pass two different values in here, or two different types in there. Let's create another template just as an example. Template set string. And note here, I'm not using my backticks, and this works perfectly fine. We're going to pass in a typed, make it equal to variable a string equals hello. And I'm going to explain this right now. So we have our templates, we have our set string, and this is not in backticks because this is just a normal word, like a regular variable. However, because this here is symbols, so if this was a plus, or even let's go like this, it will tell you, hey, what the heck are you doing? We don't know what this is, because that's not a valid variable name. But because templates oftentimes use these different types of symbols, we can overwrite it like that. Now when we do this, it's okay because we have our backticks to specify these are symbols. Alright, so here we have our set string, and you can also do this like this. This is perfectly fine. It won't change the outcome of the code. So if you want to put it in backticks, you can. We pass an a of typed, and type means that what is passed in should have a type. So it will enforce type checking on the pass-in of this variable. Then here we say variable a, so we're selecting this variable. We're saying it's of type string, we make it hello. So let's go here and say variable s for string. We're stating that it is a string if I can type. Then we're saying set string, we're passing in the s there, and if we echo out s, it will take this variable and it will change it to hello. And there we go, we get hello. Take note, however, if we were to make this an int, we'll get an issue because we're changing the type of it to a string. Here, if this was an int here, it would be fine because now both of these will represent int. You should take note that this variable a is quite literally the literal variable s here that is being passed in, and that is why we can just redefine it and then reassign it. So we should take that as note. And this is also where we get into the difference between a function and a template, because some of you will probably be confused as to when to use what. So you can think of a function as something that you do to get an end result. For example, as a lot of people like to describe functions, it's like a recipe. So you want to make something like baking a pizza. So you give it specific ingredients, which would be the input parameters. So here we go, make pizza. And then here we have our ingredients that will be passed in here. And then the return type, which we're just gonna not care about that right now. We're just going to discard this. So we're taking in our ingredients that we want to work with, and we'll follow a step-by-step guide. So this will be mix ingredients, heat oven put in oven, wait, remove, return the pizza. So it will basically execute point by point, giving us what we want at the end of the result. So in more programmatic terms, it takes a function, or a function takes an input, it performs an operation, and then it returns a result. It checks that everything you have put in, aka the ingredients, are correct. So the right type. So this would be creating an add number function. Pass in A, you pass in B. You want int as a return type, you return A plus B. Now a template is more like a shortcut to get from point A to point B. It doesn't follow any sort of recipe. Instead, it swaps out what you give it. That's what's happening here. We give it S, it swaps out S here. We give it X, it swaps out X here. We give it 8, it swaps out 8 here. So they don't return a result because instead they replace parts of your code with something else before your program runs. That is also why when we save the file and we do something like make this like this, you'll notice, and let's just remove that, we don't need that example anymore. You'll notice we get this big S here, or this big error here, because of the inconsistent typing. Because before the program even compiles, it can tell you, hey, I cannot replace this variable inside of setString, because this one, it wants a string, and it should check that that variable that we're passing in aligns with whatever we're doing here. This also makes them more flexible because they don't enforce typing as strictly as functions do, as seen with these untypes. So pretty much you want to build a function because you want reusable logic. You want to be able to make pizzas over and over and over again. You want to be able to call that function. Templates are useful when you want to create a shortcut for something, and we'll be getting into using more templates right now to just show you how powerful they can get. So templates kind of fill in the blank in your code. It takes something that might have been a lot of effort and it dumps it down. But it doesn't generate something new from your code like a function would. It takes your existing code and spits out something so you don't have to repeat typing long, boring pieces of code over and over again. Alright, so let's create something a bit more complex just to show you the power of it. Let's go template with file. It takes an F, which is the file. So you can even call this file if you want. I'm going to go F, file name, mode, actions. All of these will be untyped. Then you have untyped. And now here we have variable F, which is file. So we're stating that F here will have to be a file once it is passed in. Or will become a file once it is passed in because it is untyped. So it doesn't need to be one as soon as it is passed. We then say if open, so it's just random, or just this regularly reading a file. If file name mode. And of course we have our else, and our else will just quit, cannot open file name, and then we can just make sure this is correctly indented. Then here we can just say try. Here we do our action, so actions, we're passing that in, and in here we say close file. Now we go down here and we say with file. So we're using this template we just created, and we want to pass in text file, my file.txt fm readme of fm read, not readme, because this is the mode we're going to open it up in. And in echo text file.readline. Now this may look confusing, but what we're doing here is we're passing in actions right here. So we're not putting it here in the process, or here as a process. And we'll get to doing that in a different way later. Now what's going to happen here is this with file creates a variable for us. So we're passing in f here, which is untyped, and then we're setting what f is going to be. So we're pretty much passing in a variable here that now we can now use with this with file. We're passing in the name we want to give it, the mode, as well as the actions. And this here is the action, so it will execute there. So if I were to go here, ooh, very big, create new file, call it myfile.txt, and then say hello world. Then here, if we run this, we'll get hello world, so what is saved inside of that file. Now you could also move this up here by going procedure equals, and we just throw this in here like this, remove this part here, and now we need to actually call these actions because now we're passing in a procedure, so we need to physically call it. We cannot just throw it in here because we now need to call this procedure we make, and it will work exactly the same. So if you prefer this method, you could do it, but this is just an example that you could also do it fine like this. You don't need to call it, you just place it. Now to know the difference between a function and a template, I'm going to create a function that does the same thing. So I'm going to just copy this template here, call it with file func to specify it's going to be a function. Here we need to specify variable file because we're going to pass in a variable in here and it's going to be turned into a type of file. The name has to be a string, the mode has to be file mode, and the actions needs to be a procedure. So here we need to specify it's going to be a procedure, and then it will return void, so nothing. Then in here we can remove this here because we no longer have access to the variable being passed in as simple as this, because it is now being set here. So we remove that. We can say our open, this stays pretty much the same. We call our actions. We still have our except, which will close, or this shouldn't be except, this should be finally, my bad. Because it should close otherwise, it shouldn't close on error, it should close when it's opened or whatnot, it should always close, that's the point. And then we of course have our quit. Now we can call it pretty much the same as with file, so we go here. Now here we're passing in our variable that we want to set. So in this case I'll say text file 2. Then here we have the file name. And I'm going to keep that the same, it's fine. This is going to be fm read. And here we need to pass in how we did that procedure before. And there we go. And this will be with file. We also need to here specify variable text file, which is of type file. And this will be text file 2. So we need to declare it first before we pass it in. And there we go. So now we have pretty much the same thing, but now it's using a function, and it should be function, my bad. Func, there we go. Wait, let me get a proc, forgot function is sugarcoating. Okay, there we go, so now it's a procedure, and it pretty much does the exact same thing as this template here. Now let's take a look at the key differences between these, and let's also just call it to make sure it works. Okay, there we go, we can confirm it also works. So the first one here does code substitution, whilst this one here is a function call. A template very literally substitutes your code before the program compiles. So once it's compiled, it will pretty much write the code for you. This means variables like text file don't need to be declared beforehand. So this if here that we call text file, it doesn't need to be declared beforehand because they're created as part of the substitution process, which we see is being done here, because it literally substitutes this code. So this if here becomes this. We're redeclaring it and giving it a type. And here we're saying what variable we want to store that value in. Whilst functions are called at runtime and require all the variables to be defined beforehand. So you can't, and this is quote unquote, inject code directly into the function like you do with this template here, where you literally throw just this text file here and just goes in there. Here you need to first declare, hey, there's a text file, throw it in here. You need to specify everything beforehand. Now, templates are great if you have a lot of code patterns where you want to inject or substitute some blocks of code. And they're useful when you need like a lot of flexibility in handling operations with varying actions. Functions are best for reusable logic. So not substituting code, but reusing logic over and over again. So if you have well-defined inputs and you want well-defined outputs, and type safety is very important, then go with a procedure. If you don't know which to use, just go with procedure. You will know when to use a template when you get to that point. So if you're not sure if you should be using a template, just use a procedure. If you think it will end up being better if you could just substitute code like with a template, then use a template. Now finally, I'm going to end this tutorial off with one more template example where we use both typed and untyped in the same template. So template, swap if greater. We take an A and B, both are untyped. We pass in T, and it's capital T because we want to specify this is the actual type we want it to be, so we say typed. Then here we say if A is bigger than B, so A and B are untyped. So in this case, the template should in theory work with both strings and integers, because we're comparing size here. We can then say let temp, which is of type T, so this is the type we're passing in here, is equal to A. So we're storing that A, so the original value of A. We then say A is equal to B, B is equal to temp. So we're just swapping these two variables if A is bigger than B. Then here, we can say variable num1 is equal to 10 and, oh my gosh, num1 is equal to 10 and num2 is equal to 5. I don't know why I keep adding spaces. Then here we can say swap if greater num1, num2, and we specify they're of type int. And we can echo out num1, num2. Now if we were to run this, they will be swapped because 5 and 10. Let me just add a little space here. So 5 and 10, they are swapped. But if I make num2 15, it will be 10, 15 and not 15, 10 because they're not being swapped because of the size. We can also change this to text, so we could say world hello, and you just say this is a string now. Now if we were to run this, we'll get hello world because hello is smaller than world. If you were to convert it into ASCII and add them together, it's a very big process, but hello is smaller than world. Or if you sort it, hello would appear above world. So that's pretty much what we're doing. We see world is, we should be sorted below hello, so we swap them and then we print them out here. So we're literally passing in these variables, replacing these variables, as you can see here, and then we're spitting it out. So this is how you can add typed and untyped variables in beforehand. And yeah, that's pretty much how you use them together. It's a nice example of how you can just mix and match until you get the result you need for whatever you are doing. Now, a pragma is a way of giving the compiler more information, and they are oftentimes enclosed in these. So you might have seen them around a bit, even in our tutorials, because they oftentimes find place in these little brackets and dots. So let's use one as an example. Let's say we have let my var, and this is just a variable which is of type string, and we can just say some important variable. Now as your code grows, or your library, or whatever you are building, there may be things that you want to phase out of your code in the future. For example, let's say you created a really slow addition function, or in this case a variable that does not contain important information anymore, or that should be found somewhere else. In that case, you want to mark it as deprecated. Now what deprecated means is it is a function or a variable or whatever you're marking as deprecated that should no longer be used and will in the future be removed. So here we could just say deprecated. this will mark this variable as deprecated. So now, if I were to echo out my var, first you'll notice we get like a little yellow line here, which says my var is deprecated. So it tells you before you even compile the program that, hey, what you're trying to use right now should probably not be used. But this will still run and compile as expected. So if we go here, you can see we still get some important variable being thrown out here, so you don't have to worry about it. It is just pretty much for the user to know that, hey, you should probably not be using this anymore. There are alternatives. Another example could be if we were to create a no use procedure, and we can just make it equal to echo this should not be used anymore. So just any value you can think of should go in there. And of course we can call no use without an issue. It will run perfectly fine. This should not be used anymore. But if you were to want to deprecate this, you can add your deprecation right here. However, oftentimes it is highly recommended that if you deprecate something, to provide the user with an alternative if there is one. For example, oftentimes with functions, if it's deprecated, let's say it's a library, you want to redirect the users to the function you want to use. When you don't do this, you kind of force them to go and look for it in your documentation, which many developers are lazy and they will not do, and they will just keep using your deprecated version of your software as well as the deprecated functions because they're just too lazy to go find it themselves. But you can specify what they should be doing instead by going use my func instead. And now you're telling them when they hover over it, hey, this is deprecated. And my bad, I forgot to put a colon there, so deprecated colon. Now you're telling them, hey, this is deprecated, but you can use my func instead. Now instead of having to go all the way and search through things, they could just know, okay, I would instead use my func. Then they call my func instead, which is not deprecated. So this is the recommended way to handle deprecations. It is to give either a reason for its deprecation, or even better, an alternative to use instead of this. And of course, again, this will compile just fine. It won't throw any errors. All right. So let's say we have a calculation program, so procedure calc1. Calc1 takes in an x and a y value. It returns an int. And then, of course, we can just return x plus y. Now, if we were to call calc1, 10.1, and we can even echo that, it will run perfectly fine as normal. However, this right here has no side effects. Now, what exactly is no side effects? Pretty much a no side effect procedure, or in Nim's case a function, is that when its output only depends on its input, which also means it does not modify or access anything out of its scope. And as a refresher, this is its scope. Everything indented inside of it is its scope. So if I were to say, let x is equal to 10, or maybe not x, let's go z, and I were to use z in here for whatever reason, then this now has a side effect because it affects something outside of its scope. Another side effect is also input-output operations. This includes printing, reading files, and modifying global variables. Again, nothing outside of its scope should be modified. And if we go echo here, then this is also considered a side effect. So let's say we want to make this a no side effect. In this case, we can just go here and say no side effect. Now this will complain because we have multiple side effects currently happening. Echo, this right here is a side effect. So it says, hey, calc1 calls no side effect, or calc1 calls a side effect, echo, because this is marked as a side effect. Remove that. But still we have another one. If you hover over here, calc1 accesses global state z, which is also considered a side effect. So we remove that. Now we have a procedure that has no side effects. It is as pure as it can get. Now Nim knows that a lot of people prefer no side effects in their code whenever possible. So they provided us with the func keyword. That's why there's a difference between func and procedure in them. Even though I use them interchangeably, I should actually most of the time be saying procedure and not function, because a function is a procedure without any side effects. So it does not need this right here because it is already no side effect. So if I say echo test, it's going to complain because echo is a side effect. So it's somewhat of a syntactic sugar to just get rid of that pragma, which it now provides automatically. So you get rid of that no side effect pragma that you have to type out the whole time. Now, let's say for interest's sake, you do in fact want to use a side effect inside of your no side effect procedure. Let's say a good reason for this would be debugging. That you could provide a cast and just insert no side effect. This means for the next line, just ignore side effects. So echo, this can now run. And of course we need a colon, otherwise it wouldn't quite work right. There we go. So now we are casting the no side effect here. So we're saying, hey, okay, for the next line, just ignore it. This is great if you want to do some debugging, because if I were to now run this, it can say, hey, this can now run, and it still gives us our output. However, this again has its time and place. This does negate a ton of things Nim does in the background, so you don't really want to use this too often. So this should pretty much just be used in case you have a no side effect thing and you just need to quickly add a side effect for whatever reason. Next up, let's go and create a procedure, and let's call it warning. Warning will just echo out, hello, warning ahead. That is nothing too complex. If we call warning, there we go. If you run it, it runs like a normal program. Perfect. Now we can add a pragma here that will show a warning during compile time. It will not stop the compilation or anything. It will just simply show a warning. So if we go here, warning, this is a warning. And if you don't call warning, it will still warning us. So if we will go here, I'll just put hints off so we don't get all of that other stuff. It will actually say warning, this is a warning. So this will run even if you don't call the procedure. So during compile time, if it sees this warning, it's going to throw it. So take note that this can be confusing. So if you were to say this function is very slow and you run this, people won't really know what you're talking about unless they go to this line and column. So just take note that it can be somewhat confusing, so just make sure to specify what you're throwing a warning about. And of course you can still call it, it won't give any errors, it will still run perfectly fine. Similarly, you can have hints. So if we go here, hint using warning is kinda confusing. And they should not be hit, they should be hint. Alright, if we run this, we'll see we actually don't get the hint because we turned off hints. So to see the hint, we will need to turn on hints. So if we take a look here, let's compile it back. Actually, let's remove the hints thing entirely. There we go. Now we get the warning as well as the hint that we provided. So using warning is kind of confusing. And in here, the function is very slow. So you can do this to maybe give whoever's compiling this some information they might be interested in hearing. Alright, so now let's create another calc. Again, it will just take an x and y, which are both int, return an int, and then of course return x plus y. If we echo out calc, again it will work as expected. There we go, free. Alright, now let's say that you do not want people calling this function. Similar to deprecated, but you want it to be more strict. So you want them to go, okay, we are not going to let you run this function. This function should not be called. What you could do is you could go error. Now, note that this function can still be compiled. If we were to do this, as you can see, it still compiles. But the second we try to run this function or procedure, then we actually get an error. Usage of calc is an error defined at and wherever. So this will actually give us an error when we try and run this. So take note, when you provide an error, it can still compile the program and it can still run the program. But the second you call that procedure, it will end the program. So just take note of that. And by end, I mean it won't compile it. So just take note, it doesn't stop compiling unless you call it. Now, if you are really serious about something just not being used or being done, you can, instead of going error, go fatal. This is not good. There we go. Now what fatal will do, as you can see, is already giving us a big red here. Fatal will make sure the program does not compile at all while this fatal is in there. So when we try and run this, we're going to get a fatal error. This is not good. So fatal, unlike error, error will still compile fine. It's only when you call it where it will throw an error. Fatal will never compile. It will just say no way. Now you might be wondering, okay, but if I can't compile my program anyways, what is the point of fatal? Now fatal is good for compile time checking. For example, when nim major, which is the major version of nim, so if I were to go nim -- version, you'll notice I have nim major version 2, minor version 2, so 2.2.0. So when nim major is less than, let's say, 3, we can fatal, you need a higher version of nim. Maybe when you actually code something like this, just make sure to specify what version of nim. You'll see we get this fatal, and if we try and compile it, we get that error. And this should have a colon, my bad. There we go. However, if we were to make this less than 2, you'll notice the error actually disappears and the program can compile and echo hello, run without any issues. So this right here is a compile time check to make sure, hey, do you have the right nim version to even run this project? If you don't, throw an error. You can even go, if you need a really specific one, nim major, if that is equal to 2, and nim minor is less than 2. So if nim is version 2, but the minor version is also important, you can say if it's less than this version here, also throw an error. So if I were to go 3, we'll get an error because I have nim version 2.2. So I'll need nim version 2.3 to run this piece of code. Run this, we get an error. If we do this, we don't get an error. This has other useful use cases as well for, let's say, const use advanced feature. Let's go there. And this is equal to true. So let's say they try and compile the program when not use advanced feature. So if this is false, then we want to just go fatal. This feature must be compiled. Must be true to compile. And again, we can echo without any issue. If we run this, it goes perfectly fine. But if we make this false, and this when is it during compile time check, then here we go and get that error. Fatal has its time and place. However, you should not be trying to use it for runtime errors. For example, a division by 0 is a runtime error. If the user inputs 1 and 0, or even the developer, and it compiles and runs that, that's a runtime error. A compile time error is when we compile the program, not while the program is running. So best use is to just use fatal for compile time errors. For runtime errors, you can use raise, which we'll get to in a future video. Raise pretty much just raises an error during runtime. So generally, it is fine to just use echo and echo out, hello world, or whatever logs you may want to do. The only issue with this is you don't have things like leveling. For example, is this an information level? Is it a debug level? Is it an error level log? We need to know. It also doesn't come with any nice features such as automatically writing to a file instead of console logging to the console. And tiny things like that. And that is where the library import std/logging
comes into play. Logging allows us to take logging to the next level. So first we need to define a logger, and this logger will be new console logger. Alternatively, you could use file logger instead of console logger to log to a file, but we'll get to that later. Now that we have a logger, whenever we want to log, we simply go logger.log. We specify the log level. So this would be what type of danger level is it? Whereas something like LVL info would be, okay, it's a level 1. It's something you might want to know. It's not really that important. And now we can say, now connecting to YouTube. So if we're making let's say a YouTube video downloader, then this could be a info log that says, hey, we are just simply connecting to YouTube. And then of course, if we run this, it defines what level the log is, and then afterwards it prints out what the log itself is. Info level logs is useful when you want to provide context for the application. So in case that an error occurs, having info logs to say what happened before that error occurred may help. Now you do get more levels here, for example, LVL error, and this is of course if an error happened, not necessarily if the program stopped running, but just if an error happened in the program. You have LVL fatal, which is probably the worst case scenario, is where an error so bad happened it pretty much stopped the program from running. It's a fatal error. You have LVL warn, which is a little bit less harsh, so if it's not necessarily an error, but it's something you should know about. For example, someone's using a flag that will be deprecated, then you give them a warning level and say, hey, you just used a flag that said --hint, which is not really allowed. If we take a look at Nim actually, and we compile this with and show the hint, you'll notice here we get hints. This could be things like info level logging here, because it provides you with extra information. And then finally, you also have LVL debug. This is usually just a flag you'd see if you're a developer. You don't really want to show debug logs to the user, because upon release, debug logs generally don't get shown. And the reason is, usually when you do debugging, if you go if not defined, as we'll check if release is defined. Now release here pretty much says whether or not this is a release build of the application. So we are debugging production applications should not see this message. So in case that this is a debug build of the program, so not an official release build, we should be able to see this. We can confirm that because if we run this, we get a debug, we are debugging. However, if we do this, but then we add a release flag here, so -d:\release, then we don't get it. Even though the application is running, if I go here and say echo hello world, we can confirm that the application is in fact running, but it's not showing this debug level log because we're checking if it's been released. Now that we have the basics out of the way, let's define our file logger. So this one will specifically look at logging to files. There will be new file logger, and it will save it to errors.log. So a new file will be generated here called errors.log. And then the level threshold will be equal to LVL error. This level threshold will define what actually gets written to the file logger. Because we don't always want to log everything to a file, because that will just clutter up the file with information we may not need. This includes info and debug level file logging. But things like an error and a fatal error would be logged because we are specifically looking for that in the errors.log file. To test this out, we can go file logger.log LVL info. So this is an info level log. Let's just say now connecting to YouTube. And let's add a couple more here. Here we go. So we have an info level log, a debug level log, an error level log, and a fatal error level log. Now when we run this program, that doesn't need to be in release mode, but that's fine. If we take a look at our files, we have an errors.log file now. If we take a look inside that, we see error and fatal, but we do not see info and debug because our level threshold is only from error and above. So they will not show here. And of course, you can use common sense to know what level a threshold is. For example, a fatal error would of course be worse than an error because a fatal error would stop the program, where an error would just say, hey, something's wrong. That's where this level threshold goes. That also means that warn would not be displayed here. So if we just duplicate that debug there and say LVL warn, because by common sense we can know that a warning is not nearly as bad as an actual error. So if we run this, we take a look at our logs, note they added new ones to the bottom or to the top, and there is no warning here. Now you might already be thinking, okay, this is great and all, but it's kind of cumbersome to write any of this, because that's a lot of typing just for a log when I could just use echo. And you are right. That is why we have add handler. This adds handlers to logs to make them feel less cumbersome. For example, logger. And we can also add another one, add handler file logger. Now, both of these will be triggered at the same time. So take note of that. Both of these handlers will be triggered when we make a log. So if you don't want logs to display in the console, just don't add the top logger. If you don't want logs to be saved to a file, don't display that logger. As simple as that. So by adding both of them will be triggered once we call for a log. And to call for a log, we can either go log and specify the level, so LVL error, and specify some error. Now, of course, if we were to run this, and let's just remove that release mode there, we get error, some error, but it will also display it in errors.log right there. However, you can also now use keywords such as error, another error, or info, nothing of interest, or debug, developer note. Now, if we run this, all three of them does get displayed here, and in the errors.log, only the ones that are valid, defined by the level threshold, will be shown in the errors log. But there it is, another error. So take note, if you remove this threshold here, and you run this program again, then all of them will be displayed here. So take note that this handler still complies with any arguments that you pass into the original logger. You could also remove handler and then pass in, let's say, logger, and that will no longer log to the system. It will only log to the file. So if I put a fatal here, only in file, and run this, we will not get that fatal log, but it will appear inside of our errors.log. Now this new console logger, as well as the file logger, can both be updated to contain formats. So if empty string, and this will format it for us in a way that we can use. For example, let's say we want to specify the time it happened, because that could be very important, as well as specify the error level, or the log level rather, and in colon space, and after that it will automatically add the log that has been provided. I'm just going to expand this a little bit. Now if we run this, you'll notice we get a timestamp, so it's currently 8:05:40, the level, and then the log itself. And again, if you wanted to, you could pass this format string into this file logger as well, because currently it does not contain it. But you could pass it in there as well. Now if you run it, the files will also contain these extra information. Now there's a couple things you can do here. Instead of just time and level name, you do have options such as date. Just take note of the dollar symbol. You always need to add a dollar here to escape it. So there's dollar date, date time if you want the date and the time, app. So let's actually use them. So let's go here and say date, and here we can say app, and then let's go app name, app directory, the level ID, which is the first letter of the log level. So you might actually, let's put that there at the top, and then there we go. Now if you were to run this, we'll get a lot more information when we take a look at our logs. So first here we get our error level, and there's a fatal error. We get our date. Here we get the file. So if we go take a look here, that is the app. Then colon, and then we get the app name itself, which is just main. That's right there, main. And we can confirm this is correct because if I go pwd, there we go, home netsu documents tuts nem. Home netsu documents tuts nem, and then there's main. And in here we have the app there. And if we take a look there, there's the app there, which is pretty much the same as the app, but just excluding the app name itself. However, if you don't really know how your log should look, it is perfectly fine to also use verbose fmt string. This is one that's already built into Nim that will help us with this. So let's just make this lvl info so we get more information in the logs. Now if we run this, it will automatically format this for us. So if we go to errors.log, you'll see here we get I, comma, the date and time, the name of the executable, and then what's what. So this is automatically something you can use if you don't want to write this out yourself. Verbose fmt string. For more information about where this is actually being logged to, and I'm just going to comment this out right now so we don't get too much information. You can use echo default file name, and that will give you where logs will be written to. And the reason we get main.log here is because that's the default file name. So if we were to just remove that, it will save it to main.log instead of errors.log, as you can see there. So if you did not specify a name here, then this will provide us with the default name. You can also get the log filter, and this will get the level at which logs will be logged at. In this case, just LVL all, meaning all the logs we put here will be logged. Whether it is info, whether it's warning, error, it will be logged. Of course, we change it by setting this threshold right there. However, we can change this default one as well by going set log filter level LVL. Of course, you did not need to specify level. You could have just gone LVL debug. That would have been fine as well. But now if we run this, we get LVL debug. Or if you use level to specify the level, then you'll get the same output. Now it will only display logs that are at that level. But let's go error just so we can see it in action. So now if we were to uncomment this, we were to run this, and my bad, I did not focus there. Let's try again. You'll notice we only received the error here and not the info or debug. And this fatal here only happens in the file itself. So we won't see that. So by doing this, you can set them all pretty much to be error level or higher. And then finally, now we run into possibly a new issue. You don't always want to just add more and more logs to your logging file. You might want to cap each logging file to only have about 200 lines of logs in it before you might want to create a new logging file and move the old one as an old logging file. Nim has a built-in way to do this by just going new rolling file logger. So if we were to just remove all of the other things we do not use and we clean this up, then let's put this inside of a rolling, and we can set the max lines each file is allowed to contain to 5. Now, if we were to just update this, then here we go. So now we have 7 logs, but each file is only allowed to contain up to 5 logs. So it will create 2 files for us, one with 5 logs in it, and then another one with only 2 logs in it. So when we run the program, we get rolling log and rolling log.1. .1 is the oldest one at the moment, so here we have 5, and then rolling.log will contain the last 2. This way you can keep your log files small, and then later on check if you have maybe too many, and then just remove the ones that you don't want. So Nimble is Nim's package manager, similar to how you have npm with JavaScript, Cargo with Rust, or PDM with Python. Nimble allows you to create your project and then manage all of its dependencies and all of its run tasks. So let's start by initiating a project. So you can go Nimble init, Now if you do this, it will initiate a project in this directory. In our case, it is not fine because our directory name is nim. Now the big issue with nim is if you create a project called nim, and nim depends on a package called nim, then you have a circular dependency which it wouldn't know how to manage. So in our case, I'm going to give it a name, but if your folder name is not called nim, this is fine. I'm going to call it project, and it's going to initiate a project called project. They will ask us, do we want to create a library, a binary, or a hybrid? And I forgot to mention, you don't need to install Nimble, it comes packaged with Nim. Anyways, a library pretty much just provides functionality to other packages. So if you just want to be a support, you go library. Binary is a executable, so that is a standalone package. And in a hybrid is a mix of a library and a binary. For simplicity's sake, we're going to go binary because we don't want all of the other jazz. Then here, ask you for the initial version, just say okay. What is the package description? This could be Nimble example. It asks you, what license do you want for your code here? Your license may not be here that you want, so you could go other. Or if you don't want to give it a license, you can go proprietary. I'm going to go MIT because that is one of the simplest and easiest licenses there is. Pretty much says anyone can use the code. Just please don't blame me if something goes wrong. That's MIT for you. Then they ask you, what version of Nim do you want to support? So in our case, the lowest version of Nim is probably the version of Nim we have installed. I'm just going to say I'm okay with that, but you might want to change this depending on what your goal is. And here we go. That created a new folder called project. And in here we have a project.nimble file, a source folder, and a project.nim. Now our project.nimble file is pretty much just our package.json if you're coming from JavaScript. It contains our package version. It contains our author, so who made this. It contains a description, the license it uses. However, if you put your license in here, I recommend creating a new license file and actually putting your license in here, just so everybody knows where to find your actual license. You have a source directory, and it's just this folder right here. That's where all of your source code goes. And then a binary. That is the name of the binary that this project will run. And in here it says it requires Nim of version 2.2.4 at least. So first of all, you want to check that everything in your project is configured correctly. You can do that by going nimble check. This will just go and say, oh wait, let me just go into project. My bad, because you can only run nimble check in a place that actually has a nimble file. In this case, this one doesn't have any nimble file, so I had to go into project itself. So you go nimble check, and there we go. So it says everything is valid, that's good. To know if it works, you could just go boink like that. Now it will be, hey, something's wrong, that is not allowed. So we just simply remove that and nimble check will work as expected again. Now nimble also gives you an easy way to build your project. So just nimble build, and you just build your project, and there's an executable. You just go project like that, and Bob's your uncle, hello world, which is sit in here. You can also go nimble run. This should build and run your project, but I think this version of Nimble has a bug where it simply doesn't do that. But in theory, Nimble run should both compile and then run your project, similar to how we did it with nim c-r main.nim. That's pretty much the longer hand of it. You can also compile your source code using different engines. For example, by default, it's going to do it using the C backend. But if you want to compile it using C++, you can go nimble cpp, and then you need to specify the file specifically. You cannot compile everything at once, so you need to go source and then project.nim. And that will give us an executable here, which has been compiled using the C++ backend. Same with JavaScript, you could just go JS, and that will give us a JavaScript file, which is the compiled version of this file right here. You can confirm both of them work by going into your source file and then just running project, that works fine, or going node, if you have Node.js installed, project.js, and there we go. Both of them seem to work fine. So if you want to compile using different backends, you can. Now, I'm going to pretty much skip over this part of the tutorial because Nimble is a little bit buggy, it seems. But pretty much you can also create tasks. This is maybe, let's say you want to run tests. These tasks will allow you to run it. It's almost like if you come from JavaScript, you could go npm run dev to run a specific development command. In this case, we'd have Nimble and then hello. So it's task, the task name, the description of the task, and then what it does. This is kind of like a little bit of Nim script, which is a scripting language that uses Nim. Now if we just run that, and not Noble of course, Nimble, then generally it should actually be executing this, but I think there's an issue with compiling and running in Nimble at the moment at the same time, so it should be printing out hello world. Similarly, you have before and after, so you could create a task and say before that task this should run, and after that task this should run. So this could maybe clean up. So let's say you did a bunch of compiling and testing, then this could clean it up and just maybe remove all of those extra files it generated, and this one could maybe prepare so this task could run. Again, it should actually work, but because of Nimble it's just saying working, it's not actually doing anything else. So this was before, this right there, then there's working here, that is this actual task running, and then this last working would have been the after hello. But on a day that Nimble is not as busted as it is today, then that should work. Alright, so we have just gone through pretty much most of the basics of Nimble. Let's get to the actual fun part of Nimble. In this tutorial, we'll actually be taking a look at how we can set up a user interface in Nim, because that's one of the most fun parts of learning how to use a package manager. Because in Nim, not easily doable, but if you install a package to do it for you, it is. In our case, we'll be using nimx. Nimx is what you use to create a user interface in Nim. Take note, however, that this may not work in a future version of the tutorial. So if you're maybe, let's say 5 years from now watching this tutorial and you're having issues, simply use a different package. The tutorial will pretty much stay the same, the concepts at least, whilst the package itself may not work. This is unfortunately the volatile nature of Nim, where a lot of things unfortunately get deprecated because of the development cycle. So there are two ways to search for your packages. The first one is going Nimble search nimx. This will search through your packages. So here you'll see we have nimx. There's a URL to its GitHub. There's its tag, so it's a GUI, UI, and library. Its description is a cross-platform GUI framework. It has an MIT license, and then of course its website. Then here you have WI nimx or WinImx, whatever, and that is a minified code generator, I guess. And here we have nimx too. So we'll just be going with nimx here. Take note, however, you could also use your browser and go to nimble.directory and just search for the package. In this case, there's nimx. It seems to be trending now that I clicked on it once for the tutorial. But here we have nimx. You also have Carax, which is kind of cool. It's a framework for developing single-page applications in Nim, almost like React in JavaScript. But nimx, that's what we want. Then here's the code to install it. But I'd recommend against this because Nimble does not automatically add the dependency to your project. So this will install it to your system, but not add it as a dependency to your project, causing a lot of confusion later on during development. So what I would rather recommend is you go to the project website, which is the GitHub, go into the nimx.nimble or whatever the project's name is and just .nimble, and then take a look at that version. Then we go back here to where our code base is and we say requires nimx, and then we specify version 0.3 or 0.2 or 0.1. So this will just specify what version we should be downloading and what is allowed to be used. When you build your project, Nimble will automatically install any missing dependencies. So you'll notice if we go Nimble build right now, it will start downloading that dependency. This may take a while on your end. On my end, it is cached, so it should be relatively fast, but on your end, this may take a while. In this case, you can see I had nimx 0.2 installed, so it's just ignoring that because now we want 0.3. And there we go, it built the project. If we go project, nothing's going to change, but now we have this dependency installed. So you could use nimble install nimx, or even nimx at 0.3 for a specific version, or at head to get the latest version from GitHub. And that should be at #head, not just at head. But I don't recommend doing this unless you have specific reasons for it, mainly because Nimble does not support simply adding the dependency to your project yet. So I rather recommend you just simply add it right there. Now that we have this dependency installed, we can actually use it in our code base. Note all our code will be going into this source directory. And first we want to import a couple of nimx dependencies. So import nimx/window and import nimx/text field. Let's create a procedure called start application. And while we're at it, let's also import nimx/layout. Now because it's so many, you could actually simply put them all like this. There we go. Then here we can go and create a new window. So var wnd is equal to a new window. And take note that if you're watching this in the future, the code may be a little bit different, because even from me just writing the tutorial or scripting the tutorial to right now, a lot of things change, so there's a little bit of script as well. Then here we have new rectangle, where we have a 40 for the X position of the window, 40 for the Y position, 800 for the height, and let's go 600, this is a width and this is height, so 800 for the width, 600 for the height. Then we have wnd.makeLayout. This will create a layout for us. And we can specify, we want a label. And we can specify frame. And then text, hello world. Now in here, we can just simply run Nimble build. If you get red squiggly lines once you save, just go take a look at the documentation. The documentation itself is on their GitHub. Alright, so it has built successfully. Now you can run that project, and here we go. Now this window may be a little bit wonky on my system because I use a window manager, but there we go. If you want to change the width and the height, you could. So we could go maybe 1280 by 720 and maybe 500 by 100. Now if we were to build and run that, and usually we use nim run or nimble run, but in this case it's a little bit busted, so we're just going to skip that. And here we go. You'll also notice that its default position has changed, as well as its width and its height. So that's a basic way to actually install the package and then use it here in your project. Now to simplify this whole thing, pretty much let's say you have a C++ file, and let's actually bring that over here. This C++ file has a sum CPP, which takes in two values and then it returns a value, and a speak CPP, which just console logs we say and then whatever is here. Now, this is pretty awesome because if you have a library you might want to interop with in Nim, you can, because you can simply now just call their functions in Nim. Now, Nim allows you to interface with C, C++, Objective-C, and JavaScript, so you can use all of those with Nim pretty much out of the box. However, note that JavaScript interfacing cannot be mixed with C, C++, or Objective-C, because C, C++, and Objective-C are all backwards compatible, whilst JavaScript is a whole different language. So you might remember that if you want to compile to JavaScript, it's nim.js main.nim. That compiles to JavaScript. However, to compile to C++, you'll need CPP. But C, C++, and OC are pretty much all going to compile down to the same thing, while JavaScript will compile down to a language. So just take note that whilst you can use C and C++ together inside of the same Nim program, you cannot do it with JavaScript. So let's start off simple before we actually move on to calling stuff from the file. So we start off by going procedure printf. So we want to call printf from C. We have format, which is the C string. We specify a C string instead of a regular string because it will require you to pass in a C type string. And it returns a C int. And then we just need to specify import C, var args, header, which is stdio.h. Now stdio is pretty much one of C's libraries. This header file here could kind of also be the method C++ file we have here. It's the same thing, so methods cpp. The only difference is method cpp isn't provided by default when you have like C or C++ installed, where stdio.h is provided by default with C. It's one of its standard libraries. And then we just specify discardable, so we can discard it. Let's just maybe make it a little bit smaller so it fits better on one line. Now, one reason you should take note of why this is a C string and not a regular nim string is because in C, you actually have const char asterisk. So this right here is what a string is in C. So we don't have the usual string like we'd have in other languages. It is this round right here. That is why we specify C string, because it is unique to C. So let's actually use this by going print. So now we're calling this we just defined, which is getting it from stdio. And we say my name is %s and I am %d years old. And you just add a \n so it goes to the next line. Then you can specify Jack as well as 25. Now if we run this, nimc main.nim, let's just put a dash order so it auto runs as well. Bring this up. We get my name is Jack and I am 25 years old. But if this was just a regular string, you'd notice we don't actually even get an output here, and we actually did this time get an error. And it is really as simple as that to call a function from C. Now note that this right here is only really important when we don't specify what we're trying to call. For example, if we specified import C, printf, then we don't need to call this printf, we can just call this C echo, and it will still work perfectly fine. But if we do not specify that right there, then it won't know which function to actually get, and it will just throw you an error. So by specifying the actual function here, you can call it whatever you want to make it simple for you. And because it is discardable, if you want to, you can discard this, because this will actually return an integer or a C int. So if you don't want the value, you can simply discard it. Alright, so now let's try and use one of the methods from here with what we just learned. So let's start off with speak, because I think this one will be a little bit easier. So let's go here and we can actually, so we have reference, throw that on the side. We go and define a procedure, call it speak. We specify a name, which is the value right there, and that will be of type C string. Then we provide an import cpp, which is speak cpp. So that would be the one right there. And we have a header which contains the file. Now note, if you are using C++ and you have a header file, we currently don't actually have a header file, we just have a C++ file, then this will need to be the header file and not the C++ file. But because we don't have a header file, we're just using the C++ file, we can just specify C++ methods. And just note here, you want to go like that, so you can specify the values we pass in here is the values that's going on in here. Now that we have that, we can simply call speak rock and roll. Now when we run this, oh, and we got an error because I ran it with C, we need to specify cpp, and it works perfectly fine. Note, if it turns out that you still want to use C in your code, you can still do it by, let's go like that. It's the same code we had, it's just from the actual lesson. It will still work perfectly fine, so you can still use C stuff inside of a C++ compiled program, just so you know. And there we go, so we say rock and roll. Now let's move on to this sum CPP here.
So we go procedure, sum CPP, just calling it the same, just so we have a fun example to work with. We have int x, int y, and then it returns a cint. And in here we have import CPP, and we specify some CPP at that. Now that we have that, we can say let res, which will type int, and if we want to convert the cint into an int, we just specify int, and we say sum CPP 10 and 15, and then we can just echo out result $res. And my bad again, working with two languages makes me a little confused. just swap that around like that. And now if we run this and specify CPP, then we get 25. And if you were to specify cints here, it would work perfectly fine. In this case, switching between them doesn't really change anything, including with the last int right here. So you can easily switch between them in this case because it's not using a cint, it's more closer to a regular int. However, it is still safer to always instead specify cint because they can work with each other, but it's a little bit safer just to specify the actual type you're looking for. Now, sometimes you want to define a type from C inside of Nim. To do that, you can do something similar to type. We have ctime, which is equal to an int 64. In this case, it's rather simple what its actual type is. Then we go procedure time, pass in our arguments, pointer ctime, and it also returns ctime. This is from import c, header is time.h. However, you might also see some people do this. I've heard this is to specify that you want it from the standard library and not from your local system. However, note if you do have a time.h right here, it will opt to use this time.h instead of the one that is provided by the system. But you might see that just something you might want to take note of. In this case, I'm just going to ignore it, but you might want to you might prefer to use this one. Now that we have that, we can pretty much just echo out time nil, or actually just put this inside of let seconds, and then echo out seconds. Then when we run that, we'll get the amount of seconds as provided by the time method in time.h. Now this is very simple. It's really just very easily mixable with Nim. But what if you had something a little bit more difficult, like the tm method in C? I'm just going to copy this right here, so I don't have to type that whole thing out. The tm method, or the tm type in C, is pretty much a struct that contains all of these values right here. Now, this is when you break it down. So we are going to try and bring this into our Nim code. So let's define a new type, call it tm, and it will immediately import C and struct tm. So that struct I just showed you, we're importing that type here. Then we have our header, which is also from time.h, and this will be of type object because a struct in Nim will simply translate into an object. Then we go tm min, which is cint, tm hour, which is cint, and you can specify the rest of the details as well if you want it. I'm going to skip that for now. Then is define procedure local time, and it will be time ptr ctime, and in return a ptr tm, which also import c header time.h. Alright, now that we have our seconds here already, we can just go let tm is equal to local time. We pass in the address of our seconds, and we just echo out tm.tm hour, put a colon there, and then tm.tm min. And there should be a colon here, my bad. Now that we have that, if we run this, we get 8:13, which if we take a look at the time down here, it is in fact 8:13. So we just brought this whole local time method all the way down from C to be used in our Nim program. So knowing how to use FFI is incredibly powerful. And I'm going to link this in the description as well, because if it was not for this right here, I would not have been able to understand FFI at all. So I highly recommend everyone else should go read this as well if you're more interested in learning about FFI. Now, before we begin, it's a pretty big topic, so I'm just going to link these here. They'll also be in the description. If you want to read more about them, then feel free to go to these links in the description as well. So, most operating systems support multitasking. This is the ability to perform multiple tasks over a certain period of time. Now, a task you'll usually be heard is called a process, which is a computer program being executed. Each CPU can only execute a single process at a time. But multitasking allows the OS to change the process that is currently being executed on the CPU without having to wait for the process to finish executing. For example, let's open up our drawing app here. So let's say you have your program here. Program 1 goes to an internet server and it downloads a page from the website. So let's say it Googles Hello World and it then receives all those results. So it has to go out, do an asynchronous task or whatnot, and then once it does that, it comes back. Then we have the second one. This one here, all it does is it reads a file and returns what's inside of that file. Now let's say we start by running this one first. It's going to start running until it has to wait. Once it has to wait, so let's say it's waiting for Google, it will give the task over to this one right here, because now this one has to wait. So what's the point of continuing this one or having to wait for this one to finish? Now, because this one is waiting, that means this one can now execute. And it can read that file. So read file, and it can show that output. Yeah, I'm going to do that. Let's say that says output. And now it can give it back to this one, which can now, since it has waited in the background, can now continue its own thing. So that's pretty much what is happening here. So instead of doing action 1 and then action 2, we are doing both 1 and 2, not at the same time, but when it is possible to do it. Now this in the background happens so fast, we don't really notice it. But it can definitely increase performance a ton. And this is a very basic, high-level example of what you'll be working with when you're doing threads. And because CPUs are so fast, process 1 here could be executed for like 1 nanosecond. Then while it's waiting, it can switch to executing number 2 here for, let's say, 2 nanoseconds. And then go back to process 1 for another nanosecond. This makes it look like multiple processes are being executed at the same time, even though the CPU can technically only run one at a time. This is called concurrency. Now, this right here is pretty much what's happening in a single core CPU or in a single core of a multi-core CPU. So when you go out and buy a CPU, you'll probably see it has, let's say, 8 cores. This will be happening on one of those 8 cores. So modern CPUs do have multiple cores, where if you're on an older system, you may not have multiple. Now, each of these cores can execute a single task, which means it can actually execute 2 processes at the same time. So whilst this is still valid, if you have multiple cores, you can actually run number 2 here on its own CPU core and number 1 on its own as well. And that is what we call parallelism. Now this is because they are both seemingly running at the same time because each core can work on it. Now something I want you to take a look at is this game right here, Your DOS. This is a pretty fun game where you play as being the operating system. and doing what it is doing with the CPU. I played this game for a short while and I think it is really fun, and it's just something nice as an educational system to know what should be happening right now. So these are like the idle processes, and you're supposed to say which one should be running right now to keep the user happy. It's a very fun game and I do recommend you check it out. The link will also be in the description. Now the operating system also manages threads. A thread is a component of a process. Now, more than one can exist in the same process, and it can be executed concurrently. Now, each process can have threads, but they are going to be running concurrently. And you can imagine a thread almost like a mini process. So something your app is running extra. And this is what we explained here, where you might have a thread that goes to a website, fetches the data, and then comes back. And you might have another thread that goes to a file and then comes back. Now, technically, threads can also be executed in parallel, just like a process. Although, unlike a process, you have to be careful. Threads share resources such as memory and other stuff. That means, let's say you have two threads here. Both of them are accessing the same file to read or to write. Now, if both are writing to that file, how do you know which one to keep? Which of the writings that it added at the same time to that file? Now, most programming languages has a way to lock a thread. So if two things are trying to access the same resource at the same time, one will have to wait. So in short, a process is like an app, and a thread is like a process within a process. You don't want apps to share resources. For example, your password manager shouldn't be sharing its resources with Facebook. Those are two different processes. They should not be sharing that. In threads, however, they both belong to the same process. So number 1 here could have 5 threads, but these threads has nothing to do with number 2 here. As such, they're not sharing resources with each other. They're keeping their resources inside of each other by using threads. Alright, so let's actually get to the coding part, because if all this theory made your head tired, don't worry, I get you, bro. So let's first create a process, call it show data. This process uses a Pragma thread. In this scenario, thread is an optional Pragma, but it is considered good practice to use it. And all this simply does is echo out data. That data itself is simply a variable that has the text data. Now, first thing you'll notice is you'll get a red squiggly line, and when you hover over it, it says show data is not GC safe, as it accesses data which is a global using GC memory. Now you might be wondering, what is GC supposed to mean? Now, GC just means garbage collector. In languages like C and C++, you would often have to manage memory, aka RAM, yourself. You'll have to delete stuff from the RAM, and you'll have to add stuff to the RAM. You'll have to do all that yourself, and eventually you'll shoot yourself in the foot. That is why these days you have a garbage collector, that once something goes out of scope or doesn't need to be in the RAM anymore, it will automatically delete it on the developer's behalf. Now, garbage collector safety in Nim has an important distinction between the way threads work in Nim and in most other programming languages. Each of Nim's threads has its own isolated memory heap. Sharing memory between threads is restricted, which helps prevent race conditions and improve efficiency. Now, a race condition is when multiple threads tries to access the same data at the same time. So that example we gave you before, where pretty much two threads try to access the same file and write to that same file, there would be an issue, because how do you know which one should be writing at that moment if both of them are trying to write at the same time? That is a race condition. So if some of them wants to, let's say, modify that data and other were not ready for it, it may result in incorrect results. Now, in short, all I'm trying to say here is the above code pretty much fails, because we are not allowed to access the data variable when running a thread, because this is not part of this thread. So it's going to say, hey, don't do that. So to fix this issue, what you should instead be doing is specifying you want to take in data, which is of course a type string. Now it's a little bit more chill with it, because now we're saying, hey, this is its own thing. Don't try and access the thing right here, just access this. Now, let's say we go var thread, so that's where we define the thread, which is a thread of string. Now here we can actually create the thread by going create thread. We specify string right here, and we specify the thread we want to attach it to, so this one right here. We specify the thing that will be running in this thread, so show data, and we specify the thing we're going to be passing in, so these variables right here. Pass that in data. So there's data up here, so let's call this global data just to make it simpler. Global data. So we're passing in global data here where data is. And then finally at the end we say join threads. Now what join threads is going to do is it's going to take all the threads and it's going to join them together to very much say, hey, wait for these threads to finish. Now to run this, you'll need to go nim -- threads on, and then we're going to specify compile and run, and with threads on. When you run that, you'll get data. So that's just all it's putting out here. You can of course change this to is cool. If we try to run that, we get data is cool. Now you might be wondering, what exactly is this string here? So the string is the data we're passing in here. So if this were to be in int instead, you'll actually see we're getting error here because, hey, we can't do that. We're looking for a string here. So now, okay, let's go int. Still gonna give an error because this isn't int, so there we go. That will finally work, where we actually have to pass in global data, but let's say we just do 23, and it should work fine now. But now you might be wondering, okay, but what if we have multiple things we want to pass into this thread here? Because oftentimes a function will have 2 or 3 arguments, not just one. In that case, you can create a type. Let's call it thread data. It is a tuple with param1 being a string and param2 being an int. Then this data here, that will now be the thread data. So now we're taking in a thread data instead of a string. Meaning all we need to do is just update this to be thread data and this to be thread data as well. And in here where we pass in that value, we go here and say param1, and we do that. And then param2, we can say 5. Now of course here we actually still need to work with that data. So we could of course just go data.param1 and then data.param2. And as simple as that, you can pass in multiple data types. So now if we go like that, data is cool : 5. So you can pass in multiple parameters by just making your own little type here. Or of course you could specify each and every one, but that's going to be pretty darn annoying to do. So let's just specify our thread data like that. Now you might be wondering, okay, this is nice and all, but I still can't really see myself using this. How is there a benefit to this? And that is where we get started with actually using this. So let's create a procedure. We can call it say hi, and it takes in a number, which is an int. And this is of course thread. Now let's say this takes a while to go. So os.sleep, and we just import std/os. So os.sleep, and let's say it takes a full second to run this command. Hi from, and then of course we can just specify that number. So this right here, you can imagine it's Googling something, it's reading a file, it's doing something that's going to take it a full second to run. Now, usually when you'd have it like this, and let's say you you need to run it 5 times. So for I in 0 to 5, you do say hi. And let's just pass in I there. Now when we run this, gonna go 0, 1, 2, 3, 4, 5. It's gonna take a really long time to get to the end. And all it had to do was run 5 times, something that's just gonna take a while to run. Now we're going to convert this to a thread. So let's just remove that part there. Variable threads, which is an array. 10 thread int. Now right here we're saying, hey, this array may have up to 10 threads inside of it. And here we can go for I in threads.low to threads.high. Do the following. Create thread, and this we're pretty much just going through all of these items in the array. We're creating 10 threads doing the same thing, so it's just an efficient way of creating threads. We then say thread at index I. We say it should be doing say hi, and we just specify the number that should be passed in. You might be wondering, but hey, why aren't you specifying int here? That's because you don't really need to. It can infer it on its own, so I'm just not going to do that. So it's an optional extra if you wanted to. And in here you can just say join threads, where pretty much you're just waiting for all the threads to end. Alright, so now let's give it a run and see how it goes. So here we go, boom, all at once. Now this is even better because unlike when we were here beforehand, where we had just a for loop, where we had to wait for every single one, here they all finish at pretty much the same time. Because of course all of them take the same amount of time to sleep. And if you wanted to test that, you could just go import random, just randomize. And in here, you could just say rand 1, 2, 3 and just times that by 1000. Now, when you run this, you actually see some of them come out at the same time, others come earlier. This is because you're waiting for each one between 1 and 3 seconds to execute, and it will just give you the first one that finishes, and here at join threads, it will wait. The reason we use join threads is, let's say here, we echo out. Here we use data from threads. Now you'll notice when we run this, it's first going to execute all of those threads before it tries and use that. Otherwise, if you go here and say echo, let me just go like that, echo still in thread, you'll notice we get still in thread and then all of the threads execute. Now this might already be clicking for you that this is very similar to async await, where you declare something that is asynchronous, you run it, and then only await it down here. Very similar process, so you might be, excuse my JavaScript, this is on the dot. So data is equal to fetch data. Then instead of awaiting it here and getting that data immediately, you first do other stuff. And then only once you need that data, you do in const result is equal to await data, where you now await the data that's inside of here. So it's pretty much the same, where the rest of the program doesn't continue until this await is hit. That's what join threads is doing. It's just telling the threads, hey, you guys just finish up here. Alright, and now I want to show you. And that's it. That is pretty much threads and how you use them in Nim. Now, I'm going to cut out a couple extra things here that was originally part of this tutorial, mostly because, first of all, time constraints, and second of all, deprecation. So the first thing that unfortunately was removed is thread pools. Now you might be wondering what's a thread pool and what makes it better than a thread. Now first of all, let's just remove these randoms here so we can have a nice clean, there we go. So like this, you usually have threads, but with a thread pool, you can just do this, where you just say, hey, can you spawn this thread? And in here you just sync it. So it's the same thing, but it's just a little cleaner to write. However, you'll notice it is in fact deprecated, and you should be using Malbolgia, task pools, or weave, which I wanted to show you. However, both of them are having connection issues, and it's probably because Nimble is possibly down. We also had nice features where here we would download multiple files. So this is a real life almost example, and these files will all be downloaded via threads. So this is a real life example of where threads could be useful, where if someone has enough internet speed, you could like download 3 or 4 things at a time, saving the total amount of time you'll be spending on downloads. If you want to see this in full, you can of course always go to GitHub and just take a look at the actual lesson file itself, which contains everything I'll be skipping out on today. Thank you for watching. I really hope you all enjoyed this journey with me. and I'll see you all again in the next tutorial, whatever that may be.